25,000 miles an hour, and we came down and touched down at about 6 miles an hour with a downrange traverse of about 2 miles an hour. That's walking speed. So that's kind of just an interesting metric for you. We traveled 2.5 times the distance to the lunar surface. That's about 600,000 miles due to the trajectory and the number of orbits that we've gone through. In doing that and in performing that incredible deceleration, our first-of-a-kind liquid oxygen, liquid methane, additively manufactured 3D printed engine burned 6 times for a cumulative burn time of over 20 minutes. It's just an incredible performing machine, and we're really proud to take that technology to a TRL level 9. I got to say something about the team. The ops teams were cool under pressure for the whole 7 days. It was quite amazing to see them in work, real space cowboys. And, you know, we worked through all the difficulties. If you think back from Apollo days, there wasn't one mission that went absolutely perfectly. So you have to be adaptable, you have to be innovative, and you have to persevere. And we persevered right up until the last moments to get this soft touchdown like we wanted to. Let me just talk briefly about attitude on the surface. This is a little lander. I'm going to pretend that's the rock that the lander's leaning on. We think we came down with, like I said, about 6 miles an hour this way and about 2 miles an hour this way, and caught a foot in the surface, and the lander has tipped like this. And we believe this is the orientation of the lander on the moon. We're getting sun moving this way around the lander, so the solar arrays are being powered, and we believe a little later we'll get solar sun on the top deck solar array. The majority of our payloads are all in view, and we are collecting science, and we've collected science along the way to the moon, and I've been downloading that data. In particular, 3 payloads that are positioned on the lander have been operationally used in this mission. The LN1 payload out of Marshall Space Flight Center, it assisted us in determining our precise location in space, orbit determination we call it, using a Doppler measurement. That was very useful, and as it was part of the Deep Space Network, it augmented our communications from our own commercial network. The other one you've heard about was the NASA Doppler Lidar from Langley Research Center, and we integrated their telemetry stream into our navigation application, and we use that for our powered descent initiation. And then finally, the one that was very useful was a new technology out of Glenn Research Center, and that was the radio frequency mass gauging. And that instrument really gave us an understanding of what the propellant tank levels were, which helped us budget the amount of propellant to take us all the way safely to the surface of the moon. So very interesting mission so far. As we get more telemetry and turn more things on, we'll be updating you over the coming days of the analysis and the reconstruction of the landing. Tim can comment on that a little bit today, on how we did the powered descent all the way to the surface and why we believe in the data that I'm talking to you about today. Yesterday we thought, just to clear up some confusion, we thought we were upright. And the reason was that the tanks were reading, this is the X direction, and the tanks were reading gravity on the moon. At the fill levels, there were still residuals in the tank, and we saw those measurements in the X direction. Well, that was stale telemetry, so when we worked through the night to get other telemetry down, we noticed that in the Z direction, this direction, is where we're seeing the residual tank quantities. And so that's what tells us with fairly certain terms the orientation of the vehicle. And hopefully we'll get a picture here this weekend and share it with you. Nilofer, that's all I have.
Thank you so much, Steve. Next up, we have Joel Kearns. Joel?
Hey, thank you, Nilofer. First, let me congratulate Intuitive Machines for 3 major accomplishments. The first, as Steve said, is for having a successful soft landing on the moon by the United States since 1972. The second is for being the first non-government commercial organization to actually touch down safely on the surface of the moon. And the third is for having a touchdown point 80 degrees south latitude, much closer to the south pole of the moon than any earlier U.S. robotic or human explorers. Let me give you some of the context for the importance of Intuitive Machines' accomplishment on their mission. In 2017, the nation charged NASA to expand our scientific and technical work in the area of the moon, science, technology, and human explorers under our Artemis initiative. As part of that, NASA went down the path to listen to what industry had been telling us for some years, which is that for robotic landing services, that we should be able to purchase that from U.S. industry instead of doing it ourselves at NASA for robotic systems. Now, NASA is very good at building and operating robotic probes throughout the solar system, but we knew we'd be going back to the moon repeatedly to do science and technical studies and eventually human exploration. So we put into place this Commercial Lunar Payload Services initiative, or CLPS, to buy, in effect, the service to bring NASA cargo down to the surface of the moon and have the data from those experiments brought back to Earth by industry. Intuitive Machines is one of the participants in that initiative that's now been awarded 3 service contracts to bring NASA equipment, experiments, and cargo down to the surface of the moon. And this was Intuitive Machines' first attempt, their first mission to the moon, carrying our cargo. Now, I have talked about all of the potential advantages of having industry do this for NASA. The industry had told us years ago that they thought they were technically ready to do it, that they thought if they specialized in doing it, that they could probably do it at less cost and much more frequently and much faster from initial order than NASA probably could, since we would normally build a custom spacecraft for every endeavor. And we've seen that so far in the progress that our CLPS vendors have made as they're working down to fly off their first missions. Intuitive Machines, though, however, in doing a soft touchdown on the moon has provided the first real evidence that this is possible to do. It's possible with today's technology, with dedicated engineering and appropriate financial management, to have a private company actually design a spacecraft, develop a mission, buy a rocket, and fly all the way to the moon and soft land on the surface of the moon. Not just in an area where we landed earlier, decades ago, near the equator with the Apollo missions, but in the unusual territory at the South Pole, which is the focus of our future human Artemis missions. This is a gigantic accomplishment. On this particular mission, we had the company bring 6 NASA science and technology experiments on board down to the lunar surface. They ranged to do studies in science, in looking at the electron density and plasma on the surface of the moon, technology studies such as measuring rocket plume impingement during landing, navigation studies on the way to the moon, down to the surface of the moon, laser ranging, fuel quantity, as other investigations. And interesting enough, when we started this, we had put together a list of different instruments and payloads that the Commercial Lunar Payload Services companies could volunteer to take down to the surface of the moon, and Intuitive Machines picked a complement of 5 payloads, which we later augmented with the radio frequency mass gauge fuel measurement experiment. And Intuitive Machines picked a number of payloads and experiments from NASA to bring down, which, as Steve brought out, greatly benefited them during the execution of their mission. So at this point today, as Intuitive Machines looks to make sure they understand the status of the Odysseus vehicle, we are already looking back at scientific and technological data that we accumulated during the transit out to the moon, during the deorbit operations, and we're looking forward to getting even more data as Intuitive Machines finishes the checkout of Odysseus. Now, in doing so, we knew at NASA, when we went out to gather this by commercial services, that we had these great potential benefits, but we also had risks. We knew, for example, no one had previously done this. We knew we were asking industry to do an incredibly difficult thing to do, to go from those high speeds of orbital velocity all the way down to the very slow speeds to get to a particular position on the moon where we wanted them to land. And Intuitive Machines' accomplishment for this actually shows everyone that this approach will work, and we look forward to using it over and over in the future. Nilofer?
Thank you so much, Joel. We'll now hand it over to Tim.
Thank you, Nilofer. Very excited to be here today. They told me to smile before the press conference, and I can't help but smile anyway because we landed on the moon. A little bit about Odysseus. Odysseus is a mostly autonomous vehicle. Our operations crew would monitor the vehicle during flight. We'd provide some trajectory updates and parameter updates, and that's what got us into lunar orbit. The lunar descent is different, though. During orbit, we would prepare for maneuvers, we'd watch the maneuver, and then know that we had time to recover afterwards and replan for the next stage. But lunar-powered descent is the end game. There is no after. You're either successful or you fail. And so the last rev around the moon, we buttoned up any last-minute changes we wanted on the vehicle, and there were a few that we may talk about today. And basically, the vehicle disappeared behind the far side of the moon. We had loss of signal for 25 minutes. Everybody got up and went to the bathroom. There was nothing to do but wait for the signal to come back on. It was amazing how quickly we adapted to continuous communications during transit to regular losses of signal being a part of our life because we're circling the moon. Once we came up around the north pole of the moon, we were in a polar orbit. The vehicle was completely autonomous. We watched as the onboard systems pointed our cameras to the moon. We processed over 10,000 images on board with our own machine learning algorithms to manage the speed of the vehicle. And the guidance system decided, based on the propulsion system, our available thrust levels, orbital velocity, and distance to the target near the South Pole, when the right time to turn the engines were. That's power descent initiation. And the engines came on approximately 13 minutes before landing. We were at full thrust for what we call braking 1. Basically, we were trying to slow down from approximately 3,600 miles per hour to something more like 30 miles per hour near the landing site. That's braking 1. The vehicle performed flawlessly. Our main engine thrust was good. Our thrust control was perfect. Engine performance has exceeded expectations in many ways. And flight control, my personal background, kept the vehicle pointed exactly where it was supposed to go for the entire burn. We monitored down until a pitch over event. So early in the trajectory, the vehicle is basically flying sideways with respect to the moon, and we're flying in one direction, and the engine is slowing us down to take that velocity out of the vehicle. Once we get within a kilometer of the landing site, however, the vehicle goes into what we call a pitch over. And this brings another set of cameras into alignment with the landing site. At that point, we lost comm, which we knew we would do because we switched from one set of antennas to another. And then we regained communications all the way until approximately 200 meters above the landing site. Then there was a tense moment where we did not have regular communications, but our dedicated radio and ground operations crew found the signal, and within an hour or so, we were getting the first data down from the surface of the moon. I could not be prouder of our operations team and our engineers for putting together Odysseus, which was a marvelous machine. And to look at the moon every night now and know that we have new hardware there that we had a hand in building in our lifetime, something I couldn't say before. It really was a magical day. Thank you, Nerf.
Thank you so much, Tim. And now, finally, we'll hand it over to Prasan.
Thank you, Nilofer. First and foremost, congratulations to Intuitive Machines. An amazing, successful landing success story. One of the things that we from a technology and space tech want to do is we want to go repeated access to various parts of the solar system to do this tech demonstration because, in our view, technology drives exploration. And we had a number of experiments on this, technology demonstrations on this lander, and one was called to be used operationally. And I'll talk a little bit about that. But this aspect of a successful landing really allows to, pointing on to what Joel said, is repeated access to the lunar surface. We have a slew of technologies we want to demonstrate, as well as many scientific instruments that we want to send for understanding the lunar environment. And by having a successful story like yesterday that happened, it allows us for setting up the next set of projects that we want to fly and demonstrate, right? One of the things that we wanted to do is trying to do as much as possible testing on the ground, but that only gets us to a certain technology readiness level, which is typically TRL 5, sometimes 6. What that means is we're not quite in the environment that we want to be in, and so this is why we want to go and experiment in space or on the lunar surface, wherever it happens to be. one of the big technology demonstrations on this landing was the Navigation Doppler Lidar. We were hoping through the test of flying on this mission was to get it to TRL-6, which is the relevant environment, the lunar environment. However, with the successful ingestion of it during landing, we were able to get an operational system now, TRL-9, which is it's ready to be used from now on, right, as opposed to further testing. This wasn't totally by accident. The teams at NASA Langley Research Center that helped develop this technology did a lot of development over the years, as well as working with Intuitive Machines to see about ingesting this data if necessary. Fortunately, all that hard work came to bear yesterday when there was a technical issue, and the teams decided that, hey, it was best to try to do the switch and rely on this tech demonstration. Everything we understand from the telemetry we received, which is limited to this point until we get all the data back, that the technology performed flawlessly. Better than expected performance. It acquired range and velocity data well above the required 5 kilometers altitude as it's descending. And the reason why we need this data for a successful landing is as landers come down, we would ideally like to have them come straight down. But because there's errors in all the operations of the system, you wind up being a little bit going laterally going there. This measurement is really to try to get an understanding of that lateral motion so that the system can counteract that and zero out that lateral motion to come down straight down. So you need these type of measurements to make that happen. This is one set of technologies that allows to do that. There are a slew of other ones to make the landings even more reliable and safer that we hope to demonstrate on future landings. And so having this successful landing today allows us to gear up and get ready to do more of this going forward to enable the Artemis endeavor of repeated access to the surface and eventual landing of humans on the surface and sustained presence on the surface with infrastructure laying it down. And so this is the first step in allowing for that, and a great day for allowing us to get ready for more to come as we go forward.
Thank you, Prasan, and thank you to our briefers for those initial remarks. We'll now open it up to questions. Again, if you've joined us on the line today or on our phone bridge, please press *1 to submit your question. Once your name is called, please state to whom you'd like to direct your questions. Once your question has been answered, you will be muted, but if your question has already been answered, you will push *2 to withdraw it. Let's open our phone bridge. First up, we have Gina Sinceri with ABC News. Gina?
I think this question is for either Steve or Tim. What was your Hail Mary moment during that where you went, we think we can make this work, and we just made it work? What were those moments, or were there more than one?
Well, I think there were several of those moments. Like I said, it was a spicy mission. I'll let Tim comment a little bit, but you know, the idea to pull the range telemetry from the NASA Doppler Lidar was interesting, and change out the laser rangefinder call-outs in the navigation application. All that was very straightforward to go calculate. Part of that was put in a table, but part of that had to mean that we had to rewrite the navigation application software. And when you do that, to upload it to the vehicle, you actually have to stop guidance, navigation, and control. And when we ran that in the simulation, and we ran that on the flat sat, it did not like being rebooted like that software. And we saw the guidance drift way off. We saw a lot of helium usage, and that was very sporty. So I think in a very time-crunched time, getting ready for powered descent, we had to work feverishly to get that sequence of events, almost like Fred Hayes in Apollo 13, where trying to figure out the sequence of events to reinitialize the software, in particular reinitialize navigation. And so that was done in a very sporty way, and it was brilliantly executed by the team. And so that was the one that had us all biting our nails just a little bit, because once you start powered descent, there's no going back, like Tim said. Tim, do you have another one?
Yeah, there was, I will say on that one, a parallel effort for sure. So we had one team rewriting the code, we had one team testing procedures, and then another team, once the code was written, pushing it up on the vehicle, moving it into place. That synchronization came down to a flawlessly executed reboot of the navigation system that allowed us to successfully land. So that was exciting. Another exciting moment we had after our TCM-1, our trajectory correction maneuver, we discovered that our engine pointing geometry had an error in it. And we had to study that a bit, and we found the reason why. We had a geometry linkage that was a little bit different than we expected. Very difficult to test how that linkage to the main gimbal would respond under full thrust in space. And so we were able to use flight data to correct that. But that was another area where we had to patch the software to put that correction in place. And we became very proficient at it. I will say, and you hear this in the space industry a lot, that we stand on the shoulders of giants. The work we were doing was built upon work people had done before us. NASA's core flight software is a big part of what we do on the flight vehicle, and it has a lot of the capabilities to reload and reinitialize software built into it. And we were able to take advantage of that because of the foresight that people who had done space missions before had invested in that piece of technology, and we used it to great effectiveness going forward.
Great, thank you. Next up, we have Marcia Dunn with the Associated Press.
Hi, my questions are for you, Steve. What's your best guess for how close you are to the targeted touchdown area? And you said a lake caught the surface. Do you think the lander came in tilted to catch a lake like that? Could it have caught on a rock and then belly flopped? And do you think Odysseus was ever upright even for a moment or two, or do you think it just landed on its side from the get-go? Thanks.
Well, thank you, Marcia, for that question. We are reconstructing with the data that we get what we think happened. My theory is just a theory until we get an actual picture and see what happened. But if you pass me the model, Tim, I'll show you here, is if we're coming down, we came down a little bit faster. We were supposed to come down at 1 meter per second, which is about 2 miles an hour. And we're supposed to null the lateral velocity, which was supposed to be 0, and we're coming straight down. We had about 2 miles an hour going this way. And so if you're coming down at 6 miles an hour, is what we think, and moving 2 miles an hour, and you catch a foot, we might have fractured that landing gear and tipped over gently, like I said. We have to go look at when the main engine cutoff was to see if the main engine had any coupling effect to that or not. I can't tell you for sure. It'd be good to see the health of the landing gear and see how that all looks. And so it'll be a few days before we get all of that put together and reconstructed. That's an action I've already given the team, and I look forward to the answer to help inform our future flights.
I can add to that after pitch over, we have a hazard relative navigation system that generates measurements at 1 hertz. This is our optical processing. And we generated 84 measurements and processed 79 of those. So 84 is important because we have approximately a 120-second timeline from pitch over to landing. So the fact that we generated 84 accounts for a portion of that timeline. They're not necessarily continuous. The fact that we processed 79 of them and they were accepted by the Kalman filter that we have in our software means that there was very good agreement between the inertial measurement unit and our camera velocity measurement and the NDL, Navigation Doppler Lidar, on board. With those all in agreement, that means we had roughly 90 seconds out of 120 seconds guaranteed stable flight coming in. So we were very close to the vertical phase. We don't have the data from that interval yet, and so we're waiting to see what that is. But that's a really good indication that we were in stable control and vertical at the time we touched down.
Thank you. Bill Harwood with CBS News.
Hey, thank you very much. I think this is for Steve. How do you guys know it's resting on a rock, as it were, and not on its side? In other words, how many degrees of vertical did your type readings lead you to think, if you've even got a number like that? And are there any payloads on board that simply cannot work in the current orientation? Thanks.
Well, I'll let Tim address part of it, but our reconstruction, based on how much power we're getting off of this solar array, says that it has to be somewhat elevated off the surface horizontally. So that's why we think it's on a rock, or the foot is in a crevice or something, to hold it in that attitude. Fortunately, for most of the payloads are exposed to the outside above the surface that's down, the panel that's down towards the surface. That panel only had a single payload on it, and it's not an operational payload. It's a static payload, and that one we're still going to try to take a picture of that payload if we can, and that would meet those objectives of taking a photograph of that art cube that's on that panel, and that one that's pointed towards the surface of the moon. So we're going to try to download all the pictures and see if we got that picture in view. Tim, any more insight?
We also have some inertial measurement unit data. We've turned a lot of the flight instrumentation off on the vehicle for power management purposes, but before we did, we were able to get some packets and measure lunar gravity. And most of that lunar gravity was in the Z direction on that model, which is up along fairly close to level. So there is something, whether we run into a slope, which would also explain a tip over if there was more slope than we anticipated at touchdown. So the inertial measurement unit gives a very strong indication that this is up, and those sensors are very, very exquisite. So it's a confirmation of what we're seeing from the tanks. Exactly what the material is that's underneath the lander is something we hope to get some imagery from over the next coming days and find out more. We're as eager to see those images as the public is.
Yeah, and I would add, in terms of the technology payloads, we've already gotten data along the way to say they've been successful, right? So the radio frequency mass gauge has been working since launch, as soon as we got into low Earth orbit and going on the way. So we've gotten data all along that way, as well as during the descent, which we're still waiting for telemetry on that. The Navigation Doppler Lidar, we got that real time going down, so we know that worked very well and successful aspect of it, right? The scalps, the stereo cameras, we're waiting for the pictures to come back there, but everything else seems to be working very well, so we anticipate that worked well during the descent as well, and just waiting for the data to come back to analyze to see how that went. So a lot of the payloads have already been successfully demonstrated.
Yeah, and this is Joel. What I'd say is that, in addition to what Prasan and Tim said about the fact that so much data was acquired during transit out to the moon, low lunar orbit, and descent, of course we'll evaluate if there's any particular measurements that we can't take because of the vehicle configuration, but in general we expect to get a lot of data and a lot of measurements from the instruments, both science and technology.
Yeah, I have an add to that too. The NDL is a perfect example of a problem solved, but the radio frequency mass gauge was also something that we used for a problem avoided. We had a temperature sensor on one of our tanks, and we fly cryogenic fluids. They're very, very cold for propellant, and a temperature sensor was reporting back colder than we had anticipated. Well, that could have been indicative of a leak, and so we were beginning to spin up some contingencies. Well, what if we have a leak? What do we do? But because we had the radio frequency mass gauge, we were able to confirm that our tank masses were stable, and we just had a little bit of an anomalous sensor reading. And that avoided a problem, and we didn't spend more energy going through that. So that technology is one that maybe isn't quite as dramatic as a late orbit software reboot, but nonetheless gave us confidence going through the mission.
Great. Thank you so much for your insight on that. Next up, we have Ken Chang with the New York Times. Ken?
Yes, hi. Thank you. I was wondering, I guess, for Tim and Steve, sort of a tick-tock of what happened after lunar insertion. It looked like the orbit was lower than what was in the press kit, and then you had another burn that evening, and then you avoided the DOI burn, and then you had it moved up the landing time. So I was wondering what the various orbits were and how that affected the landing time. And also, when did you find out that you had a bum laser altimeter?
I missed the last part. I'll start with the first part. Kenneth, do you want to ask the last part again?
When did you find out that you had a bum laser altimeter?
Yeah,
okay, laser altimeter. So the first part of the question was about the lunar orbit insertion, and what happened after that, right, if I understand your question right. Well, we were having some difficulty with communications around the world, communicating from the different configurations and the different dishes that we had around the world up to our radios. And we have Quasonics radios and Thales Alenia radios. And some of those Thales Alenia radios have a range beacon, and we have a frequency that we know, a carrier frequency that we're operating on. And some of the dishes were smaller around the world. So in certain parts of the world, we had a weaker signal, and we would lose that carrier lock. And when that carrier lock goes down, you can't get a good orbit determination. And there was a shift in the ranging beacon, so that shift and that turnaround ratio in the ranging beacon is such that you had some inaccuracy. We had some inaccuracy. So we got the best data we could possibly get going into our lunar orbit insertion burn. But what we found was that was slightly elliptical. Actually, it was elliptical, not highly elliptical, but it was elliptical orbit. And so we were not comfortable necessarily with the proximity to the South Pole area. We were a little too close for our own comfort. So we decided to come in and do a raise of our paraloon position, and we did that very quickly, autonomously, and put us in a safer configuration for the mission and be prepared. And that burn we did in such a way that it eliminated the need for a deorbit insertion burn, a very small burn, before we did powered descent. When we were looking at our position around the moon, we decided to take a laser rangefinder, power it on, and ping the surface to see how close we were, because we were having trouble with this orbit determination and this Doppler measurement that we were trying to get. And we saw that that laser didn't fire. And what we found was that there's a safety enable switch, because it's not an eye-safe laser. That safety enable switch is in the box and was not disabled. So it's like having a safety on a firearm. It's for ground processing, and that was an oversight on our part. And so those laser range finders could not be turned on, and we couldn't manipulate that enable switch or disable switch with the software. And so those rangefinders had been tested and would have worked if we'd had caught that oversight and removed that enable before or disable before flight. So I think that got your question. Tim, anything to add on that?
No, that's right. I think the key thing was we have an incredible flight dynamics team who were able to determine that from the orbit we were in, we could raise paraloon with a lunar correction maneuver that they had built in with the foresight to trim the orbit if we had some unexpected conditions. And it basically put us into our descent orbit about 4 or 5 revs before we nominally would have done that. But the orbit still phased over the landing site in the right way and gave us a great opportunity to execute powered descent.
Thank you so much for that. Lauren Grush with Bloomberg.
Hi, thank you so much for taking my question. I think this might be for Steve or Tim. I'm curious if you've been able to determine if the tipping damaged the lander at all based on the rock that it's leaning on. Is there any concern of further degradation because of the position that it's in? Thanks.
Well, again, Lauren, we're hopeful to get pictures and really do an assessment of the structure and assessment of all the external equipment. We are hopeful that the top deck solar array is not damaged, and that as the sun comes around the lander, we'll be able to get some power generation from the top deck solar array, which is now vertical. And so we'll see what that means. But so far, we have quite a bit of operational capability, even though we're tipped over. And so that's really exciting for us, and we're continuing the surface operations mission as a result of it.
Thank you. Next up, we have Andrea Leinfelser with the Houston Chronicle. Andrea?
Hi. These questions are for Tim Crane. That final orbit you took, I just want to make sure that was specifically to implement the software patch to use NASA's LiDAR tech demo for landing. Also, Tim, on Twitter, or excuse me, X, you mentioned a big roll maneuver. Was this part of the plan? If not, what caused the roll maneuver, and did that create any complications? And finally, I was hoping you could walk us through some of the communication issues experienced right after landing. Was it difficult to get a signal because it was at an angle, or was it other challenges related to being on the South Pole? Thank you.
Thanks, Andrea. I did not catch the first part of your question. Could you repeat that?
Sorry, the first part was, that final orbit that you took that kind of pushed back the landing. Was that specifically to implement the software patch that helped you land with the NASA's LiDAR tech demo?
Yes. Okay. Thanks. It was. We were in good position to land at approximately 3:30, but the procedures that Steve was talking about. What order do we bring down the flight control, the guidance? Do we inhibit RCS? How do we do that in such a way that there's no unexpected consequence on the vehicle? For example, if we turned off guidance, navigation, and control, but didn't turn off the RCS control valves, they could listen to noise on the computer instead of controls to zero, and we could open up the valves and lose control. So we were very, very deliberate about working through in what we call a flat sat, which is basically the spacecraft equipment laid out in a lab driven by a simulation. We were very deliberate about working that procedure so that when we shut the software down, we could bring it back up safely and there was no harm to the vehicle. We had the patch ready in time for the first landing attempt, but we hadn't come to a satisfactory procedure yet, and we had to get it right. And so Steve and I conferred. It would be a little bit more fuel to catch the orbit once around, but again, our flight dynamics and automation team had written software that gave us a great amount of flexibility to control Odysseus. And we're really at a special time in our lunar program at Intuitive Machines, where most of our operators are also the subject matter experts who built these systems. So we had incredible insight what was going on. We had great confidence we could make this work, but we needed a little bit more time. And so we made the call to abort once around and implemented the patch at that time so that when we had that final orbit, we were in high confidence of landing. The roll maneuver at the end, we had made some decisions. Every vehicle has a mass limit, and you're trying to optimize performance versus mass. We had flown a vehicle with fixed antenna, and in order to fly with fixed antenna, we had to look at what our landing orientation was. At the South Pole, we landed. In fact, you'll see in this model, there's white paint on some surfaces and black paint on others. That's because we were going to land on the south near the South Pole, and the sun was going to illuminate the solar arrays, as you can imagine, and then also these white surfaces to reject heat. But on the other side, we have the cold side, and it gets very, very cold if you're not in direct sunlight on the moon. So we painted that black to catch reflected light off the moon and warm them up. So as we were coming down, we wanted our navigation cameras pointed to the ground. Then we wanted our navigation cameras pointed to the ground after we pitched over. But in landing, we had a planned roll maneuver to bring our antennas to face the Earth. And so in order to accommodate that, we had a planned roll maneuver. It was not unexpected that the roll maneuver would occur. It was also expected that there would be a loss of communications as we switched from our 1-2 antenna pair to our 3-4 antenna pair.
Thank you so much for that. Next up, we have Chris Davenport from the Washington Post. Chris?
Hey, thanks, everyone. For Tim and Steve, just regarding that audible you had to make, and I want to see if I can hone down on some of the chronology to get a sense of how the day unfolded for you yesterday. About what time is it that you realized that laser rangefinder wasn't working? And then did you immediately know that you could go to the NDL system? Was this something you had planned on as a contingency, or did you kind of make this up on the fly and decide, work on it, in real time yesterday? Thanks.
I'll start, and Tim will add a lot of color to this because this one was, like Gina asked, was the Hail Mary issue. When we went around the night before and we made that laser rangefinder measurement, it looked like the laser fired. We got an enable in the data, but when we did a deeper analysis of it, it was not actually fired. It was an error in the telemetry. So when we dug into it, we that morning, this was the morning of landing, we called MDA and asked them what they thought about it and could we convert that physical enable switch to a software change to command that switch, and they indicated no, there's a physical cutout for this and not a software-driven cutout for this. So I get into the control room, I can laugh about it now, and Tim was on console as the mission director, and I said, Tim, we're going to have to land without laser rangefinders, and his face got absolutely white because it was like a punch in the stomach that we were going to lose the mission. And we went around and we said, what are we going to do? We started to hack into the OS, the operating system of the laser rangefinder, to see if there was a way we could trick it some way. We thought about running a simulated table of the powered descent phase and like predict with like some parameters how we might land, and there's just way too many variables in that running a simulation table in against a real world situation, so that wasn't going to work. And so Tim and I were walking through the halls and trying to find the experts, and he came up with the idea that says, why don't we just plumb the high beam laser and the low beam laser from the NDL into the registers for the HRN laser rangefinder and the TRN laser rangefinder. He came up with that while we're walking down the hall in a hurried way, and it only would work if we ingested the range measurement in the nav application. And we had done that because we had worked with the team at Langley for so long with the NASA Doppler Lidar that we were able to have that instrument in shadow mode to give them better quality data. And because it was in shadow mode, we had that measurement in the navigation application. And it was just a brilliant piece of insight by Dr. Crane to say, let's clear the register and put those two lasers in as the actual makeshift laser rangefinders. So that's kind of how it unfolded, and we needed more time, so we delayed and took the risk and said, let's delay an orbit and switch to a later landing time, because the landing time was originally around 3:23 or 3:24, and we delayed till 5:24, as you know, based on a 2-hour orbit around the moon. So Tim, anything else?
Yeah, it sounds easy in retrospect. We had the Navigation Doppler Lidar already plumbed in the navigation system and had the range rate data, so the 3 beams on the NDL produce a velocity measurement, as Prasan had talked about. They also produce a range measurement. And we were not using the range measurement. We had just the range rate as a backup to our optical systems. But because it was already plumbed in there, we had to rewrite time tags into our measurement loader. But the challenge was the lasers. So we have these 2 navigation pods on the vehicle. If you can zoom in there, maybe not. Anyways, there are these 2 navigation pods that have the cameras. There you go. 2 navigation pods on either side of the vehicle that have cameras, and the laser rangefinders point in the same direction as the cameras. And those angles were optimized for our flight trajectory to give us the best measurements to land softly. The NDL was under one of these, and its angles were optimized to test the extent of its performance, not necessarily to feed our navigation system, but to test the sensor, because it was a technology development. So after we figured out we could write the measurements into the laser rangefinder, we had to quickly tell the computer that the laser beams were pointed in different directions. And so there were a number of attitude transformations of it's not in the same location, it's not in the same orientation. And if you've ever seen engineers doing right-hand rule transformations, there were a lot of broken wrists, put it down here, as people were trying to figure out which way is it pointing. And I will tell you that in normal software development for a spacecraft, this is the kind of thing that would have taken a month of writing down the math, cross-checking it with your colleagues, doing some simple calculations to prove that you think you're right, putting it into a simulation, running that simulation 10,000 times, evaluating its performance. Usually you find an error because you did something in that rotation wrong, and you roll it back and you go again. Our team basically did that in an hour and a half. And it worked. So it was one of the finest pieces of engineering I've ever had a chance to be affiliated with.
I'd like to add to that that the performance of the Navigation Doppler Lidar technology and payload that was developed by NASA's Langley Research Center was outstanding, and it was reliable. And that's what got Intuitive Machines some of the key data they needed in order to soft land.
Great, thank you so much for that. Eric Berger with Ars Technica. Eric?
Hi, thanks very much. Congratulations. Two questions for Tim or Steve. First of all, about propellant management. I'm curious how the cryogenic boil-off matched up with your expectations and kind of how much prop you had left at the end. And then what is the data transfer rate you're getting now versus what you expected? You know, trying to get some sense of how much data you're going to get back over the next week or so versus your original expectations. Thanks.
Propellant. So actually, the cryogens did very well. And just a correction, Eric, our system doesn't really have boil-off. Our tanks are rated to hold the pressure of the methane. It's very close to space storable. Really what we're worried about isn't a propellant boil-off. It is temperature management. We want to keep that cryogenic fluid very cold because the density of that fluid in our engine is what gives us the power of that thrust system. So really what we were looking at throughout the flight was, did our insulation plan and our isolation of the cryogenic tanks from the hot material of the spacecraft, did that give us the right thermal protection so that we did not heat that cold system up? And that worked very well. We found ourselves in a very good situation with propellant all the way through the mission. We used a little bit more helium than we thought through the mission, and had to adjust our control approach for that. And that was probably the area of concern. We were running a little bit low on helium. So a lot of lessons learned there on how we'll manage that going forward that will play out very well. And in terms of the bandwidth, that's difficult to answer. One of the things that's happening right now, we built fault detection technology into our comm system that if we're not getting a command heartbeat up on 2 of the antenna pair, it will go through a sequence of powering the radios off, restarting them, and then if they still don't get the heartbeat command signal from the Earth, then it switches to the other antenna pair. And so one of the first things we're trying to do is get out of that flight configuration and stay locked in on 2 antennas. But with that flip-flopping back and forth, right now we're trying to get the command up to move out of that flight mode, but there's a beat frequency of we go from a good configuration to one that's down, and then we're about to come up to the new one, and we move to a new antenna. And so we're working through that. When we left to come over for the briefing, I think they just about had that solved, but I can't give you a strong number because there's a variability there as we go from different antennas to different dishes around the world.
Great, thanks again. Jeff Faust with Space News. Jeff?
Good afternoon. Maybe just to quickly follow up on Eric's question for Tim, what is your best guess at how good the data rate you can eventually get once you optimize the system for the lander and its configuration? And then also, I think this question was asked earlier, I may have missed the answer. What's your best guess in terms of margin of error of how close you are to the predicted landing site? How many kilometers away do you think you touch down? Thanks.
Yeah, great questions. Thanks, Jeff. Best guess, in terms of bit rate, that's hard to say because that does vary with the antenna size and the sensitivity of each antenna. But we expect to get most of the mission data down once we stabilize our configuration. In terms of landing accuracy, without precision navigation sensors on board, the best you can expect to land on an IMU-only landing system would probably be in the 4 to 5 kilometer range. However, our optical navigation sensors perform flawlessly. In fact, our optical measurements looked better on the scopes than they had in simulations. So I'm confident that we're well within probably a 2 to 3 kilometer accuracy of the landing site for this mission. Would have been better if we'd have had our full complement of sensors as expected.
And just as a closing point, Jeff, on this question is that we're working with the Lunar Reconnaissance Orbiter and the Arizona State University faculty to do a pass to see if LRO can locate our position precisely and give us a latitude and longitude. And we expect that measurement, that pass to occur this weekend.
Thank you so much for that. Joey Roulette with Reuters. Joey?
Hey, thanks for doing this. Question for Tim or Steve. Since the lander is on its side, I was wondering if you could go into how that will limit what the lander can do, which operational capabilities are impacted by that, and which science objectives, if any, won't be able to be conducted because it's on its side. Thanks.
Well, I'll comment initially. Like I mentioned, we don't have active payloads on the panel E, I believe, is what's facing the surface of the moon. And so therefore, the active payloads that need communications and we need to command and we get the telemetry out are all exposed to the outside, which is very fortunate for us. We do have antenna, however, that are pointed at the surface, and those antennas are unusable for transmission to Earth, back to Earth. And so that really is a limiter. Our ability to communicate and get the right data down so that we get everything we need for the mission, I think is the most compromised from being on our side. Anything I missed, Tim?
No, that was it.
Well, maybe one I just thought of is I was telling you before about the solar panel on the top deck. We had to angle that at about 30 degrees tilt up for landing on the South Pole. That was one of the engineering changes we made when NASA asked us to move towards the South Pole region. Now we've tipped over and we don't know the health of that solar panel. It would be great to get a picture and or wait until the sun comes around and see if we get any battery charging off of that solar panel. So we'll see. We're in a great state of charge with the batteries. We're getting plenty of sun on the now horizontal solar panel, and we'll just have to wait and see with that other panel.
Thank you so much. Jonathan Siri, Fox News.
Thank you for taking my question, and congratulations, everyone. My question is also for Tim or Steve. Your team had to essentially rewrite the instruction manual several times while in flight, not just for troubleshooting, but also adapting to first in space performance of that new engine. Could you give us an idea of how many people were involved with the process, and did the discussions take place in a single war room, or were you conferencing in experts from multiple locations? Just give us an idea of the human logistics involved.
So I'll give you a rough overview, and then Tim can comment kind of how it went over the 7-day period. The operations team was structured into 3 shifts, red, white, and blue shift. Those shifts were supposed to work 8-hour shifts and then do a handover between shifts, but between those teams. Those teams are about 10 individuals.
Yep, 10.
And the other team that we activated was called Team 4. And the Team 4 was a handful of us senior leaders and engineers that could analyze and take the workload off of the operations teams. So if the operations teams are wrestling with a particularly thorny problem, they would call Team 4 and say, get in here and let's work on this for us and give us a solution. So we would pull in the subject matter experts for any of the disciplines that we would need to solve any particular problem, and we would work in a war room sense outside the control room to tackle that problem. We would have, for example, to activate and bring up the simulation, or activate and bring up the flat set. We would run analysis cases. We would call the vendors, like we called MDA about the laser rangefinders. We called NASA and talked about the Deep Space Network with that orbit determination need. So all of that chatter in the back, that was handled by, I would say, about 30 people that would work a given problem on and off based on the discipline. But what had happened during the mission was that red, white, and blue team and the teams and Team 4 ended up working nearly around the clock. We really could have staffed more, but it takes a lot of expertise to staff those teams, and we ended up kind of melding into, we're all working on this last problem through powered descent, and we collapsed into a single red, white, and blue team, all of it, to get that solved, which we're going to go back and look at and see. We really, really worked the team hard. They put a lot of hours in. I think one of the longest days was 48 hours long, and another day was 40 hours long for some of the folks, and that's, just working too hard, and we need to give them rest so they can be bright and make the right engineering decisions. So we got some lessons learned in that area, but we did it, and it was worth it, and it was a whole idea of persevering through the challenges and never giving up. Never, ever give up until the last-ditch solution you could find, and then keep thinking about it if it didn't work. So just a testament to a great operations team.
Yeah, I'll add to that. You know, our operations concept was a blend of human spaceflight for space station and space shuttle. We have, you know, that's in our culture here in the Houston area. Some of us had worked on the All-Hat Morpheus project at NASA, which was in some way has the DNA that led into Nova C. We had people with a military operations background, and then we had people from commercial networked operations. And so we put all of that together, and we came up with our own unique blend of how we were going to do spacecraft operations. And a big focus of that was the people inside the room on the red, white, and blue teams, keep the vehicle alive. Keep the vehicle alive and doing what it's supposed to do. And then all the mission directors, myself, Jack Twofish Fisher, and Trent Martin, we had the responsibility to interface with Team 4. And we would be able to say, I have this problem, I can't solve it with the resources I have in the room, and do what we're supposed to do. And so we would shed those out to Team 4, and they did an amazing job, whether it was talking to the vendors or developing a procedure. They took that off the plate, and that load balance, even though Steve's right, you know, I joked this morning that, you know, how was your day? I said, well, this mission was the longest 7-day day of my life. But it really allowed us to focus on keeping the vehicle alive and keeping it moving on its way to the moon and doing the things we needed to do while problems and anomalies could be solved in the back room. And, you know, this is a story that everybody on that team is going to be able to tell for generations about how we landed.
Irene Klotz, Aviation Week. Your line is open.
Thanks. If I understand that incredible sequence of events correctly, was it just serendipity that a situation developed with that elliptical orbit that caused you to try and get the laser rangefinder data where you realized it wasn't working before it would have actually been needed? And when during the touchdown would that laser rangefinder nominally have been activated?
I think I understood, Irene, the question. It was actually fortuitous that we had an elliptical orbit after lunar orbit insertion, because we would not have arbitrarily activated the laser rangefinders prior to powered descent. We tested them on the ground, we flew them on aircraft, we flew them on helicopters. We assumed after all that testing they worked. So the first usage of those laser rangefinders was supposed to be during the powered descent. But because we had such a low paraloon, we activated a laser and found the problem. So that was fortunate, and that was a bit of luck for us that then we identified that they weren't firing. So at that point, then that was recovered. Like I said, at the next morning we uncovered that, and then we had to work feverishly to figure out an alternative solution. Anything there, Tim?
Yeah, just the second part, Irene, of your question of when would they normally have come on? Normally we would have turned them on after deorbit insertion about an hour before landing, and we expected what we call the terrain relative navigation lidar, the laser rangefinder. That would have operated really from about 50 kilometers altitude all the way down to landing. And then after pitch over, we had a laser on the other side that would take us from a kilometer down. So we would have probably been 5 minutes to landing before we would have realized that those lasers weren't working if we had not had that fortuitous event. So serendipity is absolutely the right word.
Jackie Waddles, CNN.
Hi, everyone. Thanks so much for doing this. Had a quick question for Steve or Tim. I know everyone's really curious about the photos here, so do you guys have any indication if Eagle Cam is in a position to pop off the lander and take some pictures? And to that end, if you could just clarify for all of us, are there any specific payloads, whether commercial or NASA, and I know some of them are passive, and you're still working on figuring out these data downlinks and stuff, but are there any that you know for sure or just haven't gotten any data yet and don't know if you will get data from? Thanks so much.
Well, fortunately, again, EagleCam sits on a panel. Let me show Tim. If panel E, I believe, is towards the surface of the moon, EagleCam sits over here on this panel, and we plan to eject that camera off the side so it will fall about 30 meters or so, maybe not that far, away from the lander and get a good shot of the lander position this way. So we're looking to power up that EagleCam. We were waiting on getting commanding ability, power that up, clear that SD card, and fire the camera, and so we can get a view back to our lander. So that's a very exciting image for us. The reason it wasn't fired as we were landing was because of this nav system initialization that we had to do, which put a flag up to flag the EagleCam not to fire. So that was part of the troubleshooting we had to do to get the Doppler Lidar into the nav system. We had to do these navigation initializations, and that shut off the EagleCam. And we knew that was in the software, but we just did not have time to go fix that. And so now we'll get it and get the image in the orientation that we need. The other question you had about commercial payloads, we think we can meet all of the needs and from the commercial payloads that we have in the orientation we have. The one on panel E that's covered right now or shaded by the lander and the surface is the ArcCube project, and we believe we've got an image of that already that we can download and share with our customer.
I'll add that for the NASA science payloads, as we said earlier, that many of them have already taken a lot of data, a lot of measurements in transit and also on descent. We're still checking to see if in the current suspected orientation of the vehicle, whether there will be any particular measurements that can't be made in some of the payloads. So for example, we want to make sure that the laser retroreflectors, which are normally pointed up, so that when the Lunar Reconnaissance Orbiter flies over, it can pulse them with a laser beam and find their position. We'll have to check to make sure that they can still be illuminated. They probably can be when the orbiter is flying at a further angle away on the trajectory. Very similar to what we found with the recent SLIM landing from the Japanese Space Exploration Agency. But we are doing an assessment to see are there any measurements still to come that from any of the NASA supplied payloads that most likely can't take place, particularly because of this new orientation.
Great, thank you so much for that. Will Robinson-Smith for Space Flight Now. Will?
Yes, hi. Thanks for taking the time to answer our questions here. One for Joel and Prasan, if I could. Given the success and now the operability of the NDL, will that become a, highly recommended or required payload on future CLPS missions? And what are the potential implications or knock-on effects for the human landing system landers? Will NASA recommend that Blue Origin and SpaceX implement that into their landing systems? Thanks.
I'll take a shot, Prasan. Please add. So for a commercial lunar payload services initiative, we don't prescribe to the company partners that are doing this as a service, what techniques or technologies they use. But as you can imagine, all these different companies are always looking for low risk, good performance ways to gather the data or conduct the operations that they are going to conduct for NASA. So I'm sure that this story, as you can tell now, is very public about things like the performance of the NDL, and we would think that people that are looking at lunar landers would be checking into that technology now that it's actually been flight proven operationally on probably an unanticipated flight test mission, right? I actually use it operationally. I would say the same thing, the human lander system partners have their own techniques and their own approaches that they're taking, but again, now that this has been actually shown to operationally work, I would think it's going to be of great interest to folks that want to travel to the moon. Prasan?
Yeah, I will add, we've actually, NASA has already licensed this technology to a small company to commercially provide this to whoever wants to buy it, right? And so this only adds more validation of the system. There's just a technical reason to add it, right, beyond the aspects that Joel talked about, because it is an order of magnitude more accurate in precision and measurement of range and velocity components. It's half the power, half the mass of the traditional approaches that we've used in the past. And the volume in terms of signs is about a third of it. So if you just look at it from a technical perspective, it just provides all these benefits. And so I'm sure future vendors will look at this type of capability anew and try to incorporate these types of technologies. And that's why we're doing these missions, right? Is to develop better and better capable systems that allow us to do this more reliably, more capably, and hopefully more sustainably and more cost-efficient wise. So in fact, after the landing, I did joke with Steve there. It's like, hey, now are you ready for IM-2? Because we have 3 payloads already ready to go on IM-2, right? And so we're ready to demonstrate even more stuff that will help the greater space economy that burgeoning in here in the U.S. And we just want to augment that as much as possible we can with what we're doing.
Yeah, I'll chime in as well. As you look forward to future missions, and as we begin delivering cargo missions with a metric ton and more, those payloads get more and more valuable. And as those payloads get more and more valuable, we're going to have to prove to our customers that we have robustness in our landing systems. One of the ways you achieve robustness is with redundancy or with dissimilar redundancy. So having 2 ways of measuring that landing. We had a camera system on board, but if you have a camera system and a laser system, one might fail in a way that the other one might not. And so I can see that as the lunar economy opens up, as NASA begins to send cargo and larger, more expensive payloads with companies like ours and others, that you're going to see demand for these kind of sensors complementing a suite of sensors that you use to guarantee safe landing is going to be something that will be an industry standard.
Thank you for that. We are going to try and take 2 more questions, so I'm going to ask you guys to be brief in your remarks so we can get through these questions. First up, we have Marcia Smith with spacepolicyonline.com. Marcia?
Thanks so much. Getting back to the communications question, I gather that part of the challenge is that you have so many different sites around the world with different capabilities. But I know that you had talked before you launched about the challenges of communicating at the South Pole. So how much of the comm problems are related to the ground stations and how much to the place where you are on the moon? And what lessons are you going to learn from all of this for the Artemis missions?
Well, yeah, I'll answer some of that question. What you get is a phenomenon at the South Pole that NASA's interested in understanding, since that's where our future Artemis missions are targeted, or NASA's future Artemis missions are targeted, is a frequency multipath condition. And so are you going to get multipath interference on your communication frequencies? Fortunately, we think the antennas that are pointed towards the moon will give us a really good understanding of that phenomenon at the South Pole. Another serendipitous moment, right? But I would say that we thought about this landing on the South Pole quite a bit, and if you look at the mock-up, all the antennas are up high and pointed like towards Earth when you're sitting on the surface of the moon. In transit, it's very difficult. You have to constantly change your attitude to point the antennas back to Earth when you're headed toward the moon. So we're going to figure out an antenna location map for subsequent missions, and even mission 2, that gives us an antenna pointed back at the Earth when we're flying out towards the moon, for sure. Also, in this first ever use of our lunar data network, this commercially now available data network made up of these large radio astronomy dishes that we've stitched together in a network. Some of those dishes have had configuration issues. Some of those dishes have had a weaker power band. So we can all operate on this frequency, S-band set of frequencies. However, the power to reach the moon is what came into account as we went around and out towards the moon. The further we got, sometimes those power transmission levels were too low to have us keep the carrier locked up on the radios. So that was some of the challenges, and that's what we're looking for going forward, is to really regularize that lunar data network so that operationally we know the configuration. We can go upgrade to put additional orbit determination capabilities within our baseband units at each antenna site. And the best thing will be when we get our data relay satellites in orbit, we'll have that problem licked, and we can communicate short distance from the surface up to a satellite and relay that back to Earth in a more traditional way. So looking forward to those advances in the communication system.
Thank you. And we have one last question we can take this afternoon with Adam Mann from Science. Adam?
Hi there. I'm with Science News, actually, and I guess this is for the Intuitive Machines folks. I'm wondering, maybe you've answered this already, but I'm just wondering if you have any idea how long ODI might be able to stay operational on lunar surface.
Well, it's a great question, and you're going to bring a tear to my eye. We know at this landing site the sun will move beyond our solar arrays in any configuration in approximately 9 days. And so the early missions are all solar powered and require that. And then once the sun sets on ODI, the batteries will attempt to keep the vehicle warm and alive, but eventually it'll fall into a deep cold. And then the electronics that we produce just won't survive the deep cold of lunar night. And so best case scenario, we're looking at another 9 to 10 days. And then we will, of course, the next time the sun illuminates the solar arrays, we'll turn our dishes to the moon just to see if the radios and the batteries and the flight computer survive that deep cold. The solar array should survive the deep cold and provide power, but we'll just see if our electronics made it through. We'll take a look, we'll take a listen. By that time, we'll have gotten very, very good at listening to that signal, but we do expect probably a maximum of another 9 to 10 days.
Thank you so much, Tim. And thank you to everyone who submitted questions this afternoon. And thank you to our briefers for taking the time to discuss this historic mission enabled by the agency's Commercial Lunar Payload Services, or CLPS, initiative. We hope you'll continue to follow along on this mission by keeping track on Intuitive Machines' website and on nasa.gov/CLPS. That will wrap today's briefing. Thank you so much.
landing a man on the moon and returning him safely to the Earth.
Tranquility Base here. The Eagle has landed.
Feet, down at 2, feels good, 20 feet, going down at 2, 10 feet, 10 feet, contact, stop, push, engine stop, engine arm, proceed, command override off, mode control ahead, hold, pings auto. Okay, Houston, the Challenger has landed. Houston, you can tell America that Challenger is at Taurus Littrow.
"50 years ago today, Apollo 17 Commander Gene Cernan and Lunar Module pilot Jack Schmitt guided Challenger to a pinpoint landing on a barren rock-strewn area of the moon called Taurus Littrow. A half-century later, NASA's newest moon explorer, the Orion spacecraft, is barreling its way back home after circumnavigating the moon and beyond in an elliptical distant retrograde orbit, now less than 2 hours away from splashing down in the Pacific Ocean west of Baja California to complete its shakedown mission that has opened a new era of deep space exploration. Good morning from the Artemis Flight Control Room here at the Johnson Space Center in Houston and Mission Control, where the entry team of flight controllers is on duty, ready to bring Orion home to complete a 25-and-a-half-day mission. As he was for the launch of Orion more than 25 days ago, NASA Flight Director Judd Freeling is leading the entry team here in the White Flight Control Room. The target for Orion is growing larger in the field of view, moment by moment. This is a live view of the Earth from a distance of 15,000 miles away. About 3 hours and 40 minutes ago, Orion conducted the final major maneuver of its mission, a return trajectory correction burn of its thrusters to further fine-tune its path toward its splashdown site in the Pacific. We'll be heading out to the Pacific shortly for the first in a series of reports from the scene where Orion will be recovered. After launching atop the Space Launch System more than 25 days ago and traversing some 1.4 million miles in its circuitous orbit past the Moon and back, the most critical phase of the Artemis 1 mission for Orion is at hand. It is homecoming day, so let's run down the milestones you'll be hearing about and seeing over the next couple of hours. Next up for Orion will be the crew module's separation from the European service module. That pyrotechnic separation is scheduled at 11 a.m. Central Time, just 20 minutes before Orion begins its entry into the Earth's atmosphere at an altitude of 3,200 statute miles. Now, we had planned for Orion to conduct a maneuver called the raise maneuver, a 16-second thruster firing to orient itself at the proper angle for its plunge back into the atmosphere. But the latest targeting for Orion from the flight dynamics folks here in Mission Control indicates such a precise trajectory for the spacecraft, it was determined that the raise maneuver was not required. That could still change following crew module, service module separation, but at the moment, the raise maneuver will not be required. The major objective of this mission is to test the spacecraft's heat shield against the searing heat of entry, where temperatures will build up to around 5,000 degrees Fahrenheit around Orion, half as hot as the outer surface of the Sun, twice as hot as the temperatures endured by returning space shuttles and other crew vehicles. Orion will perform what is called a skip entry. dipping into the atmosphere, then lifting out of the atmosphere and dipping back in like a flat rock skimming across a pond. This will provide aerobraking for the vehicle, will help to dissipate some of the vehicle's inertia, and will provide data needed in the future to select multiple splashdown sites for crewed missions. We are expecting 2 periods during entry when the buildup of heat-generated plasma around Orion will block communications and the receipt of data with flight controllers here in Houston. The first blackout should begin around 11:20 a.m. Central Time for just under 5 minutes, right around the time of peak heating on Orion, as it travels about 25 times the speed of sound. The second blackout period is expected around 11:29 a.m. Central Time for just under 3 minutes, right after the skip entry maneuver is complete. About 5 minutes after we regain communications with Orion, the pre-programmed commands stored on board will trigger the deployment of 3 parachutes at the top of Orion to pull the forward bay cover off of the crew module. That will initiate the sequential deployment of 2 drogue chutes and 3 pilot parachutes, followed by the 3 large main chutes to slow down Orion, enabling it to gently splash down in the Pacific. The current splashdown time, 11:39 and 42 seconds a.m. Central Time, 9:39 and 42 seconds a.m. Pacific Time. We'll be talking more about those parachutes shortly. The weather forecast at the splashdown site west of Baja California is excellent. The Spaceflight Meteorology Group here at the Johnson Space Center has just issued a forecast calling for scattered clouds at 1,700 feet, winds peaking to about 9 knots with periodic wave heights of about 5 feet. That is all within flight rule limits, and it should be a splendid day for Orion's homecoming. Out in the Pacific, aboard the prime recovery ship, the USS Portland, embedded with the Kennedy Space Center's Exploration Ground Systems Recovery Team and the U.S. Navy, is my colleague from the Kennedy Space Center, Daryl Nail. Daryl, good morning to you, and as they say in the Navy, give us a sit rep on preparations out there.
Well, good morning to you, Rob, and that's right. We're live on the deck just outside the bridge here on the USS Portland with a fantastic view of the area of splashdown. I just spoke with the recovery team. They say we are currently 5 miles away from the splashdown location right here in the Pacific Ocean. The location, as you mentioned, just off the coast of Baja, Mexico. We got the great weather report, seas, as you mentioned, 4 to 5 feet. We're looking good there. Let me show you the bridge deck where we are currently positioned. This is looking forward for the ship. I talked to Captain John Ryan, who says that he currently has the ship in a racetrack going around the location near where splashdown is, just upwind of it, so that the debris that comes down, that being the crew module and the parachutes, the forward bay cover, when it separates, will be all downwind of us. Now, preparations are already underway. We can hear the helicopter engines running, so we want to take you to a live view of the flight deck. This is towards the back of the ship, where just 5 minutes ago, the Navy started the engines on 2 of the 3 Navy MH-60s, or Nighthawk helicopters, that will be used for the operation. There you see them on your screen. The 2 helicopters on the left side of the flight deck, they will be involved in the operation. The third to the right is a backup helicopter. Now, one of the helicopters will use the Navy's infrared targeting system, which will start looking for Orion at an altitude of about 50,000 feet. Should be able to quickly lock on to Orion's heat shield, which should be still very hot after reaching 5,000 degrees Fahrenheit on the heat of reentry. The second helicopter will track the forward bay cover, a 1,000-pound, 9.5-foot wide titanium cover on top of Orion, which protects the parachutes during the heat of reentry. It is jettisoned to allow them to come out. Now, NASA's plan going in was to recover it, but they've made an adjustment due to the seas and the limitations of a small boat crane needed to lift it out of the water. Both helicopters, if you can see just to the left of that helicopter at the bottom of your screen, have GSS cameras mounted to them. These are ultra-high def cameras to record 8K resolution video for engineering purposes. Now, with those helicopters just minutes away from flying out, let's take a look underneath this very flight deck. You can see into the well deck, and this is the multi-purpose capability of this vessel, the USS Portland. Down on the well deck is where the final phase of recovery will happen. 2 teams of Navy divers are preparing to launch the small boats. You see them at the bottom of your screen, just partially protruding there at the bottom. Those are inflatable boats that the Navy will use. 6 in all will pre-position themselves in the open sea to recover debris from the descent operation and then, of course, secure the Orion crew module itself. The Navy dive team will also take above water and underneath water photography of the heat shield before the crew module is moved. This is for all engineering purposes so they can see it freshly returned from space. Once the divers have Orion stabilized with tow ropes, you see that bright yellow structure right dead in the middle of your screen. That is the cradle that the boats and the winch lines will pull into position and put it right down on top of that cradle. They will flood that deck with water, roughly about 6 feet, and then with a careful choreography of winch line and lines being pulled and maintained by sailors, they'll put it in position for its ride back to San Diego. Now, coming up, we'll speak to one of the Navy divers who will be in the water helping. In fact, he's on deck standing by in just a few minutes. He's ready to go into the water. We'll get some words from him before he goes out on his assignment. Looking good on the ship right now. Rob, we'll send it back to you in Houston.
Thanks, Daryl. And again, a live view from Orion as it continues its pinpoint journey back towards its splashdown site, not far from where you are out in the Pacific. We will be going back to Daryl Nail on the USS Portland frequently during the course of today's coverage. Orion is wrapping up, as we said earlier, a mission that will have spanned 1.4 million miles, having flown further away from Earth than any human-rated spacecraft designed to return humans to Earth. And, of course, the big test that's coming up, the ultimate test of its heat shield that will repel temperatures that will build up around the base of Orion to about 5,000 degrees Fahrenheit at peak heating as Orion barrels back into the Earth's atmosphere. It has been an incredibly successful mission for the Orion spacecraft. We'll be talking to a variety of people about all that, officials and managers and engineers throughout the course of our coverage today. But for the moment, let's take a visual and interactive look at this mission with NASA's Philip Hargrove, who will use the moon board to explain it all.
Yes, welcome to the moon board here at the Apollo Saturn V Center. It's been a super exciting month since the Artemis 1 launch. So let's take a look back at everything that happened just a few miles away from where I'm standing right now. Now, on November 16th at 1:47 a.m., the SLS lifted off from Launch Pad 39B here at Kennedy Space Center, and it put on an incredible show for everybody watching here from the Space Coast. I can't even describe to you how amazing it was to watch that core stage. Those solid rocket boosters provide over 8 million pounds of thrust at liftoff. Now, those boosters and the core stage got us going from 0 to over 17,000 miles per hour in just about 8 minutes. And then once all that propellant was depleted, the responsibility was passed on to the interim cryogenic propulsion stage. Now, the first job of the ICPS was to perform a perigee raise maneuver. And this means that we're getting into a low Earth circular orbit that allows us to deploy those solar panels, start harvesting energy, and do systems checkouts to make sure that we are ready for our journey. And we stayed in that orbit for about 30 minutes, and then we did our translunar injection burn. This is the primary responsibility of the ICPS because it gives us the energy to escape low Earth orbit and commits us on a path out to the moon. Now, once it completed that burn, the ICPS separated from the Orion, and it performed one final burn to completely leave the Earth-Moon system. And after doing that, Orion was on its way out to the moon. So it spent about 4 days heading out towards the moon. And then we quickly dipped in about 60 miles above the surface of the moon and did an outbound powered flyby. Now, that powered flyby means that we're taking advantage of the speed we already have, the gravity of the moon, and the energy we get from the service module's engines in order to target our orbit. And the orbit that we were targeting is called a DRO, or a distant retrograde orbit. And what that means is that instead of moving counterclockwise relative to the Earth like the moon does naturally, we are moving clockwise. So we're going in this opposite direction. That's what retrograde means. And distant means that we are going farther away than we have with any human spacecraft before. We're orbiting about 38,000 miles above the surface of the moon. And this is a really convenient orbit because we're able to stay there without having to use a ton of fuel for station keeping. And it also provides a safe, efficient path back home when we're ready. So this allowed us to learn how to operate in deep space, one of the core tenets of this mission. And then once we were ready, we started our trip back home. So we performed one more powered flyby, this time targeting our return, where we lit up those engines as we dipped close to the surface of the moon. And then we began our return transit, which took about 7 days, and that leads us to today. So next time we'll talk a bit more about what that return looks like and what our entry is actually going to look like. But until then, back to you.
Thank you, Philip. And again, a live view of Orion closing in on planet Earth, now about 11,000 miles away from Earth, as it continues a very, very precise trajectory for a splashdown that is scheduled at 11:39 and 42 seconds a.m. Central Time this morning. For Orion, launch from the Kennedy Space Center occurred on November 16th on the world's most powerful rocket, the Space Launch System. The first outbound powered flyby of the moon was performed 5 days later on November 21st, dipping to within about 81 miles of the lunar surface. That placed Orion on a very precise trajectory for its ultimate goal, that racetrack trajectory called the distant retrograde orbit, that would allow Orion the time and the space environment needed to test its mettle. 4 days later, Orion executed an engine firing to enter into that orbit, and the next day, Orion surpassed the record set during Apollo 13 52 years ago for the greatest distance ever traveled by a human-rated spacecraft designed to return humans to the Earth. On November 28th, Orion reached its farthest distance from the Earth, some 268,000 miles, before departing the distant retrograde orbit on December 1st. And this past Monday, Orion conducted a 3-minute, 27-second engine firing behind the moon to whip around Earth's closest neighbor for the final leg of its flight, passing to within 80 miles of the surface, turning for home, and its splashdown that is scheduled just 1 hour, 21 minutes, 44 seconds from now. The initial mission of the Artemis 1 program was always designed to be a test flight, wringing out all of the systems of the Space Launch System and the Orion spacecraft, and for more than 25 days it did just that, setting the stage for a crew to board an Orion vehicle for a trip around the moon in 2 years. So with that, out in the Pacific, where Orion will be splashing down not long from now, we're going to go back here in a moment to Daryl Nail, who's standing by with one of the first persons that will actually be in the water to execute the recovery and the securing of the Orion spacecraft. Daryl?
That's right, Rob, and his name is Wayne Shearer, and he is the Navy diver first class aboard boat number 2. He is the lead on one of the 2 small boats called Cricks, which are essentially small inflatable Navy boats. He's just about 20 or so minutes away from getting into that boat. Thank you, Wayne, for coming up here and making some time for us to tell us about the operation today.
Of course, sir.
So tell me exactly how your team goes about securing this spacecraft after it comes back from space, splashes down the water just a few miles from us.
Well, sequence of events are going to go splash down, wait 2 hours. We're going to do a hazard analysis, make sure there's no gas coming off of it. We're going to come up, take those pictures like you said earlier for those engineering purposes. Once that's done, then we put the what's called a pony collar on it, and then basically it's a sequence of events of pulling all those ropes out like you said earlier and pulling it into the well deck. Easy day.
Easy day, and we know that there are certainly going to be some challenges, right? Seas are 4 to 5 foot currently, which is within your limit. Let's take a look now underneath the well deck to the boats that are currently being prepared. You're really literally going to be going down here and right to that boat after we conclude our interview. How will you manage the 4 to 5 foot seas with a bobbing spacecraft and bobbing inflatable boat with your team?
Well, this is just another day in the park for us. You know, we've trained for the last year and a half for this. We've been in worse seas than this, recovering anything under the water. It's just different. Instead of recovering something from under the water, we're going to recover something that fell from the sky.
You can see on our screen, those are the tip edges of your 2 inflatable boats. I imagine you'll be positioned somewhere towards the front or back?
I'll be positioned toward the middle of the boat.
Towards the middle of the boat. And as you do this operation, have you thought about just the importance of it? Reflecting that it is you who will be one of the first people to put your hands on a spacecraft that just came back from space.
I mean, definitely, this is probably every kid's little dream, or every little kid's dream, to be able to do exactly what I'm doing today, you know, and I think I can speak for the whole dive team that we're honored to be part of history and to be part of something so monumentous, and just ready and excited to go out and do this.
On a personal note, you and I were talking about how you got into the Navy and the dive team. What was it that motivated you to become a Navy diver, and then ultimately, now that you're on this operation, looking back at that choice?
Well, February 2003 from Leesville, Louisiana, and I heard a loud boom outside my window one morning, and I ran outside and I talked to my dad, and a few hours later we're watching the news, and unfortunately what we heard was the USS Columbia break up. So, you know, it was not a great thing to hear, but it kind of jump-started my career of like, hey, what do I want to do? And I wanted to be out there to help people, and the Navy just kind of fell into my lap. And, you know, 20 years later, to be able to be part of history of the first next thing we've flown into space like that is absolutely a dream come true for myself.
Certainly a tragedy for NASA, one that has created many lessons learned for our agency, but interesting that it led you into this.
They have around the world.
And briefly, Wayne, as you look out here to the Pacific Ocean, where you will literally be in the water in just a few minutes, will you be sharing any words with your team?
Good luck, be safe, and let's be part of history.
All right, we wish you the best. Wayne, thank you for taking the time, and good luck out there.
Thanks, sir.
Rob, we'll send it back to you.
Thanks, Daryl. It looks like a great day out in the Pacific, west of Baja, California, where Orion is headed. And you can't beat this view, though. The view of the Earth, where Orion is headed, tried and true, on a pinpoint course for a splashdown just 1 hour and 16 minutes from now. After Orion enters the Earth's atmosphere at the conclusion of this 25-and-a-half-day mission, the spacecraft is going to rely on a very heavily tested parachute system to slow down its speed and allow for a very gentle splashdown. Koki Machin, the chief engineer of Orion's parachute assembly system, now describes the process and the path to the certification of the parachute system. A series of 11 parachutes will be deployed in sequential fashion. A very dramatic return to Earth lying ahead for the Orion spacecraft.
Our design is almost exactly the Apollo design. The shape of the mains, the shape of the drogues. The only major difference is we are bigger. Apollo weighed roughly 13,500 pounds, and we weigh 22 and change thousand pounds. And so our parachutes are larger because we have more energy to take out of the system, and our parachutes are stronger. So at a fundamental level, all round parachutes are alike. The Orion system has drogue parachutes that initially decelerate the system, and because they're deployed at a much higher velocity, they're made of ribbons. The ribbons can take the fluttering associated with high velocity deployments much better than a solid canopy can. And once the system slows down, it deploys the mains. The mains are much closer to a personnel chute. They're called ring sails. The major difference would be that a personnel chute could be 28 to 30 feet in diameter, and a CPAS main is 116 feet in diameter. So the Orion parachutes are what we refer to as hybrid parachutes. The drag surfaces are nylon, but then the structural grid, how we take the drag on that nylon surface and transmit it down to the vehicle, is made of Kevlar. And Kevlar is quite a bit stronger and stiffer, and it just completely different material than the drag surfaces are. So the CPAS system is designed to safely recover the crew with just 2 mains deployed. The problem with deploying the backup chute after you deploy the first 2 chutes is you have to negotiate the chute that's already out there. So what we chose to do, and what Apollo chose to do, was to deploy the backup chute with the main system itself. And as a result, we get a much softer landing when all the parachutes work properly. But both systems were designed to land with just 2 main parachutes functioning. When we did the pad abort test at White Sands, I was quite scared. But I wasn't scared for our system. I was scared for the repositioning after the rockets took off the capsule and repositioned. It was perfect. That thing reoriented like it was on rails. And I swear to you, this huge relief came over me when the cover came off, because I thought, wow, we're not done, but we're done. I know this system's going to work.
And there again, the view of the Earth. We're about 33 minutes away from the first big milestone. That will be the separation of the crew module and the service module, signaling the beginning of Orion's entrance into the home stretch of its 1.4 million mile journey. With us at this hour is the Deputy Associate Administrator for Exploration Systems, Kathy Kerner. Kathy, thanks for joining us this morning. It's great to see you.
Glad to be here.
You know, this is a little bit of deja vu for you. You were a flight director in this room for a number of years. Your thoughts as Orion approaches the end of this maiden flight?
Yeah, certainly a lot of history in human spaceflight has been made in this room, and we're making some more today. And really excited. There's a lot of energy in the room, and it's very familiar, but it's also very different as we step into this next episode in human exploration.
You know, the mission had its trials and tribulations getting off the ground, but once it did, so far, so good. The mission has exceeded expectations in many areas. Of course, the post-flight analysis is yet to come, but from the top level, the 1,000-foot level, looking down at the mission, what are your thoughts about what has been accomplished in setting the stage for a crewed mission 2 years from now?
Absolutely, this has been a phenomenal mission thus far. If you asked me to grade it, I'd give us an A+. I think that the work that has been performed both by the Exploration Ground Systems team, the SLS team, and the Orion team has been fantastic. We've been learning how the spacecraft operates. We've been learning how to fly this amazing machine, and it's gone so well that we've actually been able to add tests during the mission that help expand the envelope that we're going to be able to use to operate the spacecraft once we have crew on board.
The major objective of the mission lies ahead. That's the rigorous testing of the heat shield, as we've just seen in our features. 5,000 degrees Fahrenheit building up around the spacecraft, twice as much as space shuttles endured when they re-entered the Earth's atmosphere. How do you think it's all going to fare, and what then needs to be done to analyze the performance of the heat shield in certifying that we are good to put a crew on board in a couple of years?
So this test, this is the primary objective of this test mission, but we've got a lot more objectives that we need to accomplish between now and when we launch crew. We have an environmental test that we need to conduct of the entire integrated spacecraft once we get the environmental and life support systems on board. So this is just one of many tests that we have going forward and one of many analyses that we need to do with all of the post-flight data that we retrieve from the spacecraft.
We opened up the broadcast paying homage to Apollo 17 landing on the moon 50 years ago today. It's only coincidence that this happened, but it seems very appropriate, doesn't it?
It does. It seems fitting that we would honor Apollo with the new legacy of the Artemis generation and this mission today.
Thanks very much, Kathy. Kathy Kerner, the Deputy Associate Administrator for Exploration Systems, and we're nearing the end of the home stretch here of this very first mission.
Thanks, Rob. Great to be here.
And as the Earth grows larger and larger in the field of view, Orion continues its trek back home with crew module, service module separation just 30 minutes from now. Entry interface just 20 minutes after that. In the meantime, let's go back out to the Pacific, the destination for Orion today, where Darrell Nail from the Kennedy Space Center, again embedded with the Exploration Ground Systems and Recovery teams, is standing by with Shannon Walker, NASA astronaut.
Well operations. All hands on the wall, staying clear of wing walls, vehicle storage areas.
That's right, Rob. Shannon Walker, NASA astronaut, has been on board since we departed on Wednesday to come out to the site. Thank you for being here to take some time to talk to us amidst this important operation to recover the Orion crew module.
Absolutely. I am happy to be here.
So tell me a little bit about the reason you're here and what you're doing as you observe the operations today.
Yeah, of course, we do not have crew on this capsule, but I am here because the next Artemis flight will have crew on it. And so we are starting the process of assessing how we're going to operate with crew. How do we extract the crew from the capsule? How do we get them to the ship safely? How do we do all the medical checks we want to do? So we're starting the process of getting ready for the next Artemis mission.
And with this capsule being recovered today, it will be brought back. I imagine that the astronauts will be very interested in the data that comes off of it. This particular capsule has sensors all over it, more than any future capsule will have.
Yeah, absolutely. So this is going to tell us what we need to do, change, modify for the next Artemis mission.
On all flight quarter stations. The ship expects to read manned flight quarters at 0945.
And what you're hearing are some announcements from the ship PA informing the crew at what stage in the operation we're at. I should mention that we just had helicopters, the MH-60s at the back of the flight deck just launched off and are in flight now to the recovery area. They play an important role here. Shannon, continuing now with our interview, when you look at the operation as a whole, they're currently trying to determine how the astronauts will be recovered. That's not happening today.
That's right.
But that will have to be integrated into the operation. Do they come off immediately after the crew splashes down? Or there's an idea kicking around there to have them stay in the capsule and come to the back of the ship. What are your thoughts on both of those? What are the pluses and minuses on those?
Well, certainly the plus of having the crew come off immediately is that the crew is not staying in the capsule for an extended period of time. There'll be a time when we'll have to turn off the cooling in the capsule, which would mean the crew will start getting very warm in their suits. So it's better to get them off before that. Also, you'll probably see later the operations in the well deck. There are a lot of waves in there, and it's probably not going to be a fun ride for the crew to be in there. So you're right, we're looking at it. The actual, let's see, next summer, we're going to have another test run. We'll be out on a ship, and we will be looking at all the different methodologies for getting crew off the capsule.
And may I ask what your particular favorite would be? I mean, I think you've already kind of indicated you're leaning more towards, let's get off the ship.
Off immediately. Yeah, so I think we will probably, and now don't quote me on this, but we'll probably extract the crew via helicopter from the capsule and helicopter them over to the ship.
And as an astronaut, just briefly, when you come back from space, physically, you're in a condition where how would you describe it, physically and mentally?
Yeah, so when we come back, we consider a crew deconditioned. While on the space station, for example, we have lots of exercise, so we're really strong when we come back. It is still a big adjustment to being in Earth's gravity again. The lunar missions, it's kind of in the middle between what we did in the shuttle days and what we're doing on the space station. So we don't know exactly how the crew's going to feel, but they're going to be exhausted, and so their balance may be off a little bit. So it's better just to get them out of the capsule. As far as the mental side goes, I found that when I am back on Earth, it's just a huge sigh of relief in that somebody else is worrying all the details, and I can just sit and relax a little bit.
Well, we appreciate you being here. Thank you for all the insight. You're doing a great job of staying balanced amidst the 4 to 5 foot seas as you see the horizon going up and down, right?
It is definitely a challenge.
Thank you very much, Shannon. Rob, we'll send it back to you in Houston.
Thanks, Darrell. Thank you, Shannon, and happy sailing out there as we continue to watch this scintillating view of the Earth, as we are just 1 hour, 5 minutes away from splashdown. Now, as Shannon Walker alluded to in that interview with Darrell Nail on the USS Portland, we're going to be on the air here for a couple of hours after splashdown while a number of flight objectives and test objectives are being conducted, data gathering on the Orion spacecraft. But the whole recovery issue to get Orion into the well deck of the USS Portland is no small feat. Melissa Jones, who is the landing director and the recovery director from the Kennedy Space Center, has worked tirelessly to choreograph all of the elements of that recovery operation. Let's take a look now at how Orion will be recovered.
Today we are aboard the USS John P. Murtha, and behind me is a mock-up capsule of the Orion crew module, and we are training the team to be ready to do Artemis 1 recovery operations. My role as the NASA Recovery Director is to lead the interagency team that will recover the capsule. Ever since the Apollo program, NASA and the Navy have worked together to recover NASA's capsules in the water. So one of the huge benefits of working with the Navy is the fact that they're operational and we leverage their core competencies to bring the flight hardware and the crew back safely from the moon. On the Artemis 1 recovery day, my job will be to direct the team through the integrated operation to recover the capsule. The ship will get to the recovery location 24 hours before, and we will start launching weather balloons. And that data will go back to Houston and will help inform where we splash down. A couple hours before splashdown, the Navy launches small boats off of the knuckle boom crane, and helicopters will take off and they will do their circles in the air, and they are waiting for the capsule to re-enter so that they can get good data and photo imagery of the capsule on its way back to Earth. Once that is done and we splash down, we will safe the capsule, approach the capsule, attach lines to the capsule, and recover it into the well deck of the ship. Artemis 1 recovery operations will take about 5 hours to perform all of the work we need to do because we are gathering data so that we can fly crewed mission on Artemis 2. When Artemis 1 splashes down, it's going to be the culmination of all of the hard work that we've put in as a team. It's going to be an amazing feeling, hearing that we've met Earth's interface and that we can see 3 good main parachutes. And when we hear splashdown, I'm going to get goosebumps all over me.
And again, that whole recovery operation will take several hours. We are going to remain on the air for at least 2 hours or so after splashdown so that we can bring you all the information regarding the initial safing of the vehicle and the test objectives that the flight control team here in Houston, led by Flight Director Judd Freeling, will be absorbing all of that data, mostly about the thermal conditions of the spacecraft, which will have come through some 5,000 degrees Fahrenheit in entry. And with us at this moment is the man who is going to be watching all of that very, very carefully, John Kowal, who's the Orion Thermal Protection System Manager. John, your big moment is lying ahead here. The plunge back into the Earth's atmosphere. This is the moment of truth to test the heat shield. What kind of thermal environment are you expecting for Orion as it makes its way into the Earth's atmosphere and then back through the atmosphere itself?
Yeah, so, as you mentioned, 5,000 degrees on the ship, but to back that up, how do we get there? So that vehicle still has all that energy that the launch rocket put into it during that first beautiful launch, right? So that gets converted into velocity. So we're going at 25,000 miles per hour, which is, how do you even fathom what that means? It's 7 miles per second. Wow. So all that energy, enough to power 4,000, 5,000 homes in a day, we have to get rid of it. And how do we do that? The vehicle comes slamming into the atmosphere, starts trying to push the air out of the way. That air is pushing back. The pressures go up. The temperatures go up. We're talking upwards of around 10,000 degrees Fahrenheit in the flow field. So that energy goes into the flow field, and then the flow field wants to give it back to the surface of the TPS. So that's what the TPS is going to see, or what the heat shield is going to see, and that's what pushes it up to 5,000 degrees Fahrenheit.
What kind of testing was required throughout the course of the preparations for Orion to prepare the vehicle for launch that made you confident that it could withstand the rigors of this sort of environment?
Yeah, there's been a lot of testing. I mean, we've been at this for since the end of the shuttle program, if you think back to that system, that was a reusable system, we had kind of been out of the business of these ablation materials for quite a while, since Apollo. So we had to train a whole new generation of engineers on developing that type of system, as well as getting the materials back. So there was a lot of testing in arc jets. That's the primary way that you test these types of materials. You can create these temperatures. It's like a wind tunnel with a lightning bolt going down the center of it, and that's how you create this high temperature plasma, and that gets impinged onto the test article. So we do a lot of materials testing. We've done quite a bit of testing of the system. You know, even though we're using the same material, the AVCoat that they used in Apollo, it's in a different form. And so we made it into blocks. Those blocks have seams that have to be filled. Those seams are always one of the areas that you want to test the most, is because that's where the problems happen. And so we've done a lot of testing there in the thermal, and also structurally we've had to do a lot of testing to see how the AVCoat blocks interact with the structure underneath, and make sure that it's all going to hold up to those loads.
And John, it's about 11 minutes or so from the time of entry interface at an altitude of about 400,000 feet until we come out of that second blackout period. So that's going to be a very interesting time, a sort of a nail-biting time, if you will. But after the vehicle splashes down and is back at the Kennedy Space Center in a few weeks for post-flight analysis, what are the sorts of things that you and your engineering team will be looking for to give it a passing grade in preparation for putting a crew on board a couple of years from now?
Yeah, there's a couple things that we look at. I break it into two different categories. The first is the flight data. We have instrumentation embedded in the heat shield at a number of locations. So we measure temperatures, we measure heat rates, we measure pressures, stresses. All that data will tell us how the material actually performed in that flight environment. It will also help us to inform our computer modeling methods, and that's another thing that we need to make sure that it's performing how we thought it was going to perform, so that we can use those models in the future, you know, to predict for other missions. Now, the other thing we'll do is we'll be looking at the hardware itself. You know, the instrumentation, you only get measurements where you put that instrument, of course, right? But looking at the heat shield, just looking at it, the big picture, you can see the streamlines, you can see how the flow was going across the heat shield, you can see where boundary layer transition may have occurred. So there's so much to just visually see, and then we'll be taking samples of the heat shield, we'll be taking that material out and looking at how much had ablated, looking at the char thickness, the density gradients as you go through as the material burned off, and comparing that to what our models have predicted. And again, that'll help us to be able to validate and correlate our models further.
Very good. It's going to be a very important time for the engineers, of course, and we'll see how Orion fares here in the next hour or so. John Kowal, Orion's Thermal Protection System Manager, thanks very much for joining us this morning.
Sure. Thank you.
Now just 16 and a half minutes away from the separation of the crew module from the European service module. That will begin a trip hammer series of events as Orion begins the process of entering the Earth's atmosphere. Entry interface just 36 minutes away. So let's go back out to the Pacific Ocean west of Baja, where Daryl is on the USS Portland. Daryl?
That's right, Rob. A quick update for you on the out here in the Pacific Ocean, just off the coast of Mexico. We have the small boats, the Navy small boats. All 6 boats are now in the water. They call them cricks. These are Navy boats that are inflatable, highly maneuverable. These are the ones that will actually put hands on the spacecraft in order to secure it and eventually get it tied to lines that brings it to the back of the ship and into the well deck. I want to talk a little bit about this location here today. This location in the Pacific, we're just about 5 miles away from the splashdown area. This was actually the backup location. Initially, this was supposed to happen off the coast of San Diego, California, but the weather forecast for that area called for a cold front that has moved in today, bringing with it 12-foot high seas, and those seas would have been too high to perform this operation, too high for the small boats for recovery. So Recovery Director Melissa Jones and the mission management team made the decision to back up and go to the backup location 300 miles south of San Diego, and that's where we find ourselves today with excellent weather in order to do this operation. As you look off into the sky, we're awaiting the second to last weather balloon release that we will have for the day. This weather data critical to the operation that is happening today, especially when it comes to the landing point of the crew module in the ocean, as well as the debris that goes with it. And that debris happens during the separation of the forward bay cover, which covers the parachutes, and then of course the parachutes and their hardware themselves. All of it together, they take in the winds, and you can feel the winds are picking up a little bit. That wind data will give us refined information and data in order to calculate exactly the landing spot. Now, we're not alone out here in the Pacific Ocean. We do have friends helping us today, and I want to take a shot now of a ship off in the distance that has joined us for today's operation, and that is the USS Montgomery. That ship is just a few miles away. As you can see it there, the USS Montgomery is providing security today. It is what the Navy calls a littoral ship. It specializes in close-to-shore combat. It's highly maneuverable in that space. Today, though, it has a peaceful mission, and that is to provide security to this location during splashdown. So for the public safety, to prevent boats from coming in and around the area, as well as provide additional eyes to the sky in tracking Orion crew module as it comes down. You can see a little bit of a bounce there, and that's caused by the seas that we are currently experiencing, which are in the range of 4 to 5 feet. Those seas closely tracked by our NASA team with a wave management system. They are wave monitoring system rather. They are closely monitoring the seas for the moment where we bring the Orion capsule into the well deck. That is a highly choreographed and very dynamic operation. With the seas being what they are, when those waves come into the well deck, it can create a very dynamic environment with waves splashing back and forth inside the well deck, and teams on ropes trying to stabilize Orion to get it in just the right position here on the ship to then allow the well deck to drain out, have the Orion crew module put in place for its ride back to San Diego. That's the latest from here on the USS Portland out in the Pacific Ocean. Rob, we'll send it back to you.
Thank you very much, Daryl. We can report that all of Orion's systems are performing magnificently at this hour. At an altitude of just under 6,000 nautical miles, we did lock up on the tracking and data relay satellite system. So Orion's telemetry is now being processed through the TDRS network. This worked in concert with the Deep Space Network throughout the course of the mission. And now that we're on TDRS the rest of the way, we'll be able to have real-time data through our tracking and data relay satellite system constellation. We're just 11.5 minutes away from crew module, service module separation, the first major milestone on the road home in this final phase of Orion's 25.5-day mission. So let's take a visual and interactive look at what is coming up for Orion's journey back to Earth. Let's go back to NASA's Philip Hargrove at the moon board.
Thank you. Welcome back to the moon board. So we're going to talk a bit about the European Service Module and the Orion Crew Module. So as we know, these two systems have been working in tandem for a really long time, and that extends beyond just this Artemis 1 test flight for the past 26 days. So back in 2019 was when they were first integrated and pieced together. In 2020 was when they were fully assembled, including the solar panels and the protective fairings that protected them during launch. And then they were finally attached to the launch abort system and made it on top of SLS in October of 2021, prior to, of course, launch on November 16th, just 26 days ago. So we know that one of the primary test objectives of this mission is to make sure that this heat shield at the bottom of the crew module is able to safely bring our astronauts home from deep space. Now, for reference, when we bring astronauts home from the International Space Station, they're coming in at about 17,000 miles per hour. But today, Orion is coming in at 25,000 miles per hour. So we're coming in way hotter, way faster than we have done before. So we need some new heat shield technology. And we also need some additional hardware in order to slow us down and make that really happen. So let's talk about what that looks like. So this forward segment of the Orion crew module is called the forward bay cover. And this section is actually designed to completely be pulled off by 3 parachutes. So we have 3 parachutes that's going to pull that off. We have 2 drogue parachutes that are going to come out after that to slow us down a bit. We have 3 pilot parachutes that are going to pull our mains out. And then the stars of the show are 3 main parachutes that measure up to 116 feet in diameter each. So that gives us 11 parachutes that it takes to get us safely back home. So now that we know a little bit about what that hardware looks like, we can take a look at what that journey actually looked like. So, as we know, we had a 7-day return transit, and as we approached the Earth, the service module and the crew module separated from one another, and the service module is going to burn up in the atmosphere above the Pacific Ocean. As that happens, the Orion crew module is going to use its reaction control thrusters to do a 180 flip and point that heat shield towards the atmosphere as we target re-entry. So a really important phase here is entry interface. This is at an altitude of about 400,000 feet, and this is where we define a lot of our entry conditions, such as the flight path angle and the velocity. Now this is really important because if you come in at too shallow of an angle, you may bounce right off the atmosphere and not even re-enter. But if you come in too steeply, you're going to experience forces that are beyond the design of your spacecraft. So what we're going to do today is actually toe the line and do a nominal skip maneuver where we're actually going to bounce off once. That allows us to have a steeper re-entry, and that actually increases the heating, allowing us to really test the capability of that heat shield. And we will also be minimizing the G loading, which leads to a softer ride for the Moonican and in the future for our Artemis astronauts. Now, once we do that, the atmosphere is going to slow us down pretty significantly, but we'll still be going over 300 miles per hour. And then we will slow down to 20 miles per hour after that sequence of 11 parachute deployments. Now, once we splash down west of California, we will have these red inflatables that will make sure that no matter what orientation we hit the water at, we will be right side up. And then the USS Portland is going to recover the capsule and bring it back to the U.S. Naval Station in San Diego. Now, there's a really large team comprised of U.S. Navy, Air Force, NASA, contractors who worked really hard to prepare for today. So I am super excited to see them welcome Orion home. Back to you.
Thank you very much, Philip. We are coming up on the critical stuff leading up to Orion's return to Earth and its splashdown in the Pacific. Just 7 minutes away now from crew module, service module separation. That European service module has worked like a champ throughout the course of the mission. The service module, which of course housed the solar arrays and all of the other propulsive functioning for Orion throughout the course of the mission, has been monitored in the European service module control room in Noordwijk in the Netherlands, where that team of flight controllers is eagerly awaiting the completion of the service module's work just a few minutes from now, when it will pyrotechnically separate from the crew module, leaving the crew module on its own. Entry interface is scheduled just 26 minutes from now. We'll be receiving reports from Flight Director Judd Freeling and his team of flight controllers throughout Orion's descent back into the Earth's atmosphere and through all of the parachute deployment sequence events leading up to splashdown that is scheduled at 11:39 and 42 seconds a.m. Central Time, 9:39 and 42 seconds a.m. Pacific Time. One thing worth noting is once Orion splashes down in the Pacific, it will stabilize in one of two positions, either pointed up, which is called stable 1, or pointed down in stable 2. The crew module uprighting system, known as the CMUS, deploys a series of 5 bright orange helium-filled bags on the top of the capsule that will either flip Orion right side up or keep it right side up in its stable 1 position. Those 5 bags are packed in hard containers and installed atop the capsule inside the structural gussets between the parachutes and other equipment. They're inflated with helium gas that is stored in pressure vessels located close by the bags. Each bag has its own independent inflation system. The CMUS, or crew module uprighting system, initiates after landing and opens up a valve for helium to flow into those uprighting bags. It is considered, at least operational, that we have 4 out of those 5 bags to inflate to maintain a stable 1 configuration for Orion to enable Navy divers to approach the vehicle. One of the first things that they'll be looking for is any leakage of toxic gas or toxic fuel from the vehicle. Assuming there is no such leak and that Orion appears to be in good shape, then they'll begin the methodical process of approaching the vehicle with other personnel and other Navy assets in order to begin the securing of Orion on the ocean for its towing back into the well deck of the USS Portland. We're under 4 minutes now until the crew module and service module separate from one another. We'll be standing by for all of that. You can see in this telemetry-driven animation that Orion is currently traveling just under 17,000 miles an hour, just under 4,000 miles away from Earth, and a hefty 254,000 miles from the moon, which of course was its target, in distant retrograde orbit, flying around the moon for its outbound powered flyby at the beginning of the mission to move to a distance of some 268,000 miles away from Earth, farther than any human-rated spacecraft designed to return to Earth had ever been designed to do, surpassing the distance record established 52 years ago during the Apollo 13 mission. Here in Mission Control, the flight dynamics folks and the guidance, navigation, and control folks have put up a graphic which is essentially the ground track for Orion as it will make its way across the southern Indian Ocean, passing the northwest coast of Australia en route to its ultimate trajectory that will carry it across the Pacific. It will be moving from south to north across the Pacific Ocean to the splashdown zone, almost a direct straight line towards the point of splashdown, which will be west of Baja California. Now just under 2 minutes until crew module, service module separation. Now just 1 minute away from crew module, service module separation. We'll be standing by for confirmation of that from the mechanical systems officer here at Mission Control. 30 seconds until separation. This will come at an altitude of 3,200 statute miles. Ten seconds until set. We have confirmation of separation. Orion flying on its own. Again, the separation occurred right on time at 11 a.m. and 11 seconds Central Time, with Orion 3,200 statute miles away from Earth. The service module, the European service module, has done its job. So with Orion flying on its own, we're about 18.5 minutes away now from the point of entry interface, where Orion will be put through its paces. This is where the heat shield will begin to feel the effects of peak heating of 5,000 degrees Fahrenheit on the heat shield, and the beginning of 2 blackout periods where the plasma around the vehicle will build up such that it will block data and communications between mission control and the spacecraft itself. Orion continues to fly smoothly on, all of its systems in excellent shape. Less than 17 minutes until entry interface. And the crew module raise burn that we thought was not going to be needed is being conducted. Just basically a fine-tuning of the orientation and the angle, a 16-second firing of the thrusters, and a good burn reported, 8.12 feet per second, and a change in velocity. So the raise burn was executed. That will further fine-tune Orion's path at the proper azimuth or orientation, where the heat shield is at its optimum angle, to begin the repulsion of the heat that will build up around the heat shield at the time that we begin entry interface, just about 15.5 minutes from now. So the crew module service module separation went off as planned. The raise maneuver was executed at 11:03 and 41 seconds Central Time. Again, the raise maneuver was executed. Orion now flying at the proper orientation for entry interface into the Earth's atmosphere. Entry interface is scheduled at 11:20 and 14 seconds a.m. Central Time at an altitude of 400,000 feet. At that point, Orion will be traveling 24,464 miles an hour with a range to splashdown of 3,659 statute miles. Flight controllers reporting a solid lock with the tracking and data relay satellite system, receiving data that's being processed through the TDRS network. Just a reminder that after we pass into the Earth's atmosphere, at the speed at which we're going and with the temperatures expected to build up very quickly for peak heating around the heat shield of Orion, we will begin the first of two blackout periods, the first of which is scheduled to begin at 11:20 and 16 seconds a.m. Central Time and will last about 4 minutes and 48 seconds. At that time, entry guidance, which has been stored on board, pre-programmed commanding for Orion to continue to point its way toward the splashdown zone, will take over. The first blackout period should end around 11:25 and 4 seconds Central Time. That will set the stage for the skip entry, basically the maneuver that will enable Orion to dip into the Earth's atmosphere and skip back out of the Earth's atmosphere and dip back into the Earth's atmosphere like a rock, a flat rock on a pond. That will continue to dissipate energy and heat on the spacecraft, and is a maneuver that data will be gathered for to try to bring in multiple splashdown sites for crewed missions in the future. The second of the two blackout periods is scheduled to begin at 11:29 and 3 seconds a.m. Central Time, and that will last for about 2 minutes and 50 seconds till about 11:31 and change. That'll be the final blackout period, after which we should lock up solidly for the remaining 8 minutes or so until splashdown. This is Mission Control Houston, 12 minutes away from entry interface. Everything is going by the book so far here in Mission Control, very quiet on the loops. Entry Flight Director Judd Freeling and his team of flight controllers watching carefully over their data as they oversee the arrival of Orion for its splashdown site west of Baja, California. Time to splashdown 31 minutes. Less than 11 minutes now until entry interface. During the period of the two blackouts, and even after we have emerged from the second of the two blackouts, Orion, through a series of pre-programmed commands stored on board, will conduct a series of role reversals This is very much like space shuttles conducted during their entries back to Earth, where it will roll to the left and then back to the right, banking roll reversals that will bleed off excess energy, excess inertia, and speed, and control the thermal characteristics of the vehicle as it heads towards its subsonic point, where it will go under Mach 1. It will go subsonic at about 11:34 and 55 seconds a.m. Central Time, some 5 minutes before splashdown. If everything goes as planned, Orion will reach an altitude of 40,000 feet at 11:35 a.m. Central Time, just about a minute before forward bay cover chute deploy begins, the series of 11 chutes, 3 that will pull the forward bay cover off of the top of the crew module. That'll be followed by the deployment of the drogue chutes, and then the 3 large main parachutes, 3 orange and white parachutes. That'll be the moment we'll be waiting for. Orion now 28.5 minutes until splashdown. Orion is approaching the northwest coast of Australia. 27.5 minutes until splashdown. We're just 8 minutes away from the point at which Orion will dip into the Earth's atmosphere and begin what basically is a hellish entry, where temperatures around the spacecraft will raise to about 5,000 degrees Fahrenheit. That's half as hot as the outer surface of the sun. And correction, Orion is actually traveling over the South Pacific at the moment, moving from south to north. Just 7.5 minutes until entry interface. And this view from a camera inside the cabin of Orion, this doesn't look like much at the moment, but it will soon when it shows the forward bay cover jettisoning and the initiation of the parachute deployment system. Entry interface less than 6.5 minutes from now. Just to recap, the crew module, the Orion crew module, separated from the European service module about 14.5 minutes ago, right on target as it was planned, and a short raise maneuver, a 16-second firing of Orion's thrusters, oriented the vehicle, raising it just a tad so that its heat shield was at the proper orientation in the direction of travel, to begin entry interface in about 5 minutes at an altitude of 400,000 feet above the Earth. Orion is making its way south to north across the Pacific Ocean. Currently traveling at 23,000 miles an hour. We're about 5 minutes away from entering the first of the 2 blackout periods, which will last about 4 minutes and 48 seconds. A journey that began with the power of the launch of the Space Launch System 25.5 days ago, about to reach its final minutes in the searing heat of re-entry, where temperatures around Orion will build up to 5,000 degrees Fahrenheit. Just under 4 minutes until entry interface. Once again, at entry interface, which we will reach about 3 minutes from now, Orion will be at an altitude of 400,000 feet, traveling just under 25,000 miles an hour, with a range to splashdown of 3,659 statute miles. Within seconds after reaching entry interface, we'll begin the first of the 2 blackout periods that will last just under 5 minutes, about 4 minutes and 48 seconds. And here's the ground track for Orion as it passes well to the west of South America. We're just 1 minute, 44 seconds away from entry interface, moving from south to north to its splashdown target west of Baja California. Just 1 minute away from entry interface. And this view from the cabin camera, looking out of the upper hatch of Orion, you can see the limb of the Earth. We're going to be losing all of the data here shortly once we enter into the Earth's atmosphere and begin the first of the 2 blackout periods. Standing by for entry interface in the first of the 2 blackout periods. We are now in the entry phase. Entry interface has begun. Entry interface at 400,000 feet. Orion traveling just under 25,000 miles an hour. We've gone into the first blackout period. This is a visualization based on what should be happening at the moment, where the temperatures around the heat shield are reaching about 5,000 degrees Fahrenheit. This is the moment of truth for Orion. We should be coming out of this first blackout period just under 4 minutes from now. Orion should be traveling about 23,326 miles an hour at the moment. Range to splashdown, 3,125 statute miles. Again, this is a visualization of what should be happening with Orion at the moment, although we are in a blackout period that should end about 3 minutes and 15 seconds from now. Once we emerge from this first blackout period, we'll conduct the skip entry maneuver that will further dissipate heat and energy and begin a very, very dramatic reduction in the velocity of Orion as it approaches its splashdown site. Clocks here in Mission Control showing the sequence of events yet to come. The first blackout period to end about 2 minutes and 18 seconds from now. The second of the 2 blackout periods would begin about 6 minutes from now for about 7 minutes, followed by the jettisoning of the forward bay cover. That will begin the sequence of the deployment of the parachutes. First, a pair of drogue chutes, 3 pilot parachutes that will then pull 3 main parachutes to begin the final moments of Orion's descent back to its splashdown in the Pacific Ocean. One minute to go until we come out of this first blackout period. When we emerge from this first blackout period, we'll be at an altitude of 274,000 feet, traveling just under 17,000 miles an hour with a range to splashdown of 2,000 statute miles. Standing by for a reacquisition of signal. And we have data from Orion. Orion out of the blackout period. Flight Dynamics reports that Orion is right on the money, coming right down the pike. A good view out of the cabin camera looking out of the upper hatch of Orion. We should be performing the skip entry maneuver momentarily. Good communications established with Orion. The second blackout period to begin about 2 minutes from now. Orion is at the apogee of the skip entry maneuver, beginning the second in a series of role reversals, again banking maneuvers to bleed off excess inertia and to dissipate heat around the spacecraft. The start of the second blackout period, about 1 minute and 13 seconds from now, will come at an altitude of 270,000 feet, with Orion traveling about 16,400 miles an hour, range to splashdown less than 1,000 miles. Coming up on the start of the second blackout period. We should be in that second blackout period right now. Orion approaching a velocity of 20 times the speed of sound. If all goes as planned, we should be out of the blackout period with a solid lockup on the vehicle at 11:31 and 46 seconds a.m. Central Time. This is Mission Control Houston, the airborne WB-57, one of the airborne assets to track Orion's return to Earth, has visual acquisition of the vehicle. We should be coming out of this second and final blackout about 30 seconds from now. And helos flying off the deck of the USS Portland now have a visual acquisition of Orion as well, at an altitude of 174,000 feet, traveling 12,600 miles an hour, range to splashdown 288 statute miles. This view on the deck of the USS Portland. And there is a view out of the cabin camera of Orion as it continues a series of role reversals. We have data back from the spacecraft. Flight Dynamics reports Orion straight and narrow on a true course toward its splashdown site. Forward bay cover jettisoning less than 3.5 minutes from now. (150,000 feet off the ocean). Orion now traveling at Mach 10. Orion's speed now down to Mach 6. Two minutes until forward bay cover jettisoning. Orion 100,000 feet now. The spacecraft about to go subsonic. "45 seconds until forward bay cover jettisoning. Orion now at 50,000 feet. Forward bay cover jettisoning pyros are armed. 25,000 feet. Drogues have been deployed. Two good drogue shoots reported by the recovery team out in the Pacific. The descent rate is right on the money. Orion's velocity now down to 282 miles an hour. Range to splashdown 1.5 miles. 10,000 feet now. And we're on mains. 5,000 feet. Reefing in progress. Three good main shoots for Orion. We have three fully inflated main chutes. Time to splashdown 90 seconds. Perfect descent rate reported. And there it is, high over the Pacific, America's new ticket to ride to the moon and beyond now in view. Orion under its chutes descending toward splashdown. Orion in the perfect orientation for splashdown, just seconds away. (1,000 feet). Good descent rate. (500 feet). Splashdown. From Tranquility Base to Taurus Littrow to the tranquil waters of the Pacific, the latest chapter of NASA's journey to the moon comes to a close. Orion, back on Earth. Unofficial splashdown time, 11:40 and 30 seconds a.m. Central Time. At a mission elapsed time of 25 days, 10 hours, 54 minutes, 50 seconds. That's unofficial. Splashing down off the coast of Baja, California. The crew module uprighting system now being inflated for the bags currently being inflated. And we have a report that Orion is stable 1, upright, the way it should be. Once again, splashdown occurring at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, west of Baja, California, after a textbook entry for the Orion spacecraft, bringing its 25-and-a-half-day mission to an end. Orion's recovery beacon is on. We have confirmation that 4 out of the 5 crew module uprighting system bags have fully inflated, standing by for word on the 5th one. But Orion is in great shape, stable 1, just in the orientation that had been expected. This is Mission Control Houston. Once again, the Orion spacecraft, having completed a journey of 1.4 million miles, bobbing gently in the Pacific Ocean. 4 out of its 5 crew module uprighting system bags have been deployed. We're standing by for word on the 5th. However, irrespectful of that, it is in stable 1 configuration, in good shape, according to the recovery team. And we are now receiving word that all 5 of the crew module uprighting system bags are fully inflated. So that's exactly what we had hoped for. Orion safely bobbing up and down in the Pacific Ocean. This is Mission Control Houston. You're looking at the Orion spacecraft that splashed down about 6.5 minutes ago at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time. We are estimating that it splashed down around 5 nautical miles away from the USS Portland. The recovery ship and Navy boats and divers will be approaching the vehicle before long. The spacecraft is in what is called a stable 1 configuration, upright, just the way we had expected it to be. 5 perfectly inflated crew module uprighting system bags, maintaining a nice gentle configuration for Orion. First of the Navy helicopters now approaching the vehicle. And here in Mission Control, some of Orion's systems no longer needed are being powered down. Many of them will stay powered up for the next 2 hours while we conduct a series of test objectives to characterize the thermal conditioning of the spacecraft. That will be important for future data for crewed missions to determine how long the crews can remain comfortable inside a vehicle returning from the moon. We also will be conducting tests of the beacon and SARSAT system for maintaining tracking of the spacecraft, for recovery forces that will be approaching the spacecraft in the future. And coming up in the next hour and a half will be the reactivation of an ammonia boiler system that will provide cooling in the spacecraft, as it will when crews return from their missions on board Orion. This is Mission Control Houston. Reports from the USS Portland indicate that the first of 2 Navy helicopters flying in the vicinity of Orion, which is about 5 nautical miles away from the ship, indicate no damage to the spacecraft and no hazardous fuel leaking from the spacecraft. A good view of the helicopters and the initial Navy boats that will be approaching Orion a short time from now. Once again, the splashdown occurring at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time. This is Mission Control Houston. Orion in the Pacific Ocean, having splashed down at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, around 5 nautical miles or so from the USS Portland. A textbook entry for the vehicle. On the USS Portland at this hour, my colleague Daryl Nell from the Kennedy Space Center, who's with the Exploration Ground Systems Recovery Team. Daryl, how did it look to you? It certainly looked textbook to us here.
I'd say that's a great description, Rob. Perfectly landed here in the Pacific Ocean, and that's been confirmed by the operations manager that I just spoke to. Watching it from the deck as an observer, we have, as you can see, some broken clouds in the sky, like right around 3,000 feet. But we saw those 3 full main parachutes pop out. It was a beautiful sight, probably just about several thousand feet in the sky, and then we watched that slow descent as the Orion crew module made its way down to the Pacific Ocean. Saw the splash, and then of course the assets aboard the USS Portland here immediately started making their way towards the splashdown site, and as you see live now, they are close to being next to the capsule. Now the helicopters that you see flying there, those are MH-60s. We have 2 of them in the air, and they are right now gathering high quality, high definition imagery of the capsule in the water. There's a spotter aboard. We have photographers as well. The doors are completely open on both sides of the helicopters, and so you can see them flying a circular track around the splashdown location. They have marked, if you can see it, you can see what looks like smoke coming off a location just to the left there. That is the boats having marked location where some of the debris has come down, the debris that was part of the separation event, the part of the parachutes opening event. So you have the sabot as well as the lid from the parachutes. All of that is being tracked by the Sasquatch team, and the Navy boats are marking that with floatable smoke grenades. All of that hardware the team wants to recover because there's valuable information and data in it. The helicopters will be out for another 20 minutes gathering imagery. You can see one of them getting very close to the crew module. There is an GSS camera, ultra high definition, 8K, which is gathering imagery. We are currently on course to go right by the splashdown location, so we are right about 3.5 miles and closing. We are going to a point that's going to be 1 mile out. That's our next waypoint. 1 mile out from the splashdown location. One of the things we're waiting for is for ammonia boil off, and that's why the Navy boats are not yet next to the capsule. We're still going to wait that out. The amount of time that that's going to take is has not been determined. They have allowed for as much as 2 hours. The ammonia on the capsule is used for cooling purposes, to keep the cabin cool for crew. Of course, there's no crew in this capsule, but for future missions, it will certainly be an important part of keeping the astronauts cool during the heat of reentry. But for now, they're going to vent off that ammonia, and as they do that, it's not quite safe to get close to the capsule with the Navy divers. So of course we'll keep our eyes fixed to the location, our cameras as well. The USS Portland's standing by for our next waypoint, 1 mile from the splashdown site. And then once the completion of the ammonia boil off, the Navy boats will be going in. spectacular sight from out here, Rob. Toss it back to you.
Thanks, Daryl. Back here in Mission Control, the entry Flight Director Judd Freeling on the left. To his left, Flight Director Rick Henfling. And with me on console here, probably none more important than the NASA Administrator, Bill Nelson. Senator, thank you for joining us today.
Rob, I'm overwhelmed. I'd say it's good to see you, but this is an extraordinary day.
I remember years ago when I saw you return on Columbia from your mission into space, and it all conjures up a tremendous amount of memories. Orion back on Earth, having circumnavigated the moon, having survived a critical test of its heat shield, I think you have to be hesitant to celebrate and throw confetti a little bit too early, but it certainly is an important achievement, is it not?
It's historic because we are now going back into space, into deep space, with a new generation. Kennedy just stunned everybody with the Apollo generation and said that we were going to achieve what we thought was impossible, and did that in a short period of time. And many things have happened since, but we knew we were going back, but we knew we were going back to the moon just to continue to explore outward into the cosmos. And so that's why this is a defining day. It is one that marks new technology, a whole new breed of astronaut, a vision for the future that captures the DNA of particularly Americans, although we do this as an international venture. And that DNA is: we are adventurers, we are explorers, we always have a frontier, and that frontier is now to continue exploring the heavens.
We had to wait a while for Artemis to finally get to the point where the Space Launch System got us underway back on November 16th, but once it did, these engineers and the other members of the team's front room, back room, they've been pretty giddy over the amount of data that they've required and how this vehicle appears to have exceeded its expectations in its performance.
The whole vehicle, the rocket, the European participation in the support module, the spacecraft itself, Orion, performing so well that they added a lot of tests. And lo and behold, we're going to be up to our ears in data, thankfully. And of course, today the two main things that had to happen was that that heat shield had to work, and it did beautifully, where they can skip off the atmosphere and bleed that speed down from 25,000 miles an hour. And then the parachutes had to work, and they did it as well.
You know, the engineering, the design of this mission, all the work that will go into the next flight when a crew is on board, right, to orbit the moon. What does this say about NASA and the international partner cooperation and the partnership that ultimately takes us not only to the moon but beyond?
Well, it says a lot about our country because we don't do it secretively. We do it openly, and we do it with our friends, and we invite all peoples of the earth. And we are doing it also with commercial partners, because when we go into orbit on Apollo 3, we are going to rendezvous and dock with in this case, SpaceX lander, and the crew will go down to the surface. And then we have another competition going on now for another lander, so that we will have two landers. And again, this is the program of going back to the moon to learn, to live, to invent, to create in order to explore beyond.
50 years ago today, Gene Cernan, Jack Schmitt landed their lunar module Challenger on Taurus Littrow, the final lunar landing. It only seems fitting half a century later to the day, Orion back home.
And what a fitting opportunity that I had last night to sit with Jack Schmitt at the astronaut dinner and to talk to him about those experiences. 50 years, it's a long time, but look what we have done in the meantime. The space shuttle, we built the International Space Station, we brought in commercial partners. We now go to and from regularly the International Space Station with cargo and crew. Here we go. We've got scouts going to the moon that are commercial scouts that land, that take NASA instruments and scientific instruments in preparing us for the landings of our astronauts. And so it's a new day. A new day has dawned. An Artemis generation is taking us there.
And Orion continues to await the arrival of the USS Portland, which shouldn't be very much longer from now, and some flight test objectives that will be taking place over the next couple of hours before we here in Houston hand the vehicle over to the Kennedy Space Center recovery team. NASA Administrator Bill Nelson, pleasure to see you today, and thank you so much for being with us.
What a day. Oh, it is my great privilege.
This is Mission Control Houston, 26 minutes after the return of Orion from its circumnavigation of the moon and a splashdown in the Pacific, a bullseye splashdown, just about 5 nautical miles away from the USS Portland, as had been planned. The Portland about to arrive near the spacecraft, as you heard from Daryl Nail, who at this moment is standing by on the Portland with the woman in charge of the recovery operations, Melissa Jones. Daryl?
Thank you, Rob. That's right. Melissa Jones, the recovery director, just came from outside the ship's control center where she was monitoring and, of course, managing her team in the midst of this recovery. So, Melissa, thank you for being here.
Thank you for having me. This is an exciting day.
What a day it is, right? We just had splashdown, and I want to ask you, first of all, operationally, where do we stand and what do we have to go?
So we had a picture-perfect splashdown, and at this time we're gathering data. With the CM powered up, we'll get some flight test objective data on thermal conditioning, and we're doing some signal data with the tri-band beacons, making sure that we can see the beacons on the capsules and on the astronaut suits to prepare for Artemis 2. And once that is complete, the vehicle will be powered down by the Mission Control Center, and they'll hand that over officially to us here locally in the Pacific. And then we will approach the capsule and attach some lines to it and pull it into the back of the well deck.
And that's a delicate mission, right? Because you will be attaching lines, and through the use of Navy boats and then also a winch inside the well deck and Navy sailors on the lines attached to it as well. It seems like a very delicate operation, especially getting in the well deck where waves will be sloshing around. And we've got already 4 to 5 foot seas out here in the Pacific.
Correct. So it is a delicate balance to try to control the capsule in the well deck with all the water that we have in there, and to softly land it on the cradle so that we can capture as much data from the heat shield as possible.
Now, as the capsule was coming down, just briefly tell me your reaction that moment that it splashed down.
So when they called capture from the helicopters, it was the most amazing feeling. It's just been a long time coming. We've been working this mission for a while, and we've done a ton of training. And every time you do training with a mock-up capsule, you don't have any of that. You don't have parachutes. You don't, hear it coming back through the atmosphere, the sonic booms, and all of that kind of stuff. And today that actually happened. It's just amazing.
And your team, it's worth noting, has been out here a long time. From the moment of launch, you were on console, ready to support if something off-nominal happened, unusual. You were going to be able to recover that capsule wherever it was needed to recover. So you were working that and then stayed through Thanksgiving all the way to now. So it's been a long road.
It has been, yeah. Several of us supported launch, and then we deployed out here about 23 days before, and we're out here for Thanksgiving as a team. So we have been waiting for this and preparing for it for a while.
And it looks like you're doing a great job so far. Good luck the rest of the way, Melissa Jones, and thank you for joining us.
Thank you very much. Thanks for having me.
All right, Rob?
Thank you, Daryl. We'll be back to you on the USS Portland here shortly as the post-splashdown activities and the recovery operations will continue. As mentioned earlier, it will take about 2 hours from the time of splashdown until the time that Flight Director Judd Freeling and his team of entry flight controllers here will hand the vehicle over to the Exploration Ground System Recovery Team that will work over the next several hours to bring the Orion into the well deck of the USS Portland. With me, a familiar face, Bob Cabana, NASA's Associate Administrator. Bob, it's great to see you here. And with Orion back on Earth, another milestone accomplished on the road back to putting Americans on the surface of the moon. In terms of the criticality of what we've seen over the past 4 weeks, your thoughts on how this mission evolved and now the stepping stone that would put a crew on board a couple of years from now?
Oh, Rob, it's been absolutely critical to get this mission off safely. This test flight is what we need in order to prove this vehicle so that we can fly with a crew, and that's the next step, and I can't wait. The launch, first off, yeah, I was on the roof of the Launch Control Center. I went up there with the administrator and deputy administrator when we came out of the T-minus 10-minute hold, and it was phenomenal. It was absolutely amazing. The rocket performed flawlessly, and I haven't been that happy in a long time after we came down off the roof. And then to see the mission go as well as it did, the shots that we got from the vehicle, that one from 40,000 miles away where you saw the moon with the Earth in the background. And then this morning, I mean, we've learned how to operate this vehicle. A few minor glitches along the way, but it is performed flawlessly. And we're learning how to work with it, operate it. And that's what this JSC team does. It is so great to be back here in mission control, to be with the ops team. I'm so proud of these guys. Amazing. But if you were watching this morning, I loved the video. I don't know if it was on NASA TV or not, but the moon just the Earth just kept getting bigger and bigger. It was really hauling as it came in. And the preciseness with which they were able to bring it down and seeing the chutes come out, and it's just, I'm so proud of this team, the Orion team, the entire SLS, Artemis team, the folks here at JSC. It's just been amazing. I wish Gene Cernan were still alive. Here we are on the 50th anniversary, and Gene was such a proponent of getting us back to the moon. I wish he were alive to have seen this mission. It would have meant a lot to him.
I don't want to date you, but I think 24 years ago, at this moment in time, you were building a space station, I believe, with your crew on STS-88. We had so many dramatic, jaw-dropping images during the course of this flight. What for you was the most impactful moment?
Oh, I'm not sure I can pick one. Obviously, the launch. The team has worked so hard to get to the point where we successfully launched this rocket. I think the successful burns along the way to actually get that go for the TLI burn and do it and be on our way to the moon again. Absolutely awesome. I think the pictures that we saw. But the splashdown, how can you not? I mean, this was really emotional, going around and congratulating folks for what we did. So it's hard to pick just one. I think what has meant the most to me, more than just watching the mission, more than the mission highlights, is being with the teams at the Kennedy Space Center, at the Marshall Space Flight Center, here at the Johnson Space Center, and just being able to go up and talk to them and thank them for all their hard work that got us to where we are. I think it means a lot to me.
And Bob, final question. The next step, Artemis 2, putting a crew on a vehicle to orbit the moon. It's going to be a complicated mission. It's a long road. It seems like a long time from now, but based on what we've just witnessed, and based on what we believe will be the ultimate data flow out of this mission, it doesn't seem that far away, does it?
It is not that far away. It's going to mean a lot when we get the crew assigned, and we see them in training. We get that human face to this. I've seen the flight hardware at KSC. The Orion 2 spacecraft for Artemis 2 is there. It's in build. We got to get Artemis 1 back and transfer some of the black boxes across to make sure that they get checked out and everything works. You know, the rockets being built. We are on the way. And I think when you put a human face to that, when you actually see that, hey, we're sending humans to the moon again, and we're going to get this one-year cadence eventually where we're doing this on an annual basis, this is our future, and it's different from how we went during Apollo. We're going in a sustainable way. We're paving the way to go onto Mars, not just the moon and Mars, but to establish a presence in our solar system beyond our home planet, to explore, to have those technologies in space, to continue to learn and improve things here on planet Earth.
Bob Cabana, NASA's Associate Administrator. Thanks so much for being with us, Bob.
Rob, it is always a pleasure to share a mic with the voice of NASA. I think a lot of you, buddy, you know that. We've worked together a long time. You keep doing a great job.
Thank you very much, Bob. Bob Cabana, NASA's Associate Administrator, with us here in Mission Control. This is Mission Control Houston. About 37 minutes since Orion splashed down in the Pacific. On the deck of the USS Portland, as he has been throughout the course of the morning, Darrell Nail, my colleague from the Kennedy Space Center. Darrell, how are things going out there? It looks like you're about to approach the vehicle.
Yeah, we're very close to that moment, Rob, here on the USS Portland. We're just about 100 miles off the coast of Baja, Mexico. The operation, as you've heard and been commentating, it is going pretty smoothly at this point. But we are in a pre-planned waiting period as we wait for the ammonia that is inside the capsule. It is used for cooling. This is boiling off at this moment into the atmosphere, and until that's complete, the boats will be on hold. Now, the Navy divers right now at this moment are outside of the 120-yard radius around the capsule. That was part of the plan. They will close within just a few feet to start detecting if there are any hazardous gases coming from the capsule. But that will only happen once our recovery director, Melissa Jones, has given them the go to close in. The ship, meanwhile, the USS Portland, is on its way to close within 2,000 yards of the capsule. As you can see it floating there. The bags fully inflated that are used to upright it. Bright orange in color at the top of the capsule. The ship will then come alongside the capsule, and once the Navy divers have gone in and made sure that the capsule is safe to approach, they will begin taking imagery, photographs, both on the top side of the water, and then also they have Navy divers prepared to go underneath the capsule and take pictures of the heat shield, the all-important component of this capsule, which is the primary objective in terms of the test and this flight test, is to make sure that that heat shield works and works well. So fresh from space, they want to make sure that they have images of it preserved as it is now before the operation begins, where they pull it into the well deck of the USS Portland. That will involve the attachment of ropes, as well as a winch line that then connects to the USS Portland. The well deck of the USS Portland will be flooded to about 6 feet, and those Navy boats will attach their lines and then pull alongside the Navy vessel, connect to a winch line, and then carefully tow it into the well deck. Again, we are currently awaiting the completion of ammonia boil-off from the capsule. They've allowed for up to 2 hours, but it could take a shorter period of time. And once you see those Navy boats closing in, then you'll know that that ammonia boil-off is complete. Of course, we'll let you know when that happens. Live on the deck of the USS Portland, Rob, we'll send it back to you.
Thank you, Daryl. Daryl Nail on the USS Portland out in the Pacific, west of Baja, California. Back here in Mission Control as the flight controllers watch over the initial phase of the recovery operations. We're joined by the director of the Johnson Space Center, Vanessa Weich. Vanessa, great Sunday to have you here with us on Console.
Fabulous Sunday. What a great day. You know, it's amazing to me everything that has been accomplished throughout this entire mission. But being here with the team and seeing and witnessing this splashdown together, amazing, wonderful. I really can't describe how I feel.
You know, we were talking just a moment ago, it never ceases to amaze me how these missions are designed. The execution is one thing, but the design of the mission here by the flight control team, and just down the hall, by the way, there are humans orbiting the Earth in the International Space Station, so it's almost like a 2-for-1 here.
It is. I mean, you know, to me this week, and well, for the past 26 days, being able to come into the control center and know that we had teams controlling the International Space Station with our crew members on board, and we've had, as you know, successfully crews living off of this planet for over 22 years, but then in another control center where we're monitoring and making sure that the maneuvers, everything that had to happen on the Orion spacecraft, that was being tracked, followed, and, you know, data, anything that needed to be sent up was just done so perfectly and professionally. This team has trained for years. First, you got to plan the mission, as you know. Then you have to execute the mission. And so the years of planning, the years of getting ready, the preparations really paid off.
You know, after a team wins the World Series like the Astros did, you can celebrate for about 24 hours before you have to worry about spring training that's coming up. There's almost never a moment to breathe. Artemis 2, not too far down the pike.
Yes, absolutely. So for us, you know, this is great. We've accomplished Orion 1, this test flight, being able to test out the heat shields, those parachutes, as you saw, brought the spacecraft down. But now we have to get it ready for our crews to be on board. So all of the systems that we need to integrate for our environmental controls, those are things that will be new as we go forward for Artemis 2. And then it's the outfitting of the cabin. All the things, simple things you think about, if they're going to be going for 10 days. So we got to make sure that we have the food, we have the clothing, all of the things that they're going to need for their next trip. But there's a lot of additional training, there's a lot of additional planning that has to happen in order for us to be ready for Artemis 2.
Thank you so much. Vanessa Weich, the director of the Johnson Space Center. What a busy time this has been.
Oh, but I also, Rob, though, I want to say thank you and congratulations to all of the employees, our entire workforce here at NASA Johnson Space Center. But I also want to thank our European partners. I want to thank our industry partners. It took thousands of people to make this possible. And now the recovery that's being done by the Navy, just want to say major thank you to the brave individuals that are out, and they're going to be bringing the Orion spacecraft into the Portland, and then she'll be back going to Florida, and my friends in Florida are ready to receive her. We're super excited and just want to say thank you to everyone that has made this possible.
Thank you so much, Vanessa Weich, director of the Johnson Space Center. Time to celebrate just a little bit before we catch our breath and press on.
Yes, time to celebrate. Then we got to get ready for Artemis, too.
Vanessa Weich, thank you so much. Back here in Mission Control, it has now been 46 minutes since the splashdown of the Orion spacecraft to complete its 25-and-a-half-day mission. Flight controllers here in Houston are reporting that the vehicle looks great in the initial visual inspections being made by the helicopter teams, as you heard Daryl Nail reference just a short time ago. We just heard from Vanessa Weich, the Johnson Space Center director. Now let's turn our attention to the East Coast, to the Kennedy Space Center, where the director of the Kennedy Space Center, Janet Petro, is standing by with us. Janet, good afternoon, and what a moment as your exploration ground systems folks are hard at work out in the Pacific.
Absolutely. Thanks, Rob. It's been a really, really exciting morning, and can't wait for our teams to get to work out there on the West Coast.
You know, we heard a short time ago from Melissa Jones from the deck of the USS Portland. How complicated has been the development of this recovery operation that your team is executing as we speak?
Well, it's pretty complicated, but you know, our teams make it look easy. I will start out by saying, or giving, I should say, a big shout out to really Vanessa and her flight ops team and the whole Orion team to deliver an amazing mission, bringing us down through splashdown. But now it's over to Melissa and her team, and she's done an incredible amount of work to get to this point. You know, what we do at NASA, it really is all about collaborations, and the collaborations that we've had with the Department of Defense in particular over the past many years, their hard work and their dedication as they went through a great deal of planning, hardware development and processes, and a lot of practicing to get to this point and make it look easy. You know, that capsule sitting out there on the ocean, it looks very similar to the Apollo capsule, but it's actually about 30% larger. And so the complexity of recovering that larger vehicle is a little bit more. But Melissa and her team have been practicing, you know, their latest underway recovery test. They completed, it was the 9th one, and they completed that last November 21st of last year, 2021. So they're ready. watching these teams precisely perform these recovery operations is amazing. And so I think we're going to have a really, really great day. I'm going to be traveling to San Diego to watch the ship come in port in a couple days. So I look forward to seeing that capsule on board the well-decked ship.
Janet, there's a lot of work to be done before Artemis 2, but the first milestone here will be getting the vehicle back to your center in Florida for a detailed inspection and detailed analysis. What's the basic timeline for all of that work?
Yeah, so splashdown today is really the beginning of the journey back to KSC. So as I mentioned, I'll be there in San Diego when the ship comes into port in a couple of days. And then Orion will then be loaded onto a truck and transported back to the Kennedy Space Center. And that's going to take a couple of days because of road-related conditions. You know, the Orion will still have some residual hazardous waste on it. And of course, planning the roadways as it gets trucked back to the Kennedy Space Center takes some careful navigation. So by the end of this month, the end of December, we expect to have Orion coming back onto our center. We think that's going to be a really great Christmas present for us here at the Kennedy Space Center. And it'll go right into our multi-payload processing facility for its post-flight assessment. And that's where the remaining residual hazardous fluids will be removed from it. And then just after the new year, the teams will be opening up the hatch of the Orion, and then once that's complete, I think Rob, you called it the moment of truth. They'll remove that heat shield and begin a really detailed inspection and assessment of how that heat shield performed during its reentry and recovery operation. So we're really looking forward. I know the whole team's really looking forward to see how that assessment comes out. And then after that, it's Orion's journey is not done. It'll be making its way up to the Glenn Research Center, where it will be doing some acoustic and further environmental testing up at that center. So journey isn't over. It's just kind of making its way here on the terrestrial path back. So thanks.
Janet Petro, the director of the Kennedy Space Center, joining us here today. Congratulations, Janet, and thanks so much for being with us.
Thank you, Rob. It's a great capstone to our 60th diamond anniversary to have splashdown, successful splashdown. So take care. Thanks, Rob.
Thank you again, Janet Petro, the director of the Kennedy Space Center, joining us today. Orion safely upright in stable 1 as the Navy and Exploration Ground Systems team continue to approach the vehicle in the first of a multi-hour choreography that will bring the vehicle into the well deck of the USS Portland. On the deck of the USS Portland right now is Darrell Nail, who has NASA astronaut Shannon Walker with him once again, post-splashdown this time. Darrell, how are things going out there?
Rob, we've got a front row seat to this operation. As you can see behind me, Shannon Walker, as you mentioned, NASA astronaut, joining me with this incredible view as we watch that capsule floating in the Pacific Ocean just 100 miles off of Baja, Mexico. We have an MH-60 Nighthawk helicopter encircling it and the Navy boats in the water. First of all, Shannon, how about this view?
It is an amazing view and so exciting to see the Orion capsule back on Earth.
That is a human-rated capsule that went around the moon and returned and is now in the Pacific Ocean. As an astronaut, what kind of thoughts do you have seeing a moment like this?
Well, it's actually really emotional to see something like this, knowing that the next time we're going to have people on that capsule or the second Orion capsule. It's pretty amazing that we're going to be able to go back to the moon soon.
Incredible indeed. And as we look at, let's paint the picture for the audience as we look out at this operation. Currently in a moment where we are pausing for ammonia boil-off. That's the cooling that the Orion crew module uses to keep the astronauts cool inside the cabin as they wait to be taken out of the capsule. There's none in this one, but this would be a period in which that would happen. You can see the Navy boats. They are roughly outside of 120 yards from the capsule. They have equipment that will sniff out any hazardous gases near the Orion, and so they are holding in position until that ammonia boil-off happens. And then also in your view, you can see the MH-60 circling back around. It is leaning so the photographers inside and a high-resolution camera mounted on the side can get imagery of the capsule fresh from space. And my question to you, Shannon, is as we watch this continue to wait and for the Navy divers to get closer, thoughts of Artemis 2 now come to mind. You've heard folks have been talking about it. Rob has been discussing it with many of the leadership around NASA. People want to know, well, who are the astronauts going to be for Astronaut 2?
Yeah.
So, any idea?
That is the question. No, I have no idea. Once we get this capsule back, we'll look it over and we'll be able to determine when Artemis 2 will actually be able to launch. And once we know that launch date, we'll figure out the right time to name the crew based on the training flow.
So there's actually a period of training in which you have to do a set amount of time to get ready for that, but really predicated on Artemis 2 and that launch date?
Absolutely. We don't want to have the crew just spinning their wheels if Artemis 2 is going to be a long way out, but I don't think it will be. So I would say sometime in the next 6 months, maybe. Is it just a guess? Don't hold me to it. We might be naming the crew.
All right, very good. Shannon Walker, NASA astronaut, thanks for joining us today. One quick update and note, the recovery team was looking at the possibility of recovering the parachutes as well as the forward bay cover, but that is not going to happen this time. They did mark their locations, but they did slip below the surface of the ocean, and so no recovery of the parachutes or the forward bay cover. That's it from right here on the USS Portland. Rob, we'll send it back to you.
Daryl Nail on the deck of the USS Portland with NASA astronaut Shannon Walker. It's been almost an hour since Orion splashed down. Everything with the entry and splashdown went by the book. If you weren't with us for the final minutes of Orion's descent toward the Pacific Ocean, we have a replay after the deployment of the three main chutes, which were pulled out in sequential fashion after pilot parachutes and drogue chutes were deployed. The main chutes came out. They reefed in perfect fashion, slowly descending towards the splashdown that was marked at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, at a point about 5 nautical miles or so from the USS Portland, west of Baja California. Orion entered the Earth's atmosphere traveling 25 times the speed of sound. It decelerated to a splashdown velocity of just under 100 miles an hour. It was a very gentle splashdown for Orion. All of its entry milestones were performed in perfect fashion. 2 blackout periods in which the plasma around Orion built up, preventing data and communications with the spacecraft as a natural function of the heat of reentry, which was about 5,000 degrees Fahrenheit, twice as much as re-entering space shuttles and other crewed vehicles have experienced. But although some analysis must be performed now, and there's the splashdown itself as it occurred, analysis, as you'll hear in a moment from our next guest, must be conducted to make sure that everything went as had been prescribed on the heat shield particularly. And there's a live view of Orion as the Navy boats with the Navy divers and other recovery personnel begin to approach the spacecraft. With us here in Mission Control is Michelle Zahner, the Orion Mission Planning Lead from the Vehicle Integration Office. Michelle, thank you for joining us today. And I guess the natural and the big question is, unbelievable that all this just ticked off in trip hammer fashion the way it was designed.
Yes, it was an incredible mission. So we accomplished all of our major mission objectives. The vehicle performed every bit as well as we hoped, and even better in a lot of ways. So as an example, the solar rays generated more power throughout the flight than we expected. So this is the furthest any human-rated spacecraft has ever gone, and that required a lot of complex analysis and mission planning and trajectory planning ahead of the mission, and to see it all come together and have such a successful test mission was amazing.
Michelle, it was a test flight, of course. There was a lot of risk involved, an elevated risk because there was no crew on board, and you could take, shouldn't say liberties, but you could expand the envelope of what you needed to do in order to acquire the data that you were looking for in order to set the stage for the next mission when a crew will be on board. From a vehicle standpoint, sitting in these mission management teams, sitting with your engineers on a day-to-day basis, how much data did you acquire, and how long do you think it's going to take to pore over this so you write the textbook of Artemis 1?
Yeah, we acquired a ton of data during the mission. So one of the first things that we'll do post-mission is take several months to go back through that data, really dissect it, and understand the vehicle performance. You know, we did a lot of testing and analysis prior to the mission, but nothing really compares to seeing the vehicle perform in the harsh space environment. So that's certainly going to be our first focus after the mission is looking at all that data. And as you mentioned, you know, we pushed the vehicle further than we probably would with the crew on board, but through that, we learned a lot. We learned that the vehicle is more robust than we thought in many areas, and so taking that information and expanding our operational envelope will help as we go forward to more complex missions in the future.
And in the Orion Vehicle Integration Office, for yourself and your colleagues, it's almost like wearing two hats. You have to go back and pore over the data from this flight, but now you got to prepare a vehicle that will sustain a crew, including an environmental control system, a life support system for the crew itself. How are you all going to juggle all of this work over the next couple of years?
Yeah, there is a lot of work that goes on in parallel. So as I mentioned, I think the post-flight review is going to be the top priority for the first few months. But at the same time, the crew module and the European Service Module for Artemis 2 is already at Kennedy Space Center. It's already being put through the paces in testing. So that vehicle is already there. After splashdown here, there are some avionics that we're going to take off of the Artemis 1 crew module, refurbish, and then install in the Artemis 2 crew module. And then, as you mentioned, we have the new environmental control and life support systems and a lot of other crew interfaces like crew displays, and all of that is in the process of being integrated and tested. So we celebrate Artemis 1 today, but tomorrow we get back to work and we start focusing heavily on Artemis 2 and making sure we have a successful first crewed mission.
You're going to have to delay those vacation plans just a little bit. Michelle Zahner from the Orion Vehicle Integration Office, thank you so much for joining us today.
Thank you for having me. Appreciate it.
Back here in Mission Control, about an hour and 2 minutes now since the splashdown of Orion. Just about 5 nautical miles away from the USS Portland, which is approaching the vehicle, as well as Navy recovery teams. Back on the USS Portland, Daryl Nail from the Kennedy Space Center with the Exploration Ground Systems folks is with Captain John Ryan, the commanding officer of the vessel. Daryl?
Thanks, Rob, and Captain John Ryan here. Thanks for making the time to come and join us from off the bridge.
Absolutely.
Appreciate you being here. So far, this has been pretty amazing in terms of the completion of the mission. From your vantage point, how did you see it, and what are you seeing now?
Right now we have the orbital is in the water. Right now we're kind of in that 2 to 3 hour window where NASA and the Navy's EOD teams are conducting some tests. We're getting imagery and data for NASA, which will help support the future astronaut missions. And from perspective, honestly, I think this is one of the coolest things I've ever gotten to do. I've been in the Navy 23 years. I've done a lot of missions and I've been all over the world, but to be part of this NASA mission today is probably one of the coolest things I've ever been part of.
That's impressive, and that says a lot. As we look just behind us, Captain Ryan, and we see the operation currently in a moment of pause where they're waiting for the capsule to vent off the rest of its ammonia using its cooling system. We can see the Navy boats in the water. Currently, you've got the ship on a course heading going around this operation. What has been your instruction to your team commanding the ship?
So I just basically wanted to keep the ship within visual distance of the orbital and our teams in case they need anything. It also is providing, let's be honest, a lot of people are out here and they're super excited about this. Let's provide visual opportunities for people to get photos and, you know, get their digital part of being the history of this event. So, you know, a lot of time and effort and training and years of work went into this. So I want everybody to kind of get their moment, and we're out here getting ready to, you know, we'll be landing the helicopter soon and, you know, just being a part of it.
Certainly watching the sailors as it splashed down, they seem to really enjoy the completion of the splashdown part of the mission. You can see they're all smiles, cameras, and so that was good. You provided us with a perfect view of the rest of the operation. I want to talk a little bit about your ship, the USS Portland, and why it was chosen for this particular mission, and what strengths does it bring to this operation?
So the USS Portland is one of the newest of the San Antonio class LPDs. So
an LPD?
Landing platform docking ship. So this type of ship, normally known as an amphibious ship, in most of our missions we'd be working with the Marine Corps to embark their equipment and deliver them to foreign shores. But the capabilities of our ship can also be used, obviously, for missions like this. We have an enormous flight deck with an aviation department that we can land multiple various types of aircraft. We can put, obviously, a number of small boats in the water. And then probably the special feature, which NASA really likes, is we have a well deck, which we can later flood, and we will bring the orbital into the well deck to transport it back to San Diego.
Those are some great assets that you bring to the operation, and I also know on the next one, in Artemis 2, it'll be a critical component. The medical facilities that you have on board here, you could take care of somebody with any number of injuries, and in fact, I believe even have surgery if you need it.
Yes, we have a tremendous medical capability on board. Hopefully not that it will be needed, but we do have a operating room, medical staff, and a lot of ability to take care of personnel should anything not work out as designed.
This ship was just recently in Los Angeles at Fleet Week earlier this year.
Yes.
Got to show it off to the public, and that's a matter of pride, I imagine, for the team.
Absolutely. The ship has had a very busy year. The ship returned from an overseas deployment much earlier in the year, supported Los Angeles Fleet Week and also the Rim at the Pacific exercise this summer, which had about 20 nations participating. So it's been a very busy year for the ship, and I think this is really just kind of the cherry on top where you get to do an unusual mission and support history.
Tell me about the footprint that NASA takes up on this boat. I'm sure I haven't seen all of it. I've seen a lot of it, the well deck, certainly the equipment that we have running on the various decks outside and inside. It's pretty sizable.
Yes, this is a very good sized ship. We have plenty of room. NASA has about 150 engineers and various entities on board, which we have plenty of room for. This ship would normally deploy with upwards of 600 Marines on board, so NASA's footprint really isn't too bad. It's well within our capabilities.
Well, there's been plenty of room, and you've been a tremendous host to us, and so thank you, Captain John Ryan, for having us and for successfully bringing us to this part and this moment of the operation.
It's been an honor to support the NASA engineers and to be out there and be part of this.
Thank you very much. Thank you. Captain John Ryan, the commanding officer of the USS Portland. And as we push out our view here in the Pacific Ocean, just 100 miles off the Baja Peninsula, you can see Orion now as a silhouette, still floating, the Orion Command Module with its CMIS bags. Those are the uprighting bags, fully deployed. It's in a stable condition. And to the right of that, you see the first Navy boat. That's a rigid hull boat. That one is the one that's going to get a little closer and provide a stabilizing tow line once it's been determined that the Navy boats can get a little closer. As we pan just to the right of that, you will see the remaining 4 boats. 2 of those boats are inflatable boats with Navy sailors aboard. Those Navy sailors will put hands on the capsule and secure it with ropes. They will then maneuver to bring that capsule to the rear of the USS Portland. The Portland will then throw out a more than 1,000-foot rope and then several 400-foot ropes. And that long rope will then attach to the capsule. It'll connect up and then begin pulling the Orion in. Now, this is a very complex operation. You think about this. That capsule does not have a keel, so it's a smooth bottom, 16.5 feet in diameter. So when it is pulled, it doesn't track in the water very well. So what has to happen is there are ropes attached to 4 points around the capsule that help stabilize it. Navy sailors, a team on each of the 4 ropes, and then on a 5th rope will be the winch. And that winch will apply enough pressure required, enough pulling force to bring that capsule into the well deck of the ship. At the moment, as we've been telling you, we are currently standing by awaiting ammonia boil-off. This is the coolant that's provided on the Orion capsule. It keeps the astronauts, should there, once they eventually go into the capsule and go on missions to the moon. Currently, no astronauts in this capsule, but we've got to vent off the ammonia nonetheless. The allotted time for that is 2 hours. And so we are just 1 hour and 10 minutes into that waiting period. And then once it's clear, you'll see those Navy boats get closer. But currently, we are still standing by, waiting for the completion of ammonia boil-off. That's it, live from the deck of the USS Portland. Of course, we'll have more interviews for you as we go along. But for now, send it back to Rob Navius in Houston.
Thank you, Daryl. Looks like a beautiful day out there west of Baja, California. A lot of smiles here in Mission Control in Houston. We're about 1 hour and 11 minutes since the splashdown of Orion to wrap up its 25.5-day mission. Integral into the flight of Orion was the performance of the European service module that functioned perfectly to take Orion out of Earth orbit on its way to the moon, and did everything it was asked to do throughout the course of the flight. And joining us is Philippe Delou, who's the Orion European Service Module Program Manager from the European Space Agency. Philippe, congratulations. Thank you for joining us today.
Thank you, and good afternoon.
Philippe, that service module went through its paces and was spot on every time it was asked to conduct a burn. Everything that it was planned to do was executed perfectly. Your thoughts on this mission?
Well, I have to say that I'm the happiest man in the world at the moment with the successful performance of the service module. She did what she was supposed to do, and even better. So it's a wonderful mission. I couldn't have dreamt more.
Now, the service module for the next flight, in which a crew will be on board, is at the Kennedy Space Center undergoing testing, and it's going to be a while for all of that hardware to come together, but you all are off and running on preparations for the next mission in a couple of years.
That's correct, yes. Well, we have already assembled the service module back in Europe and delivered it. Now it's being integrated with the crew module in Kennedy, and that's, if I don't mistake, should happen in the next summer.
Philippe, the work that the service module did, obviously invaluable. You can't conduct this mission without the work of the European service module. What kind of process was involved in getting to the point where the design of this mission, the requirements that the service module was asked to perform, and then ultimately conducted over the last 4 weeks. How did this evolution of this mission unfold for you and your team?
Well, this is a story that started quite a long time ago, in 2011, when there was a decision that the crew module would be built by Europe. So there's been a long process into setting up the requirements, proposing a design, discussing the design, also involving NASA, and agreeing on what should be the final design, take up the challenges which are associated with the design, eventually build the hardware, integrate it, and then preparing for the mission. So this has been a long way and a lot of work by the European Space Agency and the European industry.
And you know, down the hall where the International Space Station is controlled out of, ESA is a frequent flyer to the International Space Station, and the international partnership, of which ESA is such a critical contributor, is so valuable to human spaceflight now and in the years ahead. Talk a little bit about that.
That's clear. I mean, going to explore deep space is a challenge, is a big challenge. And we need all the excellence over the world in order to tackle that challenge and make it sustainable. Going there once, yes, is doable, but in order to go there on a regular basis and for a sustainable exploration of what is out there, first on the moon, then Mars, and then beyond, this will require all the forces and skills of the engineer around the world, and that's with ESA and NASA. We have started that process with the Artemis program.
Philippe Delou, a little moment perhaps to sample some bubbly to celebrate this moment, but a lot of hard work ahead, and thank you so much for being with us today.
You're welcome. It was my pleasure.
Philippe Delou, the European Service Module Program Manager, joining us here in Mission Control. Thank you, Philippe.
You're welcome.
This is Mission Control Houston, and all of the action now is focused on the USS Portland, west of Baja, California. My colleague Daryl Nail is there. Daryl?
Rob, thank you. Yep, we're here on the deck of the USS Portland, just 100 miles off the coast of Baja, Mexico, and I'm joined by Valerie Vinchulo. She is the General Dynamics Applied Physical Sciences Senior Engineer. Thanks for being here.
Yes, of course. Great.
So Valerie has some fresh information and analysis that she's been doing as it pertains to this operation, bringing the Orion command module into the well deck of the USS Portland. And so she has been looking at the wave heights with a system that you use, and tell me, you've just now analyzed the sea heights. What kind of sea heights are we dealing with, and what does that mean for the recovery of the Orion capsule out there in the ocean right now?
Yes, so we have two wave monitoring systems, two radars on board the ship. So we're monitoring the waves, measuring the Doppler velocity of the waves in the vicinity of the ship. So from that, we're able to get the significant wave height and where the direction of the waves are coming from along with the period. So right now we're seeing about 4 to 5 feet of waves at about 13 seconds from north-northwest. So with that information, we're able to provide a recovery heading for the ship that'll optimize, minimizing the motion in the well deck. So we're really trying to minimize that sloshing and bore wave in the well deck.
And that's a key point right there, Valerie. Of course, as I don't know if you could tell at home, but we're on the ship deck leaning back and forth to those 4 to 5 foot waves that we're dealing with out there in the ocean right now. So imagine Orion bobbing out there in the ocean, coming into a well deck where those waves come into the well deck. So what has been your recommendation to the team about how to deal with these waves as they bring that capsule close?
Right, so right now we're recommending a recovery course of 320 to kind of mitigate that motion. So we're kind of looking at the roll of the ship to minimize that sloshing wave, and the course of 320 is looking like the best for that recovery. That will give us a little bit of a bore wave that we're going to experience, but it's something that we think we can deal with, and we're looking forward to the recovery.
This is important because, of course, inside the well deck, I've heard it explained that once those waves come in, and then the ship, as it's moving about, creates a big wave pool inside.
Yes, yeah.
That's not good for a spacecraft that you're trying to stabilize.
No, you don't. You really want to minimize those missions to the best of our ability, and in doing so, we're just looking at everything out there, all the waves, what we're dealing with, and we have hydrodynamic ship models of the ship and of the well deck, so we're running through all of our models live, taking the live radar data, and just trying to provide the best information available here.
And so when they have that information, what is your role after you've given it? Do you continue to monitor? Are you active?
Yes, we're constantly monitoring and running the system. We're always recording data to analyze later, so constantly doing that. And we'll provide little tweaks and updates, as we get closer. But once they've started flooding, we're really on that course. So we'll just keep monitoring what's going on.
Those two radars on the ship, where are they located and what frequency are they using?
So they're located on the 05, and it's an X-band radar, and over here on the 04, so we have two, and that gives us, putting them both together, gives us a full 360 degrees, which is what you want. You want to be able to see all the waves around the ship, and they're actually an X-band radar that's been vertically polarized, so we can see the Doppler velocity as it's coming in to calculate that wave height and the swells and the wind waves in the direction they're coming in.
That's high-tech stuff. I mean, it's, you've got Doppler radar. Many people may be familiar with how that helps with weather, telling our audience and weather people where the weather is, where the storm clouds are, but it literally can map out in 3 dimensions the waves around the ship.
Yes, yeah, so we're looking, a lot of X-band radars, they're looking for targets, right? Another ship, avoidance, but we've polarized our radars to try to look at the waves, and just what other people might consider noise is what we want to capture. So.
That's interesting. It's just the opposite of what it's typically used for.
Yep.
Well, Valerie, last question I want to ask you. You've been on the ship since we departed San Diego on Wednesday.
Yes.
It's been a long journey to get to this point, this weather alternate spot where the seas are much lower. They're now 12 feet or so off of San Diego, so this is certainly something you probably appreciate.
Yes, yes.
But let me ask you about that operation and looking out there and seeing that space capsule in the water. What was like that for you watching?
Oh my gosh, it was amazing. It's something I will probably remember the rest of my life. Hearing that sonic boom and then seeing the chutes, oh my gosh, it was incredible.
Valerie Vinciullo, thank you so much for joining us.
Yeah, thank you for having me here.
All right, Rob, we'll send it back to you.
Thanks, Daryl. The work continues out in the Pacific, where you have the Orion spacecraft with all 5 of its uprighting system bags fully inflated, following its splashdown 1 hour 21 minutes ago at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, to wrap up a mission of 1.4 million miles that spanned 25 and a half days, a mission that saw the vehicle launch from the Kennedy Space Center atop the Space Launch System, the maiden flight of the world's most powerful rocket. An hour and a half after launch, Orion was sent out of Earth orbit in its translunar injection to begin a voyage out to what is called a distant retrograde orbit, a highly elliptical racetrack-shaped orbit that enabled Orion to be put through its paces for almost a month, gathering all the data that it needed and that the Orion program and mission managers had hoped for, and more. All of the engineering data that will set the tone and answer a lot of the questions that will pave the way for the Artemis 2 mission, in which a crew will be placed on board the vehicle in a couple of years for a orbital mission around the moon, again in a highly elliptical orbit, a mission that would be about 10 days in length or so. That crew yet to be named, but the pace will pick up after the first of the year in fairly dramatic fashion as the work continues to prepare the Space Launch System, the next Space Launch System rocket, and the Artemis 2 Orion vehicle to support a crew during its mission around the moon and back to Earth. In the meantime, a number of test objectives are still underway for the vehicle, most notably characterizing the thermal environment of the Orion spacecraft itself. Orion endured temperatures of up to 5,000 degrees Fahrenheit during its high-speed entry out of lunar orbit and back into the Earth's atmosphere, where it slammed into the atmosphere at 25 times the speed of sound, and then underwent a skip entry maneuver, basically skipping into the atmosphere, then dipping back out of the atmosphere again, and then back into the atmosphere to bleed off excess energy. An important maneuver that was designed and executed to perfection to bleed off excess inertia and to gain data on how we can better bring in multiple splashdown sites if required in the Pacific for future crewed missions. All of the chutes were deployed in good shape. The three main chutes deployed as planned. They reefed to their full extent, and Orion gently splashed down. After entering the Earth's atmosphere at 25 times the speed of sound, it splashed down at a meager velocity of just 19 miles an hour. Very gentle splashdown velocity had a crew been on board. And here's a replay of the final seconds for Orion as it descended below a deck of clouds at about 1,700 feet of scattered clouds. That was the final deck. The Spaceflight Meteorology Group had forecast very benign conditions for Orion. It did play out exactly that way as Orion touched down at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time. And there was splashdown. The chutes were cut automatically. The 5 crew module uprighting system inflatable bags inflated with helium gas as planned, and Orion is gently bobbing out with the Navy divers very, very close to the spacecraft. It's going to take several hours for them to hook up the equipment that they need to haul the vehicle into the well deck of the USS Portland and to bring it back to port. Back here in Mission Control, the entry team of flight controllers watching the data of the post-splashdown test objectives. in which data is being acquired on the thermal characteristics of Orion. There'll be a restart of the ammonia boiler system to gain data on long range and extra cooling for the vehicle that will be in the offing when a crew gets on board. We'll be talking more about the crew aspect of what lies ahead a couple of years from now, a short time from now. But now it is time to go back to what is a very busy place on the USS Portland, and my colleague Daryl Nail. Daryl?
Thanks, Rob. Yep, I'm here with Cody Kelly, who is the National Affairs Manager in the Search and Rescue Office at NASA. In terms of your job, we had good visual today of the capsule coming down. We clearly have the visual right now. We can see it in the water.
Yes, sir.
We know where it is. But that might not always be the case. The capsule may be beyond our visual sight, as well as in Artemis 2, the astronauts. Tell me about what your role is and how you help find out where they are in a situation like that.
Yes, sir. My name again, Mike Cody Kelly. I work in our SAR mission office. Basically, we work with all of our federal and international partners to ensure that our spacecraft are interoperable with the Search and Rescue Satellite-Aided Tracking System, or the SARSAT system. So today for Artemis 1, we tested out the vehicle tri-band beacon, which was using swept tones for the helicopters that are flying around behind us to be able to locate that spacecraft in kind of what we call the terminal area, which is within about a 1 nautical mile where you can get visuals, as well as the 406 megahertz beacons that were on the capsule, as well as what the astronauts are going to wear in Artemis 2. We were using what's called the SAR Intelligent Terminal, or the SAINT application, which is a system that ties into our ground station at the Goddard Space Flight Center to pull in all of the data from these beacons so that we can see them anywhere in the world. And that's incredibly important, especially when we have crewed missions where we, if we had some kind of emergency abort or some kind of landing, we'd have to be able to get data to our DoD partners extremely fast, even if they're landing internationally. And this is something that we do for all of our human spaceflight programs, but Artemis really has a kind of special place in my heart because all of this effort started way back in 2016 with URT-5. So we actually demonstrated some of our advanced technologies on URT-5 and slowly was able to be integrated with the landing and recovery team to provide them that key data on the day of landing and if there was any kind of emergency. The are going to wear what's called the Angel beacons, which are the advanced next generation emergency locator beacons that are located on their life preserver equipment, and that's going to be able to track an astronaut if they had to get out of the capsule, if there was an ammonia leak or some kind of emergency, as well as tying that into what the vehicle telemetry is saying to be able to give a good SAR picture to these guys that are flying helicopters looking for survivors or being able to go rescue astronauts.
And so let's talk a little bit about that further. The astronauts will be wearing GPS, essentially they're GPS locators, right?
Exactly, yes, sir.
They're beacons. And then, of course, the crew module itself has a tri-beacon.
Yes, sir.
So how do you delineate between those two?
And that's really the power of our ground station and all these web applications. They're two different legacy beacons. You have a first-generation SARSAT beacon, which is what you have on a standard boat. Even the ship itself has a first-generation beacon. And then we have what is called a second-generation beacon, which is an advanced waveform that's specifically for the astronauts themselves. In our application, we're able to actually identify each of those beacon IDs and tie them to a specific crew member so that when they turn it on, we know exactly whose beacon that is and exactly where it's at. And the power behind that is with these emerging technologies, we're able to do this even if we have bad GPS connection or we're really anywhere in the world. And this is the kind of stuff that you can have is if you go to a vendor and buy it for your boat. If you're out hiking, we're using those technologies for civilians for astronaut use and kind of vetting it out here out in the open ocean, knowing that astronauts are really one of our prime customers.
So you ran a test today, right?
Yes.
As this operation was unfolding, the crew module was sending out its beacon, its tri-beacon, but then you also had those Angel beacons for the astronauts. They were what? You put them on the boats,
yeah,
right?
we put them on the ribs or the rigid hulls inflatable boats that are out there tending the capsule, as well as on the fantail of the ship. What we're doing is we're looking to make sure the air crews could delineate between these various beacons if the crew members ever had to get out, as well as looking at the performance of the vehicle tri-band beacon after it's spent almost 2 weeks in space. So we're looking at not only today's technology but tomorrow's technology to kind of serve Artemis emerging partners and really the folks that are going to be in harm's way on a daily basis.
Your test was part of the operation today, and how did it perform?
It went phenomenally. I can't give more kudos to the crew of the Portland, First Air Force Det 3, setting that all up with the Navy, the Air Force, as well as some of our national partners in the U.S. StarSat program that made this all happen. So it was really a team effort, and it went flawlessly, just like this mission. So I couldn't be more happy.
And you could clearly identify the capsule and the two Angel beacons. I mean, it was clear as day.
It was clear as day, and we've been working on this application for over 2 years with this mission in mind, and it executed flawlessly. And the coders and developers at Goddard Space Flight Center did a phenomenal job being able to get this ready on time, on mission, and on location.
Cody Kelly, Manager of National Affairs, Search and Rescue Office at NASA. Thank you very much for joining us.
Thank you.
Rob, we'll send it back to you.
Thanks, Daryl. Great job out there, by the way, throughout the course of the day. A great view of Orion as it sits passively in the fairly calm waters of the Pacific, west of Baja, California. With me here, sitting very calmly, veteran astronaut Randy Bresnik. Randy, thanks for joining us today. You have been an integral part of the preparation of not only this mission, but all of the astronaut office activities associated with requirements that will ultimately lead to putting a crew on the next vehicle that will orbit the moon in 2 years. What did you see today that A, thrilled you, and B, was most important for you to see as a result of all the work that has gone in to make this mission possible?
That is a great question, Rob, and thanks for letting me come join you guys this morning. Certainly watching the team throughout the past 26 days was certainly the culmination of seeing that and walking in here and see this team be able to see the fruits of their labors. Seeing that we have a launch platform that was nearly flawless, practically flawless, getting our Orion uphill, and then having our service module, give us power and the flight control and the burns that all went off so well with so small residuals, we hardly had to do any trimming. And it was then great to see all the cameras that we put on that vehicle to bring everybody along on the mission, and put selfie as a word that we use now in spaceflight, and Artemis 1 getting the selfies while we were up there. And then certainly everyone holding their breath as we did the burns to get into the distant retrograde orbit, and then get out of the distant retrograde orbit, and then be able to make the trim burns to be able to get right, hit entry interface as accurately as we did here. See the service module separate, which is another big milestone, and then see the last few minutes of flight with Orion flying on its own for the very first time, and then see how well it controlled itself and how the forward big cover came off on time, the drogues came out, slowed it down, mains came out, and we landed 2.5 miles from the pinpoint bullseye, and we had expected maybe 5.5 miles. So it was awesome to see all of that, and that whole collection is what gives us confidence for the next time. All of these things that were individually areas of concern have now been proven in flight.
We've talked often during the course of the broadcast today about the fact that this is the 50th anniversary of Apollo 17's landing on the moon. Gene Cernan, Jack Schmitt, past his prologue, as they say. And now, from an astronaut office perspective, as you look down the road over the next 2 years, a lot of work to do, but certainly a leg up on what we think will be a launch in the 2024 timeframe.
Absolutely. The post-flight data reduction and everything else will be amazing to see in the next few weeks and months. But starting next week, we're right into Artemis 2 continuum processing. We got Artemis 2 crew module and service module sitting there at KSC right now, doing through its final, their final assembly. And then we have to do the verification, validation, test out, and make sure everything's working. And things like systems like the ECLIS system, which we didn't have on this. And so the first time that we're flying with that system will be when crew are on board. And so that'll be a really important, thorough checkout here on the deck. Certainly, in the next quarter, ideally assigning the crew to it so that we can start building their spacesuits, getting them involved in training, and getting them ready to go in that 2-year mark. And hopefully we will either meet or beat that 2-year mark. And so that'll be exciting to see if we can move that fast to continue the momentum that we got from this flight.
And an interesting flight design for Artemis 2, where another highly elliptical orbit around the moon. This is not like your father's Apollo 8, where we simply orbited almost at an equatorial nature, But we're going to be chasing the interim cryogenic propulsion stage as well.
Yeah, certainly. When you look at how bold Apollo was, we had never been to the moon. We didn't know we could do it. We planned on having Apollo 7, and we flew that crew module in low Earth orbit. And then Apollo 8, we launched it around the moon, and it stunned the world, and proved to ourselves, that we could do this. Well, guess what? We're doing that in one mission on Artemis 2. We're doing Apollo 7 and 8 combined. So that is a bold statement and audacious goal for NASA to set. And like you said, the highly elliptical orbit that we launch up in here on Earth, so we can launch out, get into a 24-hour orbit to check out that environmental and life control system, such that we know that we can breathe. We know that the cooling works. We know that all the systems work. Scrub the CO2, take out the humidity, to try the exercise device. So we know that by the time we end that period and we do the translunar injection burn, we know that we're good to go for the next 9 days to be able to get around the moon and come on back. All of that just buying down risk, proving out the systems, so that when we go to Artemis 3, we combine not only Apollo 9, which is the first flight of the LEM in low Earth orbit, Apollo 10, which took the LEM to lunar orbit and flew down near to the surface, then came back, and Apollo 11 landing. We do all those 3 of those missions in one. And that is very exciting, very bold, and it has got to be exciting to anybody that's in the space program, is interested in the space program, or the young people out there who are the first future space explorers who will be on those later Artemis missions.
Final question, Randy. Space is no stranger to you. You've spent quite a bit of time, shuttle flight, long-duration mission on the International Space Station. But if there was a singular image from the last 25 and a half days that sticks with you, that drove it home, that we were going well beyond the Earth, what would that be?
It would certainly be the missions where we were on the far part, where we were 268,000 miles away from Earth, and you saw Earthrise over the moon, and thinking that the next time we take those pictures, that could be with somebody behind the back of the camera, not the vehicle taking it himself.
It's going to be an interesting couple of years, a very exciting couple of years. And Randy Bresnik, thanks for joining us today. Appreciate it.
All right. Thank you. And congratulations to our Artemis team everywhere all over the world. They deserve a very well-deserved day off after this mission, but certainly looking forward to the next 2 years where we are able to take that and capitalize on it. And as we say, wash, rinse, repeat.
Copy that. Thank you, Randy. Appreciate it. Randy Bresnik with us here in Mission Control. It's been about an hour and 40 minutes since Orion splashed down. We're continuing out in the Pacific to secure the spacecraft and ultimately get it into the well deck of the USS Portland. As the team here in Mission Control works through the post-splashdown procedures before they hand the vehicle over to the Exploration Ground Systems Recovery Team on the USS Portland. Again, let's go back out west of here to west of Baja, California, where Daryl Nail is standing by on the deck of the USS Portland. Daryl?
And it's simply beautiful out here, Rob, and we've got a perfect view, a front row seat to the Orion splashdown. I want to give you a quick update on the recovery operations. Recovery Director Melissa Jones has decided to go the full 2-hour waiting period for ammonia boil-off, and so that's going to put us at 11:40 a.m. Pacific time for the boats to then close in and get next to the spacecraft and begin sniffing it for any hazardous gases. You can see it just right off the port side of the USS Portland, still in the water. The Navy boats off to the left, they're standing by for that moment, which is in just about 18 minutes from now. They're going to go in and start that procedure. Both helicopters, though, are back on the flight deck as well. Those assets have completed their part of the job. I want to bring in now Jeremy Vanderkam. This is a special individual. Well, of course, everybody's special, but when it comes to the heat shield, this is something you know well. You are the Deputy Thermal Protection System Manager for the Orion program. Your team designed the heat shield, tested it, and have been basically there from the start of this. And so I want to ask you, this of course has been the primary objective of this test flight.
That's right.
Testing the very component, the heat shield, that you and your team helped design. And so I want to ask you, first of all, how much do you just want to get out there and take a look at that heat shield, which is right behind you?
I can't wait. Yeah. I tried to convince lots of people to let me in the small boats. Didn't happen, but that's okay. We'll be doing our inspections once we get hard down in the well deck later this afternoon, and we'll get a good look at how we did.
Do you have any early information from the imagery that has been taken thus far?
Not a lot so far. We've been, looking at the capsule as it floats in the water through our binoculars and whatnot. Everything looks great, exactly as we expected it so far. But yeah, we'll get the details going here in a few hours.
So tell me about this particular heat shield. It is different and also similar in ways to previous heat shields. Tell me about it. How does it work?
Yeah, so this is the largest ablative heat shield that humans have ever devised for a spacecraft devised to take humans farther away from our home planet than ever. So what we did is we combined some older technology. We actually resurrected a material system from the Apollo program called AVCOAT, and we modified the way that it's applied to our vehicle for Orion in a more programmatically modern way, if you will. So the way that we do it now is
you got a piece of
I have a sample here, a test sample. So the brown material in the middle here is our AVCOAT material, and we make it in blocks, and we bond those blocks to the base of the Orion spacecraft onto the heat shield there.
It looks like wood.
Yeah, it does. It does look like wood. It's not. I can assure you. Yeah. And then there are seams between those blocks, which is the red element that you see here. And in this test sample, we've actually applied heat in our test facilities at Ames Research Center in Mountain View, California, to simulate the heat of reentry, to char the surface just as it is on the base of the spacecraft right now. And then what we'll do is when we get the spacecraft back in, we'll go and look at how that heat shield works compared to our test results. And that'll allow us to certify then the heat shield for Artemis 2.
You've done a lot of testing on this heat shield, but you were telling me that no matter how much you test it, you can't duplicate what it just went through.
That's correct. Yeah, what I'm holding here is about the largest size thing that we can test. And obviously the 5-meter Orion heat shield is much larger, so we have a lot of extrapolation for scale that we have to do. And similarly, our test facilities can't reach the combination of heat flux, pressure, shear stresses, etc., that an actual entering spacecraft does. So we're always having to wait for that flight test to get the final certification that our system is good to go.
So I'll trade you props here and let you hold the actual Orion. And tell me, you said you've used binoculars, you've sighted the spacecraft. One side of it, I guess, gets a little more charred than the other. What have you seen?
Yeah, so far it's actually looking like we expected. Sunward side is the hot side of the vehicle. And so we can see that, for example, the thermal control tape that we put on the exterior of the vehicle, all that shininess that we saw pre-launch is basically gone on the windward side, as expected. And then on the leeward side, where the windows are, I'm seeing a fair amount of tape remaining, as expected. So our heating predictions, how that the heat contours over the vehicle were predicted to be, looks like that's how they were. So, so far, so good.
Jeremy Vanderkam, thank you so much for joining us. He is the Deputy Thermal Protection System Manager for the Orion program, and I know you're anxious to get that capsule in this well deck so you can get your eyes on it.
Yep, I'm ready.
Good luck the rest of the way, Jeremy.
All right, thank you.
All right, we'll send it back to you, Rob.
Thank you, Daryl. Back here in Mission Control. We're about 32 minutes or so away from the point at which the entry team of flight controllers plan to hand the vehicle over to the Exploration Ground Systems recovery team that Daryl has been involved with on the USS Portland. That will come after the completion of detailed flight test objectives, the last of which will be the restart of an ammonia boiler system to provide additional cooling for the vehicle. This is a test to see what kind of additional cooling might be required once a crewed mission returns from the moon to maintain the most comfortable level of cooling for a crew on board that is returning from the moon for an extended period of time, particularly if they wind up splashing down a further distance away from the recovery ship than Orion did today. Everything went perfectly during Orion's high-speed entry back into the Earth's atmosphere, and it splashed down and all of the post-splashdown activities that have occurred so far, as we will be continuing our coverage until Judd Freeling, the entry flight director, hands back the vehicle to the Exploration Ground Systems folks out in the Pacific. And again, back here in Mission Control, you're looking at Flight Director Judd Freeling. In the middle of your screen, to his left, Flight Director Rick Henfling, as the entry team of flight controllers heading into the home stretch of their work here before they hand the vehicle back to the Exploration Ground Systems folks on the deck of the USS Portland, where, again, my colleague Daryl Nail is standing by with yet another guest.
Thank you, Rob. And as you can see behind us, still right here on the port side, we have Orion floating, stable, and the Navy boats there tending the ship. And we should be sending them in, and in just about 10 minutes from now, they will begin sniffing for any hazardous gases that will be coming off, and then they'll secure Orion. In the meantime, we have Dr. Emily Spreen, the Sasquatch team lead for NASA. And if you thought that your name was unique, well, it is. It surprised me when I was on the ship walking by your door and I saw Sasquatch team. I thought, what might that be? And then I found out, and it's fascinating. Emily, tell me, first of all, what is the Sasquatch team? What do you do?
So Sasquatch is in charge of generating waypoints for the ship and for the small boats, as well as creating footprints, which is where we get our name Sasquatch. So Sasquatch generates big footprints, and those footprints contain the debris field as it's coming down. And that's used to help position the helos in the air and keep people safe and outside of that debris field as we are, having a spacecraft splash down.
Absolutely, and it's really incredible. You were explaining to me, how you calculate these footprints, and just for background, as the Orion comes down and separates out the forward bay cover, which reveals the parachutes, and then there are certain items around that, a sabot, a lid, various pieces are coming out of it, and your team is able to model exactly or approximately where those pieces fall in the water so that assets can get close. How do you figure that out?
So a lot of the data came out of CPAS drop test. That's Capsule Parachute Assembly System drop test. Those are done out in Yuma. That was used to prove the Orion parachute system. From that, we were able to derive a lot of the aerodynamic properties of some of the debris objects, which I've got some here.
Sure do.
So these are drogue, lid, and sabot. They're not flight versions, but they are, representative size. These would be, on top and bottom of a parachute as it's mortar deployed like a cannon out from Orion. We've also got a smaller piece of debris here, and that's a pilot sabot. So essentially, at the drop tests, we were able to, really hammer down what those different aerodynamic properties are using rate of descent and then where those things touch down in Yuma. And we're able to use that in our model here for actual Artemis 1 operations.
And as I understand it, there are 26 pieces of debris, right, that came out from, the separation of the forward bay cover and the parachutes, and you model every single one of those 26 pieces?
Their model is a group, so, we've got a group of lids, that come off at drogue parachute deployment, right? So we've got, a couple lids that come off, a couple sabots. And so we say, the lids and sabots, they'll be in this footprint as that footprint descends and then goes into the ocean.
And as it lands into the ocean, I guess the shape that it kind of takes is that Sasquatch, a giant foot.
That's right, a footprint.
With all that debris coming down, I mean, the different aerodynamic properties, this is going to be different than, say, the larger one, which is going to be different from the parachute. What kind of modeling goes in to be able to tell where that parachute's going to float? Because a parachute takes many forms as it's falling.
Right. So we're taking in, we're using that CPAS data, but we're also taking in day of weather conditions. So we've got, weather people on board the USS Portland with us, and we're talking with spaceflight meteorology back in Mission Control in Houston, and we're getting information that we're using to take into account, because once things are on parachutes, just like you said, they're drifting. But with that, we were able to predict the CM splashdown location within a nautical mile. So
that's impressive.
Yeah, we're really, really pleased. It went beautifully.
Wow, nice job to your team and to you.
Thank you.
That right there is impressive. I was just going to ask you, how about the rest of the debris field? Were you able to determine with what level of accuracy the rest of it came down?
So right now, none of those other pieces have GPS information on them. We're hoping to get some information about that later. We'll see what the ship's capabilities are and what NASA's able to get from that. But that's something that's still in the works, so we'll see.
All right.
I'm pretty certain.
Emily Spreen, Sasquatch team lead for NASA. Thank you to you and your team for doing such a great job with us and joining us.
It's been an honor. It's been great. Thank you.
All right. Rob?
Thanks, Daryl. We're coming up on the 2-hour mark since Orion splashdown on target in the Pacific, west of Baja, California. The end to Orion's 25-and-a-half-day mission culminated a mission that was punctuated by a tremendous number of highlights, and we can take a look back at some of those highlights now. That began with the launch of the Space Launch System from Launch Pad 39B at the Kennedy Space Center at 1:47 a.m. Eastern Time on November 16th. The Space Launch System lifted off, conducted a roll program to place itself on the proper azimuth and the proper trajectory to enter a orbit of the Earth. It would spend the Orion spacecraft itself with its associated European service module and the attached interim cryogenic propulsion stage would spend one orbit in low Earth orbit. And there is the separation of the core stage. The vehicle conducted a translunar injection burn that enabled Orion to break out of low Earth orbit and begin its trajectory toward the moon, and the elliptical orbit, the highly elliptical orbit, called the distant retrograde orbit, that provided the time that was required for Orion to acquire data on the space environment and the time required for engineers to test all of its systems and collect as much data as possible in this first test flight that would precede placing a crew on board an Orion spacecraft 2 years from now. This dramatic video of the Earth-Moon transit that took place showed and punctuated the fact that we were pressing away from our home planet to a distance of some 268,000 miles away from Earth, further than any human-rated spacecraft had ever traveled, for a spacecraft designed to return humans to Earth, eclipsing the mark set by the Apollo 13 vehicle back in 1970. The distant retrograde departure burn that began the trip home for Orion this past Monday. You can see the effect of that engine firing on the solar arrays on Orion's service module. That, in effect, was what amounted to a deorbit burn of sorts that placed Orion on a trajectory to return to Earth, which it did today with a splashdown 1 hour and 58 minutes ago. As we circled back around the moon for the return powered flyby, we saw a dramatic close-up of the moon and the crescent of the Earth in the distance, using the moon's gravitational field as a slingshot effect to set our sights on the Earth and the trajectory required to splash down in the Pacific, which we did, as Orion gently waits for the arrival of the recovery team that will begin the process of hauling the spacecraft into the well deck of the USS Portland. And this was the view from the cabin camera looking upward out of the forward bay, basically the top of Orion, as the first chutes were deployed. These were the forward bay covered parachutes that in turn pulled out drogue chutes and then the 3 main parachutes to dramatically slow down Orion's descent back to Earth. And as you see here, under 3 fully reefed chutes, Orion finally splashed down at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, to wrap up its mission of 1.4 million miles. This is Mission Control Houston. Flight controllers here reporting back to Flight Director Judd Freeling that they have begun the power down of Orion's systems, with everything looking good and data having been acquired. So the post-splashdown test objectives are nearing an end. The vehicle is being powered down, and we should be a short time away from the point at which Flight Director Judd Freeling hands over the vehicle to the Exploration Ground Systems folks out in the Pacific. We'll be heading back shortly to the USS Portland, but as you can see, the first contingent of the Navy boats are approaching the Orion spacecraft, which is in great shape following its high-speed entry and splashdown that occurred just over 2 hours ago. We're just minutes away from handing over the vehicle to the Exploration Ground Systems folks. This is Mission Control Houston. Entry Flight Director Judd Freeling, who also was the Ascent Flight Director for Orion's launch aboard the Space Launch System 25.5 days ago, is addressing his team of flight controllers here in Mission Control. With that, Judd Freeling has handed over the Orion vehicle to a round of applause. The vehicle has now been handed over to the Exploration Ground Systems folks out in the Pacific, where my colleague Daryl Nail is standing by with members of the Navy helicopter team that saw Orion up close and personal about 2 hours ago. Daryl?
That's right, Robin. They were the first to see it. They picked up the heat signature as it came above the horizon, and they were the first to have a close-up look of the Orion crew module as it was in the water. I have with me, as you mentioned, 3 Navy pilots with the HSC-23 squadron in the Navy. They were flying the MH-60s, the Nighthawk helicopters. I've got Jacob Naylor, Jackson Cotney, and Gabe Weigelt. Thank you all for being here, and it's great to have you.
Thanks for having us.
Yeah, thank you. Well, tell me, first of all, this operation, for those who were watching earlier on, we saw your helicopters going around the area almost immediately after splashdown. Tell me about how you're able to do that and then what unfolded for your mission.
Yeah, so basically we have a FLIR camera mounted on the front of the helicopter and about 7 NASA personnel in the back. So while they're riding in the back, they're giving us azimuth and elevation angles to take a look at, and basically right away, even earlier than we expected, we picked up the capsule coming in. And so us 3 were the backup aircraft pilots, but we did hear it come over the radio that they had it captured right away. They have basically a FLIR that uses infrared, so it's seeing that how hot that capsule is coming down. They caught it a whole way down, which was exactly what we needed for that engineering data.
easy to lock in on, right? At 5,000 degrees Fahrenheit, the bottom of the heat shield, that FLIR was just almost instantaneous as soon as that thing came above the horizon. Then you began capturing imagery, and we watched as the helicopters circled, and sometimes they were doing some pretty nice banks around the Orion crew module. What was that about, Jackson? Why did they take that path around Orion?
Yeah, so the second part of the mission was to get a hazard analysis of the capsule, and then just engineering level fidelity data, like imagery from some of the photographers on board. And then we had another helicopter up that was testing out the new Angel beacon that the crews are going to wear eventually when the capsule does come down. So that all deals with our primary mission set of search and rescue, which is what we're hoping to do in Artemis 2, is to actually pull the astronauts from the capsule via the hoist.
Right. And so you guys were also using data from the Sasquatch team. We just interviewed them and heard about the great work that they did in predicting where that debris field would be coming down, 26 different pieces as the crew module was getting its parachutes out and everything. Using that data, how accurate was it for you, and how did it help you fly around the area?
So there was actually one of the NASA personnel in the back had a tablet which had the debris field on top of it, and as time goes on, that debris field could get a little smaller and smaller, and so they helped give us headings and guidances on where to turn and where to get the aircraft to avoid any of that debris field coming down and hitting us in the head on the helicopter. So
yeah, right, and successful. You guys were looked great out there at sea, surrounding the capsule, flying, in fact, at sometimes very closely. We saw you hover. I don't know what the feet was, but it looked pretty close to the ocean surface.
Probably about 50 feet above, just so that the photographers could get good data. And then we were kept safe by Emily and her team. The whole Sasquatch team helped us with the footprints so that we knew where we could fly, so that we'd be safe.
Where does this rank for you guys in terms of your mission? I mean, you're young fellas, so you don't have your call signs yet, which eventually you'll get that. But being a part of this mission, it's very different, right? The civilian nature, where most DoD missions are not of that nature. So where does it rank in terms for you? What kind of what was it like for you?
It's absolutely amazing, and certainly a career highlight for us up until this point. Yeah, we were still just in the backup aircraft, but just being able to just support these awesome pilots that were out there with us. We had Therapist and Ripper and Stapler and James. All of them did such a great job. So we're just really excited that this is both exciting for us and kind of plants that seed to be exciting for everyone else watching, and excited for the next mission with astronauts in it. So.
And that'll be the next great part, right? So as Navy pilots, you'll be able to hover over top of the next capsule that comes down, and it's going to have astronauts in it. Briefly describe what you imagine that would be like.
That's got to be an unreal experience. I hope I'm still around to be able to be a part of that, because that's got to be one of the greatest feelings ever, pulling someone out of a capsule that's just been to the moon and back. Unimaginable feeling, I got to say.
Absolutely. Well, thank you all. We appreciate you. Jacob Naylor, Jackson Cotney, and Gabe Weigelt with the HS-23 Squadron. Great job today. Thank you for joining us, and we appreciate you being here.
Thanks for having us.
Thank you so much. Appreciate you.
All right, and here on the USS Portland, the mission continues. The operation to recover the Orion command module, which you see is still out there in the Pacific. We're awaiting the Navy boats to get a little closer to begin their operations and sniffing out hazardous gases and making sure that they are able to connect up to that capsule and tow it back inside the USS Portland, our Navy ship on scene here. That's going to do it for us, for the Exploration Ground Systems, the Department of Defense, and NASA. We want to send it back to you, Rob, in Houston, Texas.
Thank you, Daryl, and magnificent job out there on the USS Portland, and the work is just beginning out there, as you heard. Here in Mission Control, the work is over for the entry team of flight controllers who have handed the vehicle over to the Exploration Ground Systems folks out in the Pacific, with the power down of Orion having been completed. Entry Flight Director Judd Freeling has released his team, and they will be making their way out of Mission Control, with Orion's handover now complete. Splashdown occurring at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time. The team is posing for a team picture before they are released for the day. Upcoming, you can follow, if you wish, all of the remaining recovery work, including the Orion being brought into the well deck of the USS Portland on the YouTube channel that you see there, www.youtube.com/KSC Newsroom. The Kennedy Space Center Exploration Ground Systems folks now in charge of the operations to bring Orion back into the well deck, to get it back on shore, and then transport it back to the Kennedy Space Center for post-flight analysis. That'll wrap up our coverage of Orion's return to Earth, and let's point you to our post-splashdown news conference that's coming up at 2:30 p.m. Central Time, 3:30 p.m. Eastern Time on NASA television, as a variety of folks discuss entry, splashdown, and recovery, and take a look back at the 25-and-a-half-day mission of Orion, its first flight, next stop, a crew on board 2 years from now. With that, we wish you a great Sunday. This is Mission Control Houston.
Feel the tension here at Cape Canaveral.
Sending astronauts to space is a lot more fun than not sending astronauts to space.
T-minus 1 minute and counting.
And NASA should know.
Ignition.
For decades, the country that landed 6 crews of astronauts on the surface of the moon was the undisputed leader among spacefaring nations. But since 2011, after the last of the great American space shuttles flew, the U.S. has been completely unable to launch its own astronauts aboard its own rockets from its own soil.
One final time.
Instead, we have become a grounded nation, a humbled nation, reduced to hitching rides aboard Russia's Soyuz rocket at $80 million a seat. That all changes now. When a SpaceX Falcon 9 rocket and Crew Dragon spacecraft leave the launch pad at Cape Canaveral carrying astronauts Bob Behnken and Doug Hurley on May 27th, an entirely new chapter in space travel will begin. The launch marks the beginning of the age of commercial crew flights, a great democratization of the space game, with private companies designing and building glittering 21st century rockets using 21st century technology and selling their services to NASA, leaving the space agency free to focus on its longer-term dreams of sending astronauts to the moon and Mars. SpaceX is not the only company that will be part of this grand new enterprise. In position to fly soon is Boeing's Starliner spacecraft, which will tag team with SpaceX in getting crews to and from the International Space Station. It is altogether fitting that the upcoming launch will take place from Cape Canaveral's Pad 39A, the same pad from which Apollo 11 launched, carrying the first crew of humans to the surface of the moon. Just as a new era began then, so too is one beginning now. America, once grounded, is flying again. This afternoon, as we broadcast live from Kennedy Space Center in Florida, I'm Jeffrey Kluger at the Time Magazine headquarters in New York. It has been 9 years since the final flight of the final space shuttle, which means it's been 9 years since the United States has had the capability to launch its own astronauts aboard its own rockets from its own soil. That's the longest America has been grounded since Alan Shepard became the first American in space 59 years ago this month. In that time, America launched 6 one-person Mercury missions, 10 two-person Gemini missions, 15 three-person Apollo missions, and 135 missions of the Space Shuttle. Every single one of those spacecraft had something in common that they do not have in common with today's flight. They were effectively designed by NASA and then built to order by a company it hired to do the job. The SpaceX Crew Dragon vehicle that will take astronauts Bob Behnken and Doug Hurley to space today will be the first privately designed and built rocket and spacecraft ever to fly human crew. History will be made by the mere fact that America is getting back into the space game, and more history will be made by the fact that that feat will be achieved in so different a way. We have what's known as an instantaneous launch window at Cape Canaveral today, and what that means is when this rocket takes off, this rocket can take off at 3:22 period. It can't take off at 3:22 and a half. It can't take off at 3:22 and a third. That's because it has to rendezvous with the International Space Station, which is currently in an orbit with a 51.6-degree inclination to the equator. That's a pretty high inclination. At 250 miles of altitude, the spacecraft will launch from an entirely different orientation. Basically, that means 19 hours of chasing the space station before the crew catches up with it. It'll take only 12 minutes to get to space. It'll take a full day almost before the crew actually docks. Bad weather scrubbed the launch last week or on Wednesday, and there is a lot that can go wrong when it comes to the weather. NASA has a whole series of rules dictating when spacecraft will be grounded. You don't launch within 10 nautical miles of an attached thunderstorm. You don't launch within 3 nautical miles of thunderstorm debris clouds. You don't launch within 5 miles of disturbed weather. You don't launch within 10 miles of cumulus clouds. There's rule after rule after rule intended to keep the crews safe. Now, this isn't to say that people haven't launched in dangerous conditions before. They have. The Apollo 12 crew, which launched in November of 1969, was actually struck by lightning barely a minute after it got off the pad, causing the entire electrical system to drop out. So that was a cautionary tale. The shuttle Challenger was, of course, America's great tragedy in 1986 when Challenger blew up on liftoff, and a great deal had to do with flying in cold weather when the O-rings that sealed the solid fuel in the solid fuel boosters on either side of the spacecraft became brittle and burned through, causing the explosion that claimed the crew's life. So weather is a critical issue in any launch, and it will be an issue in today's launch, as disappointing as it was on Wednesday when the spacecraft did not launch on time. We have to be prepared for possible disappointment again today. Safety is paramount in a launch like this, especially in a first test of a first spacecraft with a first new crew flying it. Benkin and Doug Hurley will be wearing an entirely new generation of spacesuits today. The suits that were designed were actually designed in part by a Hollywood costume designer, Jose Fernandez, who designed some of the costumes for Batman versus Superman and the Avengers. Fernandez has told the press that Elon Musk, the head of SpaceX, said, quote, "When people put this spacesuit on, I want them to look better than they did without it, like a tuxedo." It is a one-piece suit. It effectively is a spacecraft all by itself. A self-contained life support system for the astronauts. They can slip into it easily, and it plugs directly into the life support systems of the suit. We now have some interesting footage from SpaceX describing how the suits were designed by the people who designed them.
I think one of the things that was important in the development of the suit was to make it easy to use, something that the crew just has to literally plug in when they sit down, and then the suit kind of takes care of itself from there. So the suit is really kind of one part of the bigger Dragon system. It's really part of the vehicle. So we think of it as kind of a suit seat system. So the seat that the crew is in and the suit are in a lot of ways working together. And so it made sense that we were designing Dragon in-house to also design the suit.
Our spacesuits is completely designed in-house. It's built here in Hawthorne, California, in the same building as the rocket and the capsule. The spacesuit is custom made for each crew member, and that is to optimize the fit for the crew member.
We definitely wanted to innovate, and we wanted it to look inspiring, but first and foremost, we wanted it to be safe and reliable. The spacesuit's primary purpose is to protect the crew in the unlikely event that the cabin were to depressurize. But the suit does a number of additional things. It provides cooling and communication to the crew inside of the suit, provides them hearing protection, and the outer layer of the suit is flame resistant, so it provides flame protection as well. When the crew gets in the capsule, they get in their seats and they plug the suit into the umbilical that's attached to the seat. And the umbilical is providing everything that the suit needs. So it provides the avionics or electronics for communications, is providing the air to cool the suit, and then it also provides gas when needed to pressurize the suit. So it's really a single point that lets the suit do all the things that it needs to do. We designed the helmet in-house. The helmet serves a number of different functions. Obviously, it's protecting the crew's head and it's retaining gas like the rest of the suit, but it also houses the microphones as well as the valves that are regulating pressure in the suit. We had to design the gloves so that they would work with the touchscreens, but the gloves also still had to do a number of other things like the rest of the suit. So all of those things had to come together within the glove. It'll be obviously really amazing to see Bob and Doug in their flight suits, and I think one of the things that's cool about the suit is it's not just a piece of hardware, it's not just a suit, it's a very personal thing. It's Bob's suit and it's Doug's suit. And so seeing the two of them in their suits, using it in flight will be just a really amazing thing.
We're looking at a shot now inside the Launch Control Headquarters at Kennedy Space Center. There are actually three active mission controls operating today. There is the Launch Control Center here at KSC at the Kennedy Space Center. There is a Launch Control Center at the SpaceX headquarters in Hawthorne, California. And, of course, there is Mission Control in Houston, which will take over the flight the moment the engine bells clear the tower. As soon as the spacecraft is free of the gantry, it is basically Houston's bird to fly in cooperation with the crew in Hawthorne, California. What we're seeing now is the area around the crew walkout facility. Down that small gangway you see right in the back, this is the ramp and the doorway through which historic crews have passed before. The first, right here we have the first crew to go to the first moon landing, Buzz Aldrin, Neil Armstrong, and Michael Collins. This is the Apollo 11 crew. This is the first crew to fly the space shuttle, Bob Crippen and John Young in 1981. This, tragically, is the Challenger crew at their walkout on the way to their flight. This, similarly, is the Columbia crew, the crew that was lost in 2003 when their spacecraft broke up on reentry. There have been many more successful missions coming out of these doorways over the course of decades than there have been these periodic tragedies. And we see Bob Behnken and Doug Hurley. This is from last Wednesday during their walkout, wearing the new SpaceX spacesuits. They are climbing into a gull wing Tesla, and one of Elon Musk's companies, on their way to the launch pad. We are told that on that flight, on that drive to the pad last Wednesday, their audio track included AC/DC, the Blues Brothers, and the Star Spangled Banner to get them into a patriotic mood. The look at the pad right now is not enormously promising. The cloud cover obviously suggests that there could be some weather delays again today. Of course, a weather delay effectively means a scrub because, as we said, we have a 3:22 p.m. instantaneous launch window. It slams shut at 3:22, and at that point, the crew would have to wait again until tomorrow at 3 p.m. What we're seeing here is the swing arm attached to the Crew Dragon spacecraft. That swing arm runs from the gantry, that scaffolding that stands next to the rocket, and provides the crew access to the spacecraft itself. The large building we were just looking at was the vehicle assembly building, where the rocket is, as the name suggests, assembled and uprighted. Again, we are back on the pad here. The sight of the flag waving as briskly as it was in the breeze is not necessarily the best indicator of ideal weather, as is this cloud cover. But for now, all systems are still considered go, and the flight is still a go for 3:22 p.m. We are seeing now astronauts Bob Behnken and Doug Hurley walking through those same historic doors, getting ready to be transported to the pad. That's Bob Behnken on the right, Doug Hurley on the left. Doug is the overall spacecraft commander. Bob is the commander of the crew activities, particularly rendezvous and docking. You notice that in the space game, everybody gets the name commander in their title. Nobody wants to be seen as the subordinate. Back in the days of the Gemini program, they were called not pilot and co-pilot, but the command pilot and the pilot for the same reason. These are the astronauts, of course, saying goodbye to friends and family. You note that in this time of quarantine especially, there's no physical contact. This has been going on since long before the COVID era. There have been crew quarantines as far as long ago as the Gemini program. The crew climbing into this Tesla Gullwing will be attached to the seats through the same life support system that attaches them to the seats in the spacecraft. This allows oxygen and other life-sustaining systems to begin running through the suits. Think of each of these suits as a freestanding independent spacesuit. They are now getting primed for the suits to be able to sustain them once those helmets are closed. Basically, once those helmets are closed, the crew will have breathed fresh air for the last time until they return to Earth. It will be canned air on their way up, on their time aboard the station, and on their way down. They now begin a 9-mile ride out to the launch pad. One more goodbye to family and friends, and then off they go for that ride to the pad, which is close to the last time we will see them live until they return to Earth, anywhere from a month from now to 3 months from now. Typically the ride to the launch pad has taken place in a sort of RV, a recreational vehicle, a climate-controlled van in which the crew sat together. This caravan of Teslas is the kind of advertising money can't buy, but they are also sweet machines, and they are in keeping with the technology that's on display today, which is Elon Musk's two key companies. So it is only fitting that they will drive to a SpaceX space capsule spacecraft in a Tesla car. The one astronaut who has gone to the pad before in a Phil here. The distance, the mileage to the launch pad is a function of the fact that what the astronauts will be flying aboard today is essentially a 76,000 gallons of highly explosive fuel in a 229-foot rocket. That is a very dangerous machine, and all flights are observed. The viewing stands are about 3.5 miles from the launch pad itself. The somewhat circuitous route that the crew has to travel via NASA roadways to get them out to the pad is about 9 miles, which is why we see this long motorcade. During the days of the Apollo program, the Saturn V rocket, had it exploded on the launch pad, would have produced the greatest non-nuclear explosion ever engineered by human beings. So there was a 3-mile sort of no-go footprint stomped around the rocket. There was an absolute absence of any other human life aside from the astronauts themselves and the key pad crew technicians and the hundreds of thousands of people who watch those launches, watch from that 3-mile distance. Here we're seeing the motorcade approaching closer to the pad. Once it arrives, the crew will board the elevators that will take them up the gantry and to the spacecraft level at the top of the Falcon 9 rocket.
So that they can be on the, the pointy end of the rocket, getting a chance to go up to space. It's just a momentous moment.
And they're listening to some tunes too, I heard, right, Lauren?
Yeah. There are at least 3 songs on their playlist that are super interesting. The first is AC/DC's Back in Black. You know that one.
Yeah, well, who doesn't?
Right. Another one that they're listening to is the elevator music from the Blues Brothers film, The Girl from Ipanema. Oh, Leland.
Okay.
Got another career.
That's enough.
Career
That's
number
enough.
3.
That's enough.
Right. NFL, astronaut, musician. Yep.
And, of course, they are also listening to the Star Spangled Banner, the Army French Horns version.
Now, we didn't have tunes in the Astrovan.
No?
And I know that the Tesla has a really kicking stereo system. Is that still the custom stereo system that's in the Tesla?
I haven't been in this one, so I don't know what they're rocking, but I'm sure it's pretty cool.
And again, just for some perspective, they left the operations and checkout building just a minute ago, and so it's about a 9-mile drive from there to the launch pad. It takes them around 20 minutes, kind of depends on how quickly they're trucking.
The other thing sometimes that you hear as you're in the convoy is the helicopter, the Huey helicopter flying overhead. And it's kind of also, you're thinking military, you're thinking really important things, and it's a moment that also kind of solidifies in you that, hey, something big is about to happen. And that whoop, 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 the sound of that Huey is just in your head, and it feels good that all these people are helping you get there safely.
Yeah, I think we heard that actually coming by this building earlier because we were talking. I was like, I hope that's what I think it is.
And it was pretty low because it was pretty loud.
You could feel it, too.
I did. I could feel it.
I took this drive yesterday in my rental car, and granted, it wasn't in a Model X, and I'm not an astronaut, but driving to 39A, that same route, and trying to put myself, imagine myself in that headspace, it was pretty awesome. I got to figure out how to get on Falcon 9.
Lauren, we're all astronauts. We're in space.
That is true.
You just got to get on the rocket.
Yeah, well, Leland, there's a big group of people that want you there.
I think we should, listen to them.
Yeah, I'm all for it.
I think we should.
Maybe we should make that a poll question.
Yeah. Well, we should all maybe go to space. What do you think?
I am on board. I mean, not literally right now, but I would like to be on board.
Lauren, would you go with us?
Absolutely.
Okay, poll question.
We have so many people watching online, sending well wishes to Bob and Doug. I mean, it started early this week as we were ramping up for Wednesday, and I feel like it's just been this buildup of momentum because, you know, we were following along Wednesday, and now we're all following along Saturday, and we have people watching from home that hopefully don't have to work today and can really tune into what's going on here.
And we, you know, as astronauts, truly appreciate all the support, all the social media feeds, and we think about, you know, our families. You know, we saw Megan and Karen there with their sons, wishing Doug and Bob well wishes and God.
Did you guys call me? The convoy is now approaching launch pad 39A, the historic pad from which Apollo 11 launched, from which nearly all of the lunar flights launched, and which is now leased to SpaceX for the launch of the Falcon 9 rocket and ultimately the Falcon Heavy rocket. We see well-wishers on the side of the road. We see the waving. We see the farewells. This is the critical moment when the crew will begin to take leave of the Earth, take leave of these ground-based vehicles, and become a part of the machine that's going to take them to space. When they arrive, there will be a short walk from the cars to the elevators that will take them up to the top of the gantry level, through the swing arm and over to their spacecraft, which will be their home for the next 20-some hours. About 24 hours from right now, the crew will be rendezvousing with the International Space Station. As we said before, it'll take them only 12 minutes to get to space, but it will take them 19 minutes to catch up with the ISS, the International Space Station. And when they board, they will be aboard the station for anywhere from a month to 3 months. We hear these helicopters overhead now. You can see these, the NASA logo on the back of the Teslas is the 1970s worm logo, it was called, because of its squiggly sort of sine wave design. The worm logo has been taken out of mothballs and is being put back to use, along with the more traditional NASA blue round logo that is nicknamed the meatball. On what we're looking at right here, toward the left, what that structure that looks like a water tower is exactly that. It is a water tower that dispenses hundreds of thousands of gallons of water to cool the launch pad shortly after the engines light. The larger structure in the middle is the gantry that holds the elevator and other support structures. And at the top of the gantry, off to the right, you see that swing arm, which will be the gangway that the astronauts will walk across in order to board the rocket.
Blast danger area. Now, before any pad technicians, engineers, or astronauts enter that area around the launch pad, the SpaceX and NASA teams do an internal go, no-go poll to make sure everything is clear.
This storied launch pad, which has been the beginning point for so many firsts, is the perfect backdrop for today's historic launch that marks a new first and a new era in human spaceflight.
And here's a view from our gantry near the Launch Complex 39A. We've got another view of the convoy going by here. if I had to count up all the cameras we have all over the place for this, I'd be here all day.
That's a beautiful shot right there, looking at the Kennedy Space Center and Merritt Island and all of the nature around us. It's a big buffer from 39A so that we can be safe and launch our rockets off to space safely.
Absolutely, and a lot of people don't realize this is a national wildlife refuge. I mean, I pass turtles on the way to my car every day.
Well, when we would run from the operations and checkout building, we'd have to watch out for snakes and for alligators, and so to be really careful about the wildlife.
We used to have one who lived at 39A.
Oh, really?
Yeah, an alligator.
Well, maybe we'll see him. We'll keep an eye out. Tweet at us if you see any.
Did you name him Worm?
Ooh, ahead of my time.
I don't know how an alligator would feel about being called Worm, Leland.
Yeah, well.
And we've got a ton of you following along on social media. Lynn says, as a fellow Missourian, we're so proud of Bob. Launch America, we will be watching from the Space Coast, cheering loud. And another comment, Godspeed and good luck, Astro Benkin and Astro Doug, hashtag Launch America. There you see the SpaceX horizontal integration facility. It's on the left of the screen now. We saw the front of it from the other angle. Or I'm sorry, no, yes. There it is. I was getting my buildings mixed up, so it's on the right now. Yeah, bigger building.
The other is the Falcon Support Building. It's where all of our offices are, and yes, you're correct.
Thank you for the correction, Laura.
There's our hangar. We process Falcon Heavy in there. There are other boosters in that hangar as well. And the rocket and Dragon that is on the pad right now was put together, or rather finally integrated inside of that hangar and then rolled out to that pad to go up vertical.
And there it is. That shot really gives you a sense of the scale of the Falcon 9 rocket. Those Teslas look teeny, teeny, tiny, making their way up there. And so as they make their way up to the pad, we're going to throw it over now to Hawthorne, where Jesse and Dan are watching the action. Hi, guys.
Of the rocket. Another pretty key upgrade is the Dragon's new life support system. As you can imagine, flying humans requires keeping a habitable environment throughout the entire flight, and that means covering everything like providing breathing air, keeping the capsule at a safe pressure, keeping it free of contaminants, removing any carbon dioxide in the air, regulating the temperature, the humidity, all of these things, and also implementing that waste collection system, aka the toilet.
That sounds pretty important. The changes to Falcon 9 were small but extremely meaningful to meet NASA's requirements for safety for human spaceflight. And specifically, SpaceX had to prove a high degree of fault tolerance, meaning that small failures in the system would not lead to mission failure. Falcon 9 was already able to handle engine failure, but new emphasis was put on making sure that a failure throughout any phase of launch would not mean mission failure. And this goes all the way down to latches, control valves, electronics, wiring, and so much more.
All right, well, with the astronauts now on location at Pad 39A, we're going to swing it right back. Marie, Lauren, Leland, take us through the crew making their final steps towards the Dragon spacecraft.
Sure thing. So we are looking again at Launch Complex 39A. Just a few seconds ago, we saw the Tesla carrying Bob and Doug pull up to the launch pad. This is the site of so much history, you guys. This is where Apollo and Saturn V rockets that launched to the moon took astronauts from. I mean, this pad has so much history. Leland, you launched from there. What's it like seeing Crew Dragon and Falcon 9 there with the pad? With all of the visual changes that have been made? I mean, what kind of emotions does this stir up in you?
You know, when we got out of our Astro van, we stepped out and we just looked up to see this vehicle, and it was it was creaking, it was groaning, it was making noises, it was getting ready for us to enter it, to take us off planet. And you know, you get a chance to take a picture. Sometimes you stand there, you look there, you think about all the training you've done, all the preparation, and again, all the people that have helped you get there. And it's just a solemn, amazing moment for all of us.
And there's another amazing drone shot. Lauren, you explained this a little bit earlier about kind of how SpaceX brings the rocket and capsule vertical. Now that we see it, can you kind of explain that again for folks who maybe missed that?
Yes, of course. Dragon is actually processed a few miles down the road at Area 59, or Dragonland as we like to call it. We then put it on a truck and drive it all the way to the hangar where the rocket is. And so what will happen is we'll then we call it break over, where the vehicle's up vertical, we'll turn it sideways because the rocket is being processed sideways or horizontal into the hangar, lift it, mate it to Falcon 9, and then roll up those hangar doors and essentially pull the vehicle in the transporter erector, which is the big white truss structure that you see there. Mm-hmm. All the fluid lines, electrical lines, and everything are connected to the vehicles via the TE, transporter erector. And they basically roll it up those rails. You can't really see them. You kind of see them in the screen, those rails. Mm-hmm. Roll the entire TE rocket Dragon assembly up to the very top of the pad, pin it into the pad systems, and then roll it up vertical.
And we are about T-minus 2 hours, 57 minutes, 44 seconds and counting. In just a couple of minutes, we are expecting to hear a formal announcement that the crew is at the pad. Of course, we saw them pull up in the Teslas, and there they are. Looks like they've already gotten out of the car, and they are walking up to the elevator that will carry them all the way up to the 255-foot level, and then they'll have a couple of steps to get up to the level where the crew access arm is.
I have the AC/DC song in my head as I see them walking up.
You know what I was kind of jamming out to on my way in was ZZ Top, Sharp Dressed Man.
Oh, nice.
I was like, I don't know, that might be on my playlist if I was in there. There they are, taken in the sight, craning to see the top of the Falcon 9 rocket. It's 230 feet tall if you round up, and then Crew Dragon is another 27 feet from the bottom of the trunk to the top of the nose cone. So when you're out there in person, it's really hard to describe just how large it is.
Look at them getting excited. They're ready to get in the vehicle, get in the elevator, and make it to the top. There's some FOD he's picking up, foreign object debris.
Appreciate that. They're also wearing FOD covers on their shoes, by the way.
Oh, really?
Yeah. We want to make sure that they don't, track the inside of Dragon when they go in. And so right before they enter the vehicle, they'll remove the FOD covers off of their boots.
You take for granted, all just the little details like that, all of the thought and preparation that has to go into literally every single piece of this operation.
I love the makeover of Pad 39A with the sleek black with the white ticking and the lines, and it's a very futuristic look for this iconic launch pad. And to think what's been there before with Mercury, Gemini, Apollo shuttle, and now the SpaceX Crew Dragon getting ready for a launch to the International Space Station. Rocket fuel still going through my veins.
And we feel so honored to be able to launch from here. Oh, here they are. That's a really fast elevator.
Yeah.
I know, it really zips. That took them up to 255 feet in just a matter of seconds.
They were removing their FOD covers?
Looks like they were just maybe checking something on his boot or leg.
And we should hear a call any moment that the crew has arrived at the pad as they make their way up the stairs, and they're headed to the crew access arm now. There's the worm again, popping.
You know it.
Meatball.
Don't worry, there's a meatball on Crew Dragon.
Those white arrows you see there are essentially illuminating the way for anyone who's up there to find their way to the escape baskets in the event of an emergency that would require them to get far away from the rocket and the pad.
And it's hard to tell from this angle, but there's actually a phone right here, and I can't tell if it's Bob or Doug that's using the phone right now, but Leland, can you explain the significance of that? It's the same phone that was there during the shuttle days.
Yeah, you get a chance to talk to maybe friends or family that you haven't had maybe couldn't come to the launch. In this case, it's quite a few people, but just to have that last moment to talk to someone before you get in the vehicle. A beautiful view.
And we're watching the crew when they're done using the phone there. We expect them to be making their way into the crew access arm. And coming up at about T-minus 2 hours and 35 minutes, the astronauts will ingress, or that's a word we use to describe climbing into Crew Dragon. And we saw Doug do it a couple minutes early on Wednesday. They were a little bit ahead of schedule, so that time could be a little bit flexible. But that's going to happen with the assistance of the suit techs, and they will get strapped into their seats. And so with that coming up, we're going to head over to Hawthorne for a preview of what's in store for the future in space travel. Jesse?
We've been listening to NASA's feed of narrating what is going on the swing arm, on the pad at the moment. They will eventually be throwing out to Hawthorne, California, the headquarters of SpaceX, to show some of what's going on out there. At the moment, we see Bob Behnken removing the foreign object debris shoes from his boots that prevent them from tracking any foreign object, any dirt into this pristine new spacecraft. It's sort of like taking off your galoshes before you come into the house. The astronauts are about to cross that swing arm and then enter the spacecraft. You can see over that NASA Meatball logo on the wall what looks like a little bit of graffiti. That is where the astronauts signed their names, Bob Behnken and Doug Hurley, before boarding last Wednesday. This is the beginning of a new crew tradition in this new White Room. And this, by the end of SpaceX's at least 6 missions to the ISS, that wall is going to be pretty full of signatures. You saw something similar in the walkout scenes when they were leaving through the double doors during the walkout to the vans that take the astronauts to the launch pad. You could notice over the doors dozens and dozens of crew stickers, crew patches, each one indicating a crew, whether from the Mercury, Gemini, Apollo, or shuttle eras, that have walked through those doors and gone to the launch pads. This marks a new tradition, autographing the walls of the White Room before boarding the spacecraft. The spacecraft they're getting into now, the Dragon, it's a young machine. It's a machine that's carrying humans for the first time, but it has a pretty robust history. There have been 22 Dragon launches so far, with 21 visits to the International Space Station. The spacecraft is capable of seating up to 7 people, which was the capacity and the maximum capacity of the much larger shuttle. It stands almost 27 feet tall and 13 feet wide. That's about the same width as the Apollo crew vehicle, but it's 2.5 times the height and the habitable capacity that the Apollo had. It is maneuvered in space by 16 Draco thrusters. Those are the thrusters that allow it to change its orientation and attitude in space. On the way back down, it descends under the power of 2 drogue parachutes and 4 main parachutes, as you can see in the footage here. It is a pretty adaptable system. We see it right now configured for just 2 astronauts, but again, it can hold as many as 7. The Falcon 9 rocket, on top of which the Dragon will launch today, stands 229 feet tall. It's fueled by 9 Merlin engines. SpaceX has an interesting technique for building rockets. Basically, they go by the more is more philosophy. Their very first rocket, the Falcon, had a single Merlin engine. The Falcon 9, as the name suggests, has 9 engines. The Falcon Heavy, which is one of the heaviest lift rockets flying today, has 3 clusters of 9 or 27 Merlin engines. Each one of those engines is capable of producing 125,000 pounds of thrust. So for this rocket that'll be launching today, it will be exerting the equivalent of 1,125,000 pounds of thrust overall. It runs on RP-1 rocket fuel, which sounds very fancy, but is in fact simply a highly technical way of saying refined kerosene. And it also uses liquid oxygen as the oxidizer. This will be the 84th launch of a Falcon 9 rocket since the very first launch on June 4th, 2010. And one great innovation of the SpaceX design system is that first stage is not expendable. The first stage of the rocket can be reused when it is jettisoned from the rest of the spacecraft after its fuel has been spent. It doesn't simply tumble into the ocean. Instead, it lands on a barge in the ocean to be refurbished and used again. So far, there have been 44 successful landings of a Falcon first stage on an ocean barge, and 31 of those stages have been refurbished and reflown. This is one way of keeping costs down and keeping the production lines moving quickly. Today's launch is the result of more than 10 years of development of the Commercial Crew Program. The initial idea was to allow NASA simply to purchase services of private companies that would fly crew to and from the International Space Station, freeing the space agency up to focus on its longer-term ambitions to explore deeper space, going to the moon, going then later on to Mars. Here we're seeing when the first commercial crew announcements were made, the crews were introduced. There are two companies that will be flying crews to and from the International Space Station. SpaceX, and unmentioned so far today, but very much in the game, is Boeing, which will be flying its Starliner spacecraft. It has one more uncrewed test sometime in the next 2 or 3 months. And then it has another crewed test sometime early in 2021. The astronauts and SpaceX have been through a lot of stages to get to this point. They successfully flew a pad abort test, which is what we're seeing right here. A test of the launch escape system that pulls the capsule away from a booster that may be flying awry or may be about to explode. The Gemini, old Gemini spacecraft used ejection seats. The Apollo and Mercury spacecraft used something very much like this. What you're seeing here is what would happen if a rocket began to blow up and the SpaceX crew compartment or the Dragon crew compartment would simply separate and then descend into the Atlantic safely for a quick recovery. This was one of their bigger successes, this pad abort test. They similarly flew a launch abort test in which they actually deliberately destroyed a Falcon 9 on the way up in order to test whether the spacecraft could safely get away from a rocket that was in danger of exploding. The company did ace that test as well. The escape system was proven. It showed that the astronauts could indeed be pulled safely away from an exploding vehicle. We see that happening now. That small dot toward the center of your screen is the crew compartment escaping. Now, not all has gone well. This explosion right here was deliberate. That was supposed to simulate a rocket that had gone awry. Not all has gone well. There have been some stumbles. During one of the pad abort tests in 2019, the spacecraft itself exploded on the launch pad, which is a very bad sign. And there was no denying the fact that that was a setback. Here is another setback from 2016 when one of the rockets was being fueled on the launch pad and exploded. We just saw that's a crash of one of the first stages as it was trying to land on a barge, failing to land. There were no injuries in any of these cases, fortunately. And as recently as yesterday in Boca Chica, Texas, where the SpaceX Starship is being designed, the 120-foot tall stainless steel rocket that Elon Musk hopes to use to get to the moon and then later on to Mars, there was a static fire test on the launch pad just yesterday, and there was another explosion. It was a poorly timed accident one day before Elon Musk and SpaceX are set to send astronauts to space. It does not necessarily inspire confidence, but these are two very different spacecraft. Starship, which exploded yesterday, is very much an in-development prototype spacecraft that is nowhere near ready to carry humans. The Falcon 9 is a highly proven vehicle with its 88 launches and its overall highly successful safety rating. So what we're seeing today is the result of multiple successes and a handful of failures, and that basically is how rocket engineering is done.
SpaceX Dragon, loud and clear.
Core, loud and clear. Tejas comm check complete. Standby with comm checks with MD and LD in the launch configuration.
Dragon, MD on countdown 1. Comm check.
SpaceX Jason, loud and clear.
Copy, loud and clear. Glad to have you guys on board. Stand by for comm check on Dragon to ground. Dragon, MD, Dragon to ground, comm check.
MD Dragon, loud and clear.
MD, loud and clear. Stand by for comm checks with LD.
Dragon, launch director on countdown 1, comm check.
Good afternoon, Mike. Loud and clear.
I have you the same, and good afternoon. Stand by for my comm check on Dragon to ground. Dragon, SpaceX on Dragon to ground, comm check.
SpaceX Dragon, loud and clear.
I have you the same. Back to core.
Dragon SpaceX, this concludes our launch configuration comm checks. Report when ready for seat rotation per section 2 of 4.100.
Dragon will put that in work.
Copy.
All right, so all those communications checks were done successfully, and you could even see, and it's so cool when we get these views right inside the cabin.
SpaceX Dragon in 2.2, we are ready for seat rotation.
Copy. We will report when initiating.
But you could see Doug Hurley using his right hand. He has the talk button built into the seat itself. So just, again, showing you all of the different systems, how the suit is integrated into the seat, and it's all just one big circle for this whole spacecraft. So really cool to see those comm checks live. Jessica, thank you so much for walking us through some of the really cool updates, the upgrades. Did you have any other cool stuff besides?
Let's see. So I don't know if you guys can see, but we have the Dragon clean room here. And one of the coolest things is it is right on the main floor of our main building. So thousands of employees walk by here all the time and get to see Dragon in its final processing before it goes to the Cape. On Wednesday, the Crew 1 capsule was in here. It looked almost done. It looks a little empty right now, but that's because that capsule went off into our separate test facility for its final propulsion checks. So we do leak checks and things there, and we do that in a separate facility just because it's
We've been looking at Bob and Doug Hurley inside the spacecraft. Let's get to know these two gentlemen a little bit. Bob Benkin is listed as the Joint Operations Commander for the mission. What that means is he's in charge of the delicate choreography of rendezvousing and docking and other exercises as the spacecraft approaches the International Space Station tomorrow. That's a very delicate system. A small 26-foot spacecraft is approaching a great flying space liner the size of a football field, and mating those two vehicles is a complicated process. Bob was first selected to be an astronaut in 2000. He has flown 2 space shuttle missions, STS-123 in March of 2008 and STS-130 in February of 2010. He is a veteran of no fewer than half a dozen spacewalks, 3 on each mission. He was born in St. Anne, Missouri. He has a bachelor's degree in physics and a master's in engineering from no less a place than Caltech, and did serve for a time as a U.S. Air Force flight test engineer. Doug Hurley is the commander of the spacecraft. He, too, was selected as an astronaut in the incoming class of 2000. He was born in Endicott, New York. He has a bachelor's in civil engineering from Tulane and graduated as into the U.S. Naval Pilot Test School in Maryland. He was a fighter pilot and test pilot in the Marine Corps. He flew on, like Bob, he's been on 2 shuttle flights, STS-127 in 2009, and fittingly, STS-135 in July 11th, the very last shuttle flight after 30 years of shuttle missions. Both of these astronauts get a commander designation, commander for mission operations and commander for the spacecraft itself. It is one more sign of the fact that as collaborative and as collegial a business as flying in space is, these are competitive men and women, and nobody likes to be flying necessarily under the command of someone else. So they both get a little bit of taste of command. And we have some NASA deeper profiles that we can throw to showing you a little bit more about the astronauts talking about themselves and their own experiences.
Hi, I'm Bob Bankin. I am the Joint Operations Mission Commander for NASA's SpaceX Demo 2 mission. So Doug Hurley and I are about to take NASA's SpaceX Demo 2 mission to the International Space Station. During that mission, we'll perform some checkouts, everything from a response to a fire on board to flying close to the International Space Station manually. We'll make sure all those systems are working during the test flight so that the future missions will have them available even if they don't plan to utilize them. We're hopeful that future crews on Dragon vehicles headed to NASA space station aren't cursing our names because we accepted some feature that was complicated and hard to train and in the end hard to operate. In the Air Force environment, flight test environment, there's always a balance of managing risk as you go forward to execute a test point and figuring out a way to collect the data. And do that in the calm, cool, collected kind of test environment with experienced folks before a pilot ends up someplace a little bit more complicated with a lot less resources. My role for a space mission is very much the same. My career at NASA has kind of spanned a couple of decades at this point. I arrived with the class of 2000, went through the training program, primarily focused on the space shuttle and the International Space Station, learning those systems through the assembly process, which was a little bit like where we were with Dragon in the early days, because space station kept changing and you had to stay up with it. After that, I was eventually assigned to a series of kind of training activities, both as a long-duration crew member and then flip-flopped over and flew a couple of shuttle missions, both on Endeavour. After that, I came back and kind of worked up the leadership chain through station operations, deputy chief, and then chief of the astronaut office. One of my goals was to try to get as many astronauts off to Kazakhstan so they would appreciate the day when we got to launch again from the Florida coast. Probably two things that jump out to me as kind of big wins. One is associated with having a high enough fidelity from a training perspective. Both Doug and I can sit in a capsule, we can put on suits, and we can go through a situation or a scenario where the suits are going to inflate to try to protect us from whatever situation is developing on board the vehicle. And I think one of our biggest accomplishments was a tool to be able to plan our own way out of orbit back to Earth. And we had to come up with a way that didn't break the software allocation that was out there. And we just had the big picture of, okay, how does the crew just get home if they end up in this situation? How does the crew get home if they end up in this situation? When they were able to flip that switch and not count how many failures it took to get there, but accept that let's figure out the easiest way to provide that capability, and they got on board with it. That was the aha moment. You don't necessarily have to save the mission with the crew, but you need to save the crew with the crew is kind of the mindset that we've put out there. It's really kind of designed that launch day is kind of relaxed. So we'll get up, have a little bit of exercise probably, or breakfast and then some exercise, be able to do some last minute phone calls. We'll probably have lunch, review, weather briefing of some sort to understand what our weather's going to look like. We'll hear anything associated with the vehicle, kind of technical detail-wise. We'll get a little bit of an early read on that before the formal process of getting the suit on and then heading out to the launch pad. For me, having launched a couple times on vehicles, the second time was definitely different than the first time in terms of relaxation associated with the mission. You're doing that for the first time, you can feel a little bit guilty of, hey, should I study one more thing, or is there one more piece of information I should get? So that's definitely different between where I was on my first flight and where I'm at right now. On a deeply personal level, I'm really excited that my son is going to get a chance to see me launch into space. Being an astronaut has been a little bit of an abstraction thing for him because he's seen me do it in old videos, but he hasn't seen me do it for real. I think it's important for the U.S. to continue to have these exciting things out there from a technical, engineering, science, challenge perspective, because it motivated me to go into this sort of a career, and I know that it motivates other children in. And so I'm excited to bring it back to the Florida coast, or be a part of bringing it back. I'm just one piece of a multi-thousand member team that's going to hopefully pull this off in short order. It's inspiring to me, and I'm just excited to be a part of it.
What's going on in that white room? The portion of the swing arm that connects to the spacecraft that we can see, the sort of accordion-like black structure, that is the white room where the crew technicians, the pad technicians, are helping the astronauts into the spacecraft. What's going on behind that enclosure right now is the closeout. This is the point at which the spacecraft is sealed. While the astronauts have not yet physically left the planet, they have effectively atmospherically left the planet. They are now breathing life support air. They're being sustained by the systems aboard, the environmental control systems aboard the spacecraft. They are now, in some ways, in space. This is the way they will be living for the next 1 to 3 months aboard the International Space Station. They are now, in a sense, integrated with their spacecraft. They are part of the machine. The door is closed. There is no Florida air filling their spacecraft any longer. This is all the life support system of their suits, of their seats, which are integrated into the suits, and of the Dragon 9, or of the Crew Dragon spacecraft itself, keeping the crew alive. They are now very much in the process of leave-taking. having checked in on the doings on the capsule, let's meet our second astronaut aboard, Doug Hurley, the commander of the spacecraft itself.
Hi, my name is Doug Hurley, and I'm the spacecraft commander for the Demo 2 mission to the International Space Station. This mission is the crewed test flight for the SpaceX Crew Dragon. So every portion of the flight, this will be the first time the Crew Dragon has had a crew on board. And so there's a myriad of objectives we want to achieve. Obviously, the first part is to launch the rendezvous and docking phase. And then we'll spend some time on board space station and do some docked activities with the vehicle. And then at some point, 30 to 90 days later, we will undock and do an entry and a landing in the Atlantic off the coast of Florida. It's a story. On STS-127, which was my first flight, I think we scrubbed on the order of 6 times over the course of about a month. It was literally Groundhog Day trying to get into space. And of course, it's your first flight, so you really, really want to go. We just had technical challenges for the first 2 or 3 launch attempts, and then had to scrub for weather a number of times before we finally got to go. That's why you got to go to the pad, you got to get in the vehicle, because you never know when the weather's going to clear. It's not the best of stories, but I think back so fondly on that mission. We worked really hard for 16 days, but it was a great mission once we got airborne. We first got down to Kennedy, we got every checklist out and every responsibility that each one of us had. We kind of almost tabletopped it for the first couple days. And you see that in sports teams. You see the coaches and players that spend that extra time after practice and at night reviewing film and going over films of the other teams. I think that's what you need to do in a space flight, is you need to know what you're going to do almost instinctively, if not completely by heart, and then go from there. And I think it sets you up for success. With the shuttle, you were on your back for almost 4 hours waiting to launch. So part of it was just, let's get this over with and get going. But then when the engine's light, you know you are going, and you know you're going somewhere pretty fast. And you go from, in the case of the shuttle, you go from 3 Gs to 0 Gs instantaneously, and things start floating. And I remember distinctly just thinking, what just happened? Because 8.5 minutes ago I was on Earth and now I'm in space. And obviously with Falcon 9 and Dragon, this will be the first time humans have ridden on the Falcon 9, even though it's flown many, many times. You tend to pull more Gs. The first stage is pretty similar. Like shuttle, we had about a 2.5 minute first stage. The difference is going to be with Falcon 9, the engines, you separate from that part of the rocket with the engines the first stage, and so you get kind of a weightlessness there for, or a lack of acceleration there for a split second or two. So that part of it is going to be distinctly different. We could experience somewhere on the order of 4+ Gs, whereas shuttle, we were limited to just 3 Gs. I think our concentration has mostly been on, the profile, the crew vehicle interface, just how the Dragon will work for crews going forward. That's why we're going to do this flight now, is to prove out what we think it will do. Ideally, it will do exactly what we expect it to do. The first simulator where we integrated the Hawthorne mission control team and the Houston mission control team was a huge moment, to be able to just have the entire integrated team that's going to support us getting to and from space station, talking together, working through the challenges. I think that was probably for me the first big highlight, and that wasn't that long ago. It overwhelms you to think about how many people have in some way, shape, or form touched this program and this vehicle to get us to this point. We obviously in a lot of ways are the lucky ones that get to fly it, but we certainly not for 1 second take for granted the amount of effort that so many other people had to put into this to make it successful. And, you know, we'll do our part to make it successful and to get back here and celebrate with everybody in a few short months. Very excited. Yeah, very excited.
So today is as much about Bob and Doug and the future of the space program as it is a bit of an elegiac look back at the phase we just left behind. And that phase ended with the final flight of Atlantis. Let's take a look at Atlantis and how it got prepared for that final flight that ended the 135 flight space shuttle program. The spacecraft hatch has now been officially closed. We will get back to that Atlantis footage in a moment. You can see the White Room team sealing the hatch. It is a very painstaking process. This is the doorway that separates the astronauts from the void once they get to space, so you want no mistakes with this. Hatches have a long history in NASA. They have a very dark history with a hatch that would not open during the Apollo 1 fire. And so if there's any part of the spacecraft that has gotten special attention since that tragedy in 1967, it is the hatch, the doorway that separates the astronauts from their internal world to the external world. This crew, this White Room crew, will not leave this spacecraft until they are absolutely assured that the hatch is sealed and closed and that it is crew-worthy and flight-worthy. And it's starting to look as if they are satisfied with these preparations and will momentarily be backing away and allowing that swing arm to move back. And now let's take a look at that look at the final flight of the shuttle Atlantis and how it got ready for that closeout voyage. The final mission for America's space shuttle fleet began with the shuttle Atlantis in this processing hangar. The ship was there for weeks to check and recheck its millions of parts, making sure the very last shuttle was ready to haul 14 tons of food, equipment, and supplies to the International Space Station. Once Atlantis was announced fit to fly, the next step in this final trip was the procedure known as rollover. That began with Atlantis being towed from its processing hangar to the vehicle assembly building, following a path well worn by 134 other shuttle missions over 30 years of flying. 3 photographers documented this process with time-lapse pictures shot over the course of 4 days. In all, 15 cameras captured 120,000 images. Once inside the vehicle assembly building, the country's largest building by volume east of the Mississippi, Atlantis was lifted by a halter crane. It was then attached to its giant solid fuel boosters and to its 15-story liquid fuel tank. When that was completed, the shuttle emerged to begin its 6-hour slow crawl to the launch pad. Shuttle workers gathered by the hundreds to witness the space shuttle's final rollout, and with good and sentimental reason. 355 humans flew over the course of 135 shuttle missions from 1981 through 2011. The shuttle's secret was in some ways its very lack of glamour. It was a reusable workhorse ship that got humans and equipment to and from space, and in so doing helped ensure America's future off the planet. This launch of 2 astronauts aboard a SpaceX rocket, the first such launch from American soil since Atlantis's flight, is the next big step in that future. Once again, we are getting a look at the swing arm that will soon be pulling away from the spacecraft, leaving Bob and Doug there alone at the top of the rocket with their support team finally separated from them. You can see here that there's a bit of a rain squall. It's a little bit hard to make out the rainfall itself, but it's not at all hard to make out the gray skies, so there could be a few problems there. As you can see, we're back in the White Room now, and this hatch is getting still more attention, although it's looking like these touchpads are being used to check off those final milestones, and it looks like this crew is getting ready to leave the White Room at long last and let that swing arm come back. While we're waiting for the swing arm to come back, a big part of the future of the space program obviously does involve Elon Musk, and I had an opportunity to talk to him sometime last year. Let's see a little bit of that conversation we had at the SpaceX headquarters in Hawthorne, California.
I think Apollo 11 landing on the moon was probably the most inspiring thing in history. Arguably the most inspiring thing. Just the level of inspiration that provided to the people of Earth was incredible. And it certainly inspired me. I kept expecting that we would continue beyond Apollo 11, that we would have a base on the moon, that we would be sending people to Mars. But the United States has been without the ability to send people to low Earth orbit since 2011 when the shuttle retired. We need to advance space beyond what has been done before, and that we need to send people to Mars, expand our horizons, to do more.
In 2002, Elon Musk founded SpaceX.
We have liftoff.
Breaking the stranglehold that governments had as the exclusive providers for access to space.
Second stage ignition confirmed.
When Musk couldn't lease facilities to launch his rockets from the continental United States, he moved a team of engineers to a small atoll in the Marshall Islands. Despite early failures, SpaceX eventually found success. In 2010, it became the first non-governmental organization to launch, orbit, and successfully recover a spacecraft. And in 2011, it was awarded its first NASA contract as part of the Commercial Crew program.
I thought starting SpaceX would be 90% likely to fail. The cost of access to space was just too high. even if we doubled NASA's budget, unless NASA had good options for rocket contractors, they would still not make progress. So I actually just funded the whole company in the beginning myself, not because I thought it would turn out well, but because I thought it would fail.
Elon Musk's sheer brazenness, his willingness to break old molds and make bold promises, has captivated space fans, giving the company and its founders something of the popular following once enjoyed by Steve Jobs and Apple. And it's not just image. The company does things differently, relanding spent first stages on ocean barges, building its massive stainless steel Starship rocket, adding technological prowess to its popular sizzle.
The holy grail of access to space is a fully reusable orbital rocket. We cannot have a base on the moon. We cannot have a city on Mars. We cannot become a multi-planet species without full and rapid reusability. And we've made significant progress towards reusability with the reuse of the Falcon 9 boost stage. That's somewhere around 2/3 of the cost of launch, maybe 70%. And we've just recently been successful in catching the fairing, the nose cone of the rocket. And that is a crazy exercise with a boat that's basically a giant catcher's mitt. And the boat adjusts course automatically, and the two just, maneuver to touch each other.
While SpaceX is pushing the limits of rocket technology, it has also had some setbacks. A Crew Dragon spacecraft exploded during a test in 2019. The upcoming launch of a crew to the International Space Station is years behind schedule.
Any new development process, especially for something as complicated as a spaceship, that can safely fly crew, the focus for NASA is doing it safely, doing it right. You learn many times the most from the failures and the tests that don't go the way that you expect them to. So the incident with the Crew Dragon last year, testing the escape system on the ground, having an anomaly, and then going back and looking through the design, making sure that we fully understood everything that happened and really, upgraded the design to make sure that something like that could never happen again and be as safe as possible from beginning to end. And it really culminated in that successful in-flight abort test earlier this year.
And there you just saw the trunk jettison again, some really loud cheers.
But the Falcon 9 that will launch this week is now considered a reliable machine with a proven record. That does not say there's no risk. The rocket will use the so-called load and go approach before launch, with the fuel tanks being filled after the astronauts have boarded the spacecraft. This improves rocket performance given the dense, supercooled fuel that's used, but it's never been tried before with astronauts aboard, and there will be some tense moments leading up to the launch.
The NASA team really took, a strong look at all of the pros and cons of all the different ways to do that timing between crew, integration and ingress, and vehicle loading and launch. And they really came together and determined that this was the right, best approach to go do for this vehicle.
SpaceX represents a big part of NASA's future, but it also has a lyrical link to the past. One of the sweetest spots in all the world for people who love space is pad 39A.
It's the best pad.
Best pad. I mean, Apollo 11 left from there.
Yeah.
Virtually all of the lunar landing and orbital missions left from there. And now,
I can't believe we get to use this pad.
And that's my question.
An insane honor.
What does that feel like? That is SpaceX's leased pad now.
We're not worthy.
While this launch will be historic, Musk has his eyes on the future too, already building a new rocket dubbed Starship, capable of taking humans to the moon and even Mars. This flight marks an important first step toward those grander journeys to come. We're getting a live shot here of the scene at Cape Canaveral, and if you are not seeing the launch pad clearly, that's because the weather conditions have conspired once again against this launch. Now we are still 2 hours out from launch, close to 2 hours, a minute 58 and 14 seconds, and Florida weather can be fickle stuff. It could clear and cloud up and clear and cloud up again couple of times in the next 2 hours, but at the moment these are not conditions in which any prudent flight director would launch a spacecraft. What we're hearing from Times reporters on the ground is the word torrential to describe the downpour. So at the moment, so far there's no launch, there's no countdown hold. There can't be a countdown hold today because there is an instantaneous launch window at 3:22. So the clock will keep running, and the spacecraft, the rocket, either will or will not get off the ground at 3:22 p.m. At the moment, if this weather holds, it will not get off the pad. But once again, we rely on the very volatility and fickleness of Florida weather to perhaps clear up for us. In the meantime, that is the very short-term future of space exploration, what's going to happen in the next 2 hours. Let's take a look at something of the longer view, what the future of space exploration is going to look like after this flight does get off the ground at some point in the next, over the course of the next couple of years and decades. Even as NASA and the rest of the world await this week's launch of 2 astronauts to the International Space Station aboard a SpaceX Falcon 9 rocket, the space agency itself has its eyes trained deeper into space, much deeper. The entire purpose of the Commercial Crew program was not just to open up space travel to the private sector, it was also to allow the agency to devote its human exploration energy to returning astronauts to the surface of the moon, and later, to Mars.
We're going to Mars, and in order to go to Mars, we have to use the moon as a proving ground. We need to get to Mars. That's our driving ambition as an agency and as humanity. As far as exploration, this has been on the minds of many people for generations and generations.
The new lunar program, named Artemis, after the sister of Apollo, aims to have the first woman and the next man on the surface of the moon no later than 2024. The plan is an ambitious one, but with a lot of work and a few breaks, the goal can be met. Long in development and now nearing completion is the rocket that will be used for the missions. NASA's prosaically named Space Launch System, or SLS, the 21st century's answer to the 20th century's Saturn V. Initial versions of the SLS will stand taller than a 32-story building. Later iterations will top out at 38 stories. Either one will be more than capable of setting crews off on a deep space journey.
The SLS rocket, the biggest rocket that's ever been built in history, taller than the Statue of Liberty. It's on the 5-yard line, and we're going to punch it into the end zone. If we're going to land in 2024, which we're going to do, the key is going to be SLS.
Also nearly ready for flight is the Orion crew vehicle, an exceedingly souped-up version of the old Apollo spacecraft, able to carry as many as 6 crew members compared to Apollo's 3. The first flight could take place as soon as 2021.
Welcome inside the Orion trainer. Right now, I'd say crew members are over here 2 or 3 days out of the week doing different tests.
One of the neatest things about the Orion spacecraft in general is that this is designed to take us to Mars. And so this spacecraft is designed to be operated autonomously by the crew. So when we are on our way out to Mars, there's going to be minutes of comm delay back to Houston. And we have to make all the decisions in here. It's really amazing. It's an impressive vehicle.
In order to land on the moon, NASA needs a new lunar lander, and on April 30th, the space agency selected 3 companies, SpaceX, Blue Origin, and Dynetics, to begin the work of developing one. The early blueprints from all of the companies are promising, and the competition will be bracing, with only one company emerging as the final builder. NASA's goal for this generation of lunar landings is not to repeat the short visits of the Apollo missions, the so-called flags and footprints model, but rather to go to the moon to stay.
I don't want to give any specific dates. I don't want to make any announcements, but if we're going to land in 2024, we've got to select quickly. The goal is to lead a coalition of nations to have a sustainable presence at the moon with more access to more parts of the moon than ever before. We learned that there's hundreds of millions of tons of water ice at the south pole of the moon. What does that mean? Water ice represents air to breathe, it represents water to drink, it represents rocket fuel. We are going to Mars. The moon is a waypoint. It's the place where we learn how to live and work. We learn how to make it sustainable.
Only by learning how to live off the land in a long-term encampment just a 3-day flight from home can America be sure it's ready to take the next great step, to send astronauts to Mars. After half a century of staying close to home in low Earth orbit, human beings will once again look deeper into space and will follow to the places that cosmic gaze leads them. Well, as you can see from this shot, the weather has only deteriorated further. There is no word yet from NASA on whether this flight would scrub early if the weather conditions seemed absolutely hopeless, or whether they will continue counting down straight to that 3:22 p.m. mark. One of the determining factors will be the load and go fuel. They have not yet begun fueling this rocket. That's a complicated process. It's entirely possible that if the weather continues to deteriorate, they'll decide it's not worth even going through that, and the launch would get scrubbed early and the crew would emerge early. But the betting here and the betting in Canaveral at the moment is no matter what, we will go right up to that 3:22 p.m. mark, and the spacecraft either will or will not lift off. Whatever happens today on the launch pad, what happened before the crew got to the launch pad is part of a long history of spaceflight traditions. Astronauts are not necessarily superstitious by nature, but they are creatures of habit. The first big moment in any astronaut's day has always been the pre-flight breakfast, typically steak and eggs. That was Neil Armstrong, Buzz Aldrin, and Michael Collins having their pre-flight breakfast pre-Apollo 11. What we saw a moment ago was the traditional tree planting at the Baikonur Cosmodrome in Kazakhstan, where each new astronaut who goes aloft will plant a tree. The plush toy we saw floating in the spacecraft a moment earlier is another tradition. Astronauts will often bring along a toy of some kind, not simply as a comfort object, but so they have something that will float when they reach 0G. Remember, they're strapped into their seats. They can't float out. So when you see the plush toy beginning to fly, you know that you are in orbit. Here we see Bob and Doug continuing with their other tradition, the new tradition of signing the walls of the White Room before they take off. And one of the oldest traditions, and perhaps one of the least dignified of the traditions, is one begun by Yuri Gagarin, the first human being in space. On his way to the launch pad, he realized that he must have consumed a little bit too much coffee on his way to the pad, so he stepped out of the van and opened his spacesuit and relieved himself against the tire of the van, taking him to the launch pad. Ever since then, astronauts and cosmonauts leaving from the Baikonur Cosmodrome will stop on their way to the pad and have a similar self-relieving ceremony. It's not the most dignified, but it is one of the most enduring of spaceflight traditions. I am being told that we have one small error to correct here. Bob and Doug signing the wall of the White Room is not a new tradition. This, in fact, has been going on for decades of flights, including the Space Shuttle and other crews before them. This is simply the continuation of a long-standing tradition, this time, though, in a brand-new White Room with a brand-new spacecraft. Pad 39A, the launch pad from which the astronauts will leave for space today, if the weather permits, is one of the most historic spots in the history of the space program. Elon Musk, as you saw earlier, sees it almost as hallowed ground, as do a lot of people. It is the launch pad from which virtually all of the Apollo lunar missions flew, as well as all 135 of the shuttle missions. Let's take a look at the history of Pad 39A and how it came to be.
We're go, same time, we're go. Altitude, velocity, light.
Why, some say the moon. Why choose this as our goal? And they may well ask, why climb the highest mountain?
Contact light. Okay, engine stop. We copy, get down, Eagle.
Start. T-minus 10, 9, 8, 7, 6, 5. All three engines up and burning. 2, 1, 0, and liftoff. The final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
Roger roll, Atlantis.
Let's take a look back at some of the history that came before today. The great Apollo program, of course, was the one that took human beings to the moon. There were 11 Apollo launches from Apollo 7 to Apollo 17, and 9 of them went to the lunar surface, or went to at least around the moon and then on to the lunar surface. Some of the great men and women of space history worked in that room. Gene Kranz, Glyn Lunny, Chris Kraft, all of the giants of the space program. The rockets that launched from Pad 39A during the Apollo program were the largest rockets ever built. If you had been able to harness the power of that rocket taking off, it would have been the equivalent of running every river in America through a single hydroelectric turbine at the same moment. That was the kind of energy that was used to get these rockets off the ground and into deep space. The technology used was, of course, primitive by today's standards. This was slide rule technology, this was pencil technology, this was mental math technology, and yet it got these spacecraft to the lunar surface. The touchdown on the moon that was achieved here on Apollo 11 on July 20th, 1969, was the culmination of a promise President Kennedy made 8 years earlier, when he simply declared that we choose to go to the moon. We don't have to go to the moon. We choose to do this because we are a spacefaring people. We are a questing people. We are people who look at what's on one mountain and decide we have to get to the other mountain. We are people who look at one coast of an ocean and decide we have to get to the other side of that ocean in order to explore. It all began with these 7 men, the original Mercury astronauts. 6 of the 7 flew. 1 didn't because of an early heart murmur. What they went through to be qualified was not easy stuff. From the Mercury program, the one-man spacecraft, the very first launch was right here. You see it on a Redstone rocket. It was a little popgun suborbital flight. It's a tiny rocket. This spacecraft carrying Alan Shepard did not go into orbit. It went into what was called a suborbital flight. He had about 5 minutes above the atmosphere, about 5 minutes of weightlessness, but that was enough for America to have said it had put men in space, or it had put a man in space. There was a second suborbital flown by Gus Grissom shortly after Al Shepard's flight. The crowds that gathered to watch these launches were a sign of what this meant to the United States. This wasn't just a technological achievement. This was a geopolitical achievement. This was the United States in a bipolar world with the post-war capitalist American system on one end and the communist system on the other, and it was very much seen as a war of two ideologies. This, what we're looking at here, was views of John Glenn, the first American to orbit the Earth on February 20th, 1962. The one-man Mercury program led to the two-man Gemini program. This was the program that allowed astronauts to test the technologies they would need to get to the moon: rendezvous, docking, spacewalks, long-duration space flights. The Gemini 7 crew, Jim Lovell and Frank Borman, spent 2 weeks sealed in a Gemini spacecraft. Right here, what we're looking at is the rendezvous between the Gemini 6 and Gemini 7 spacecraft, the very first time two spacecraft met in orbit. That was considered an almost impossible feat to achieve. Spacewalking in its early iterations was not a safe thing to do. If we are looking at Gene Cernan here, and it's hard to tell, this was could be the Gemini 9 spacewalk, in which Gene Cernan labeled the spacewalk from hell. He overheated. He could not see in his spacesuit. His helmet visor clouded up. But it was one way of learning what spacewalking involved, and that it wasn't simply the happy drift that people thought it was. Going forward, of course, beginning in 1981, was the shuttle program. This was the point at which the U.S. decided that we were going to make a long-term commitment to low Earth orbit, which sounded less swashbuckling than the space shuttle or than the Apollo programs, but this was our chance to live in space. This was the space shuttle was equal parts elegant and wonderfully simple. It was a space truck. It ran, as it said, shuttle runs to and from Earth orbit to bring crews up, to bring hardware up. It launched some of the greatest spacecraft in history. The Galileo probe that orbited Jupiter left from the body of a space shuttle. The Hubble Space Telescope left from the body of a space shuttle. 135 such missions made spaceflight routine. Since the grounding of the space shuttle, we have been a nation that has flown to space with the aid of the Russians aboard the Russian Soyuz spacecraft. The Soyuz has been flying since 1966. It's sort of the Volkswagen Beetle of the space program. It's tough, it's reliable, it's all but indestructible. It is a speedy cosmic sports car, and it's a heck of a machine going up and a heck of a ride coming down. Scott Kelly, who spent a year in space, said that landing in a Soyuz spacecraft is a little bit like going over Niagara Falls in a barrel that's on fire. And yet, here we see Christina Koch coming back from space after having spent nearly a year in space. What we are looking at here appears to be an early iteration of the constellation, the Ares 5. This is a simulation of the what was going to be America's return to the moon program. It was begun in 2004 by the George W. Bush administration, and the goal was to have human boots back on the moon as early as 2015. It was going to consist of 2 boosters, one that was a relatively small booster, the Ares 1, to take astronauts to space, and another, the Ares 5, which would take cargo, rather. This was a launch of the Ares 1, the very first iteration of the very first of the constellation programs. And here again are simulations of what the lunar vehicle would have been. The Constellation program fell victim, unfortunately, to what often happens in Washington, which is that as administrations change, so too do goals. The Constellation program had gotten rather far along when the Bush administration transitioned to the Obama administration, and the Obama administration then decided to focus less on a return to the moon and more to the commercial crew program, with the commercial sector, the Boeing Starliner and the SpaceX Dragon, taking over the work of getting astronauts to and from low Earth orbit, so that the space agency, the space program, so that NASA could focus on deep space exploration. And this is where we stand now, with the commercial crew program taking care of low Earth orbit, and NASA looking forward to returning to the moon with both the Artemis program and the new lunar lander being developed for the Artemis program. 3 companies have now been chosen to build that lunar lander. Blue Origin, which is the company owned by Amazon founder Jeff Bezos, SpaceX, and Dianetics, and all 3 of them are working on building a lunar lander. Meantime, what we're looking at here is the new Shepard rocket that Blue Origin hopes to use to send paying customers into suborbital space, very much like Alan Shepard's very first flight into space. Here we're seeing the Virgin Galactic spacecraft. Similarly, Sir Richard Branson's Virgin Galactic company hopes to launch paying customers on suborbital flights that will give them about 5 minutes of weightlessness above the atmosphere. Ultimately, Elon Musk, in what the images we're seeing here, hopes to launch his 150-foot tall stainless steel Starship rocket on the surface of the moon. This looks improbable, but NASA believes enough in this that this is one of SpaceX is one of the companies that's gotten a contract to help develop a lunar lander. This is Musk's next great enterprise, and Starship is where he hopes to make his mark, landing both on the surface of the moon and ultimately on Mars. We're back now to a live picture of the pad, and it looks like things may have cleared up a little bit. We will see what NASA has to tell us about where the weather stands, but the sky looks a bit bluer, the rain looks a bit subdued, and there is still a chance that we could be getting off the ground today at 3:22 p.m. We are, like the rest of the world, watching this this impending liftoff today, waiting for what NASA reports will be a weather update. Weather will be the final determinant. As we can see from this angle, it does appear that the skies are clearing. Now, those are some pretty formidable clouds through which the spacecraft would have to launch, but those are some pretty promising blue patches among the clouds. And the better news is the sky appears, the air appears generally clearer, generally less cloudy, less foggy, and generally less rainy. So we are standing by for a weather update from NASA, which we are told will be coming momentarily. So we are here with Terry Virts, the veteran of 2 space flights, 2 weeks aboard one space shuttle mission helping to build the International Space Station, and then 200 days aboard the space station involving 3 spacewalks, 1 stint as commander of the station, a trip you made by Soyuz, the Russian Soyuz rocket. So you're a veteran of 2 very different kind of spacecraft. The space shuttle, which is just a big bruiser of a machine, and sort of a sports car like the Soyuz. What do you think it would be like to fly the Crew Dragon?
Well, I think it's going to be a lot more like the Soyuz. It's roughly the same size. I noticed when I flew on the space shuttle, it was like a muscle car. It was rumbling and lots of noise, and it kind of slowly takes its time getting into space. It's similar to a Saturn V in terms of weight and thrust, whereas the Soyuz was bam, and you're just up and gone. Of course, it was a nuclear ICBM, a Soviet ICBM. So they didn't want those things to sit around and look pretty. They wanted them to get going quickly.
Right.
So the Falcon is going to be a lot more like the Soyuz.
All credit to them if this launch goes off as we hope it will. But they are several years behind schedule, and the U.S. has been 9 years now without the ability to get astronauts to space on our own spacecraft. We're used to thinking of going to low Earth orbit as fairly routine. Why has it taken so long? Why is it so hard to get spacecraft into orbit?
Well, the easy answer is space is hard and it takes time, and you have to, work on all the technical things. But the reality is, between John Glenn's or Alan Shepard's first flight and Neil and Buzz on the moon, that was 8.5 years. And people, there were no cell phones to help do email, and we didn't have any history. So we were quicker in the 60s than we are today. And this is SpaceX, which is probably one of the fastest rocket companies ever. I mean, they get stuff done quickly.
Right.
Part of the problem happened where Congress just underfunded the program,
Right.
Which takes some of the air out of this is a privately funded thing, because it was really a government funded project. And when the government didn't fund it by the full amount, that really slowed it down. Part of it is, there are problems that happened, and there's been several, serious technical problems along the way. But when I was in space, the SpaceX cargo capsule showed up a couple of times and brought my underwear and food and supplies. And that program happened really, really quickly. It was basically, I think, 2008 when the cargo contract was really going. And by 2012, they were delivering stuff to the space station. So SpaceX has shown it can get stuff done much more quickly than the old government model. But it's still not a perfect system. And it's still taking us longer in the 2010s than it did in the 1960s.
There's another competitor in this race, of course, Boeing, and Boeing's spacecraft is its CST-100 Starliner, which also will be carrying astronauts to and from the International Space Station. Now, they had a bit of a setback on their last uncrewed mission. They weren't quite able to reach the International Space Station. What do you think about Boeing's chances for getting their own crews up there, and how quickly do you think they'll be able to be flying?
Well, I think Boeing is going to do this also. It's going to take them, they're many months away. This is not going to happen next month for Boeing. It's going to take some time before they do it. They had software problems. And when I was a test pilot, I mostly worked on software programs, and I would always tease the engineers, it's only software, guys. Come on, you should be able to get this done. And the reality is software is often the hardest, longest, most complicated, part of any aerospace program. But I'll ask you this question, Jeff. Do you want to check your MySpace account later on today? The reality is, MySpace was the first to market,
right.
But now everybody does Facebook, right? So just the fact that you're the first to market is sometimes good and sometimes it's irrelevant. So Boeing is definitely a player in this market, if you will. Mm-hmm. The ISS program is a pretty small market. It's only 1 or 2 launches a year for each company. It's really not a big program. So the real marketplace is going to be if we ever get to a place where there's private space stations like the Bigelow space station, or if we ever start legitimately manufacturing in space, then companies like SpaceX and Boeing and maybe others eventually, Sierra Nevada or who knows, then they'll be launching 4, 5, 10 capsules a year, and not just one a year, and then it becomes interesting. So the government is kind of seeding that market, but hopefully it will eventually grow into something bigger.
And if it grows into something bigger, if we do have private space stations in orbit being serviced by private spacecraft, will they be vacation? Will they be academic? Will they be industrial? Will they be all of the above?
I think the space station has a corner on the academic market. It's a government subsidized thing. That's the place for universities or companies to do research. The space station is the place for science projects, but it's not a place for manufacturing. So if we ever figure out how to do 3D printing of human organs or make microelectronics and mass scale that you can make them better in weightlessness than you can on Earth, if any of those technologies actually hit, then that's going to have to go to the Bigelow or another private space. So that's one of the markets, is manufacturing. And I think the tourism is also a very interesting idea. There's several, space tourist companies, if you will. Virgin and Blue Origin are probably going to fly tourists first, maybe this year, maybe next year, but those are just suborbital. They go up and come down 5 minutes later.
That's right.
To have orbital space tourism would be amazing, but that's going to require a place like the ISS that's not exactly set up for tourists. It's a government thing. So I think that would be a really interesting marketplace. Of course, it's going to be probably more expensive than a retired astronaut or a journalist would be able to afford.
Yeah, I have a feeling I'll just be looking at someone else's vacation photos.
They're family movies.
Exactly. Elon Musk is a character. I think even Musk himself would admit that he's a bit of a character. And there's been some friction between him and NASA Administrator Jim Bridenstine in the last year or so. Are you troubled by that, or do you just see it as sort of the rough and tumble of the space business?
I'm not troubled. I thought you were going to say there's been some friction between him and everyone.
A little of that.
This is the world that we live in. I'm a lot more troubled or excited by a rocket that works or doesn't work than I am about some tweets going off. Elon has admitted that he's the kind of the king of self-inflicted wounds. If I was a shareholder, I might want my CEO to be more focused on shareholder value and not on Twitter. But that's between him and his shareholders. So the things that concern me as an astronaut, if I were flying, and I'm not, I'm retired, I don't work at NASA, I'm done. Is the rocket going to work? Is the escape engine going to work? Will the parachutes work? Will the rendezvous system work? Is the software are the computers going to work? All that's the stuff that really would concern me. And that's where I think having some transparency and making sure that you're just being open and honest with the public is more important. Some of this other stuff is just showmanship, I think.
Right. Now, before we went live here, you and I were talking a little bit about the difference between flying, say, a Soyuz and flying the new SpaceX Crew Dragon. And certainly no slur on Bob Behnken or Doug Hurley, the astronauts who will be aboard the Crew Dragon. But you said that there is a bit less flying going on with this spacecraft than there is when you're at the stick of a Soyuz or a space shuttle. Tell me a bit about that. How come?
Right. So actually, the details of it are proprietary, and I've never worked at SpaceX, or that wasn't my job back when I was at NASA. So I don't know all the details, but from what I understand, there's basically no flying involved. Everything is automated from the launch to on-orbit maneuvering. The docking is automated. During entry, there's nothing for the crew to do. The capsule does everything. There's not, from what I understand, there's not even like a control stick that you normally have to fly an airplane or a spaceship. They are going to do some manual maneuvering during docking just to prove that the system works, because this is a test flight. So, but it's like it's a touchpad. So they're going to have a screen, and they'll be, roll left, and then the shuttle will roll left, and then pitch up, and the capsule will pitch up. Flying on the space shuttle, was designed in the 70s. Right. It was the best flying machine of all time. It was, and you could fly it, during launch. I did fly it in orbit. I flew, rendezvous, and I flew around the space station with the control stick, and back in the atmosphere, I flew it with the control stick, and like an airplane. So the shuttle, from a test pilot's point of view, there will never be anything as cool as the space shuttle, because you could really fly the thing. But this is a new era. It's the 2020s. And, we're going to have self-driving cars. I think by the end of the century, our grandkids are going to think back and, hey, Grandpa, what was it like to have a car that you had to drive, this is just the way of things. The goal of this is not to fly it. The goal of this is to take people from Earth to the space station and back. It's just a logistical cog in the space station program. As you mentioned, we've been doing this since John Glenn and Yuri Gagarin in the early 60s. And this is just a more modern version of that. And this is not the goal. Like I said, we got to get people into space. The goal is what they do after they get to space. That's the interesting part of it. So this is kind of it's the rental car at the airport. It's not your vacation destination.
We're talking about 2024 to have boots on the moon, the first woman and the next man. In candor, are you sanguine about that? Do you think we can make that date?
Well, the commercial crew program, if you will, was really born in 2009 when the Obama administration took over, and Charlie and Laurie Garver kind of ran the space agency. They announced Constellation was canceled the week I launched in space in 2010. And here it is, 2020. So that's a decade. And we still haven't sent people just to Earth orbit in a capsule. And we're going to be on the moon in 4 years. So I just, as a realistic person, that doesn't seem realistic at all. However, in the 60s, we did do that, right? We were able to make it happen. But it's not, it's not the 1960s NASA today. So that's going to be something that's going to be very difficult. I think we also need to say, why are we doing that? And I think if it's part of a strategic plan to use the moon as a testing ground to get to Mars, if it were part of a truly strategic plan, then you do the things you need to do to, fulfill that strategic plan, rather than just say, here's a random thing and we have to do it. The other thing is the debt that we're racking up right now, Jeff, is staggering, and it's just changed the course of the next decade or two, what's happening in 2020. So we're going to have to be very strategic about money that we spend. So I think there's just a new reality that we're in.
And that brings us to the always somewhat touchy area of politics. For our viewers, you mentioned Constellation, which was, of course, the lunar exploration program that was established under the George W. Bush administration, and there was a fair amount of progress, a good amount of progress that was made on that. And then it was canceled under the Obama administration, and the Obama administration had a number of its own policies, including the asteroid redirect mission, moving an asteroid closer to Earth, and then studying it. Now, under the Trump administration, we are back on a lunar course. Do you worry that whatever happens in November, the Trump administration will either end then or it will end in 4 years? That's not much time either way. Do you worry that we will once again shift course and start all over and have a new program that will have to be begun from scratch?
One of the things, while I was an astronaut, you fly and then you go visit Congress and the White House. I've been there several times, and now that I'm retired from being an astronaut, I've spoken at the National Space Council with the Vice President. And I talk to folks often, and the one message I always have for them is, it's not about the rocket science, it's about the political science. And unless the way to run a space program is not change what the last guy did because you don't like him. And that's what we've been doing now for more than a decade. So the political system's broken in so many ways. NASA is just 1% of a really messed up political system, right? So I think the hope for me is that private companies can put together a plan. I think if we can figure out how to do private-public partnerships, right? And I know Mr. Breinstein's been really focused on that, and that I know this is a priority for him. But let Blue Origin, just let them go. Let SpaceX go. Let Sierra Nevada go. Let these other companies, and Boeing and Lockheed, they can do things privately, and when they are allowed to do that, they can be more efficient too. So I think if we can figure out how to let these companies do things, and let the government do things like make treaties, bring in Russia, bring in Europe, bring in other countries to work. Eventually we're going to need nuclear power. Government's going to have to do that. You know, SpaceX is not going to make a nuclear reactor. So
Yeah.
I think if we figure out how to do that right, that can help us moderate, attenuate some of this political ups and downs that we have. Because otherwise, it's never going to happen. And the SLS, you know, that rocket really was born in 2005 when George W. gave his vision for space exploration.
Right.
It was going to use cheaper engines. It was going to be, they weren't going to have a capsule on it. It was going to just be the cargo ship. It was part of an integrated plan.
Yeah.
And then that got canceled and changed. And that was 15 years ago. And it's still years and years away from launching people. So.
Yeah, I remember at the time in 2005 when it was announced, the target date was footprints on the moon, maybe as early as 2015. Well, that's 5 years ago. We're still not back in low Earth orbit.
I think Air and Space Magazine did an article. I was one of the next astronauts on the moon. I was one of the guys they featured, along with some of the, I think Megan Bankin and Karen Nyberg, actually.
Yeah.
Bob Doug's wives, I think they were in there too.
Would you suit back up to go to the moon?
You know what? To go to the moon, yes, of course. I had this do I stay or leave calculus that I went through at NASA, and I had kind of done everything there was to do. I was a station commander and shuttle pilot and blah, blah, blah. So there was other things I want to do in life. But I always said if I could go make a film in space, that's something I would like to do.
Yeah, yeah. Well, now there's talk of that happening. There's talk of Tom Cruise shooting aboard the International Space Station. So. So maybe you can co-star with Tom Cruise. Well, is there anything else that I have neglected to ask you that you think our viewers would want to know about what the stakes are this week and what it feels like to be Bob Behnken and Doug Hurley climbing into this machine?
I can say that when I flew on both of my flights, it was really exciting. The very first time I suited up for my first flight, it ended up being canceled for weather, and we launched again the next day. And that first time it was like I was out of my element. I was nervous. I was in this big suit. Even though I practiced it, it really was kind of, okay, this is something different. But the second night I went out, I felt a lot more comfortable, and it was almost like I'd already done it, even though I hadn't. So the nerves were better that second time. Bob and Doug aren't going to have that because they've both flown, you know, they've flown several shuttle missions. It's been a decade since they've flown.
Yeah.
But I don't think that's going to be a problem. Also, on my first flight, my first 2 days were miserable. I had the worst headache of my life. I was taking ibuprofen, and it was on my third morning. I remember Steve Robinson said, "Hey, how are you feeling?" And I was like, "God, I feel like crap." And then literally a few minutes later, it was like a light switch, and all of a sudden I was fine. Yeah. And then I was fine the rest of the time. On my second flight, even though it was 4 or 5 years later, I felt fine. Like your body just needs a couple days to figure out what the heck just happened.
Right.
Your inner ear fluids and everything.
Yeah.
For some reason, your brain figures it out. And at least for my case, and I've heard others say the same thing, you know, I felt okay. And so my guess is that they're going to feel okay because this isn't their first space flight.
Right. You told me something once, speaking about spacewalking, about what it's like to step out into that void, and every one of your rational brain cells tells you that you cannot fall. You are in orbit. Physics is keeping you up there.
Right.
But look down, and there's nothing below you but a planet 250 miles below you. Describe that experience a little bit.
So on my first spacewalk, when I went outside, it was nighttime on Earth, but the station was up in the sunlight.
Right.
So that actually helped because when it's daytime on Earth, you see the Earth going by, and several of my colleagues had said, "Man, I got vertigo when I went outside." I didn't think I would, but I wasn't sure because it was my first time. So I went outside. The very first thing I did, there's a waist tether on the side. I pulled it off. I clipped it on a handrail, and I let go. So I was in outer space, floating above Earth, and I just looked down, I looked around, I went, okay, I'm fine. I just wanted to make my brain behave and make sure it was okay.
Yeah.
Personally, I don't like ledges. I hate standing on the edge of a building or something like that. I hate it. And so whenever I'm on a bridge or on a building, I always walk right over to the edge.
Yeah.
Just to force myself to do it because I don't like it. It's almost like I'm just having to beat my brain into submission, and but I still feel I'm like, ugh.
Yeah.
If I'm in a fighter jet flying upside down, I'm fine because I'm strapped in and it's okay. If I'm standing on a ledge, so that was it. That was my way to try and get my brain, like as you so well described it. Every rational brain cell knows you're okay, but it's the emotional brain cells that don't necessarily know that.
You've got a book coming out soon. Tell me a little bit about that.
I do. Well, we both do. But my next book is going to be called How to Astronaut. It's a collection of 51 short essays. The goal is to laugh and to say, wow. Those are the two things that I hope to get by it. I wrote it myself, no ghostwriters. And it's some basic stuff like, how do you learn how to be a doctor? How do you learn how to launch in a space shuttle? It's some crazy stuff like, what do you do if the engines don't light and you're stuck in orbit? Or what do you do with a dead body if your crewmate dies? Or, are there aliens? And so it's some stuff that is expected, some stuff that's not expected. You can pick it up and read it. Any chapter, it doesn't have to go in order. It's just a collection of essays. And I think it's going to be pretty fun. It's a good beach read when you go to the beach this summer. Coming out September 15th. So they've started doing pre-sales now.
Terrific. Congratulations on that. And thank you very much for spending time with us, Terry Virts, veteran of 2 space flights and former commander of the ISS. Not bad.
Thanks, Jeff. Looking forward to this launch.
Thank you. So am I.
And welcome back. For those of you who are just joining us, we are now T-minus 1 hour, 1 minute, and 40 seconds from launch. We are awaiting a weather update from NASA. At the moment, the skies look clear. It appears that the torrential downpours of earlier in the day have ended. The winds do not seem too challenging. So the hope is that we will see that swing arm, the access arm that connects the spacecraft to the gantry, move back soon. There will be at 2:25 in about 5 minutes an Air Force One flyover carrying the President and the First Lady, who will be here to watch the launch and later to make some comments in the vehicle assembly building. The Vice President, who was here yesterday, will not be here, or who was here on Wednesday rather, during the first attempted launch, will not be here today. President Trump will not be the first president to watch a launch live, though he will be one of the first. The only other two were President Nixon, who in November of 1969 watched the Apollo 12 crew launch for the second lunar landing, and much later in October of 1998, President Clinton watched John Glenn on his great return to flight. Here in this shot, we see former President Lyndon Johnson and then Vice President Spiro Agnew at the launch of Apollo 11, but President Nixon, who had been in office for just 6 months at that point, did not attend. He did, as you can see, attend the return of the crew. He was on board the USS Hornet when they were recovered. This, you can see here, President Clinton and First Lady Hillary Clinton watching the launch of Senator Glenn. And here is President Michelle Obama visiting the space station or the Space Center earlier in the decade. Once again, here is rollout footage. And for those folks who are joining us on YouTube, here we have the presidential flyover, Air Force One bringing the President and the First Lady to the launch facility where they will watch the takeoff that we hope will be coming now in 58 minutes and 52 seconds. For those of you who are joining us on YouTube, there is a comment section in YouTube. We would love to answer any questions, respond to any comments you have. One question that came in from a viewer earlier was how long it will take the astronauts to get to space. And the remarkable thing is this is just a 12-minute ride from the surface of the Earth in a 1G gravity sphere, gravity well, to low Earth orbit in 0G. The astronauts, Bob Behnken and Doug Hurley, will make that transition in just 12 minutes. Now, it will take them 19 more hours inside their spacecraft to catch up with the International Space Station, but only 12 minutes to go from Earth to orbit. It is a hot, fast sprint. Once those engines light, these guys are truly hauling the mail. The astronaut's day is a complicated one. We're looking at some scenes here from Wednesday when the launch was scrubbed. This is Bob Behnken, and that's Doug Hurley, and Bob Behnken being suited up in the same suit-up room that was used in the Apollo program, and some of that equipment, some of that off-green equipment on the back wall is the original hardware that was used back then. It's still being used now. It's relatively simple stuff. You can see those old analog meters. Once the crew is suited up, they are made ready to get to the launch pad. They are carrying, as you can see, the umbilicals here. They have air conditioning systems. Since these spacesuits are essentially self-contained spacecraft, they need their own kind of coolant system. We see here the two astronauts speaking to both Elon Musk and on the right, and Jim Bridenstine, the administrator of NASA, on the left. These are the two men who are most responsible for what will happen today. The walkout happened on Wednesday very nominally. This is how it's supposed to look. A lot of waves and blown kisses to friends and family. The backup crew is there with them as well. Typically, backup crews are there until the very last moment, always ready to be available in the event an astronaut would not fly. Here they were climbing into the Gull Wing Tesla, getting ready to go out to the launch pad, saying goodbye to their wives and children. Again, you notice they are standing behind a yellow line, and it's only pantomime hugging going on here. This was the case even before the COVID pandemic, astronauts have always been put into some kind of pre-flight quarantine to keep them from carrying any pathogens up to the International Space Station. But particularly in the age of COVID, we do not want this new virus making it off the ground and into space. One correction from earlier, that was not today's Air Force One flyover that we showed you. That was footage from Wednesday. Apparently there will not be a flyover today. The President and the First Lady are coming in via Air Force One, but there won't be the same kind of flyover for the press and the spectators. The crew plugged in their environmental control systems from their spacesuits into a similar environmental system in the Tesla on the way out to the launch pad. We are told they listened to a mixtape on the way out that included the Blues Brothers, AC/DC, and the Star Spangled Banner to get them in the mood for this most American of missions, the first time American astronauts will be launching aboard an American rocket from American soil since July of 2011, when the shuttle Atlantis made the final trip to the into orbit to service the International Space Station. We are now at T-minus 51 minutes and 55 seconds, and we just got word from NASA that the escape system, the rockets that would pull the spacecraft away from an exploding Falcon 9 in the event of an emergency, are being armed, which is a good sign. That means they are preparing for launch. Much more important, the fueling that will take place about 30 minutes before launch, loading on those 76,000 gallons of liquid oxygen and kerosene into the spacecraft, or into the rocket rather, are also on track to proceed on time. So these are both good signs. Again, we are still close to an hour away. Weather can do a lot of funky things in an hour, and we have no way of knowing with any certainty if this mission will get off on time. But those are two very promising signs that they are going ahead with these two very important milestones, arming the escape system and fueling the rocket in anticipation for launch.
To get into the White Room, which was the last place we saw them standing up before they climbed inside Dragon. And again, the wider shot there of Launch Complex 39A, where we are inside of an hour from liftoff, and I think we're just a couple minutes away from the pull we're going to hear before they start propellant load. Again, a two-stage rocket there. And gosh, you guys, the weather looks not that bad. I mean, obviously that is not an official forecast, but it doesn't look quite as bad as it did Wednesday. We've got a little bit better odds. So there's the countdown clock. We're going to pause to listen to that comm.
We've gotten a number of questions from viewers about how we keep space coronavirus free. An important lesson was learned in 1968 when the Apollo 7 astronauts all caught head colds on a miserable 11-day mission. COVID is much more serious than a head cold, but protocols that were put in place back then are still in place today to keep any spacecraft disease-free. So let's take a look at how space is being kept COVID-free in this time of pandemic. There's no better way to escape the coronavirus that's stalking the world than to leave the world altogether. Astronauts Bob Behnken and Doug Hurley will be doing that when they take off aboard a Crew Dragon spacecraft for a flight to the International Space Station. But before leaving, they had to ensure they weren't carrying the virus aloft with them. That meant quarantine, or crew health stabilization, as NASA calls it. For decades, NASA astronauts have quarantined before traveling to space, but that's not the way it always was. In the early days of the Mercury and Gemini programs, the idea of isolating the 1- and 2-man crews before flight was considered ill-advised and even impossible. There was just too much work for them to do to indulge any worries about colds and flus. All of that changed after the flight of Apollo 7, when astronauts Wally Schirra, Don Isley, and Walt Cunningham came down with severe head colds early in what turned out to be a miserable 11 days in space. By the time of the Apollo 8 lunar orbit mission, a 21-day pre-flight quarantine protocol was put into place. The crew was scheduled to launch December 21st, 1968, which should have meant quarantining from December 1st on. But President Lyndon Johnson had other ideas, and on the evening of December 9th, he held a dinner at the White House honoring the crew and the rest of NASA. That meant a late start on quarantining, with the 21 days cut to just 12. For the first 3 of the 6 successful lunar landing missions, Apollos 11, 12, and 14, there was not only a pre-flight quarantine, but 3 more weeks of isolation afterwards to ensure that the astronauts were not carrying any lunar pathogens back with them. By the time of Apollos 15, 16, and 17, NASA, reassured that lunar pathogens didn't exist in the first place, lifted the post-flight part of the lockdown. The 3 crews that flew to Skylab, America's first space station in the 1970s, had a longer 3-week pre-flight quarantine period in keeping with the longer stretch they'd be spending in space. The shuttle crews got a break. Just a week of pre-flight quarantine, 3 days spent at crew quarters at the Johnson Space Center in Houston, and 4 spent in similar accommodations at the Kennedy Space Center in Florida. With the coronavirus at large, Behnken and Hurley were assigned a longer 12-day quarantine period, 5 days in home isolation and 7 at Cape Canaveral. They and the few technicians and medical personnel who have come into contact with them during quarantine were also required to have 2 negative coronavirus tests in order for the crew to be certified fit to fly. Where humans go, at least some germs hitch a ride with us. The key is to ensure as few as possible accompany us to space. And here we are at last seeing that swing arm moving away from the spacecraft. Bob Behnken and Doug Hurley are now very much on their own, with the exception, of course, of the tens of millions of people in the world watching their mission and the hundreds and even thousands of controllers on the ground around the country and around the world who are helping to keep them safe. So in that sense, they are not at all alone, but physically they are there without their support team, without their White Room crew. It's just 2 men in that spacecraft getting ready to take off. We are now at T-minus 39 minutes and just 7 seconds. We are awaiting a shot of the presidential motorcade. The president and the first lady departed the White House at 12:10 p.m. today and arrived at the shuttle landing facility at 2:25, just 20 minutes ago. So they will be moving over to the operational support building next, where they will be, from which they'll be viewing the flight. Meantime, the skies continue to clear. The weather continues to look as if it is going to cooperate, and it only needs to cooperate for another 38 minutes and 25 seconds, after which Florida is free to do what Florida does, which is for the weather to become turbulent again. We just need these skies, these conditions to hold for now under 40 minutes. And as we see this rocket and the spacecraft on the launch pad, it's worth mentioning again just how extraordinarily well designed and engineered the machines are. The Falcon 9 rocket itself stands 229 feet tall. It's fueled by 9 Merlin engines using RP-1 rocket fuel, which sounds pretty glamorous, except RP-1 rocket fuel is pretty much just high-intensity kerosene, and that's mixed with liquid oxygen as the oxidizer. Each of the 9 engines produces 125,000 pounds of thrust for an overall 1.125 million pounds. The Falcon 9 first flew on June 4th, 2010. It's been an operational vehicle for a decade now. This will be the 84th launch of a Falcon 9, and significantly one of the things that distinguishes the Falcon 9 from virtually every other, or actually every other expendable rocket that does fly, is that when its first stage is spent, it's not simply dumped in the ocean as a use once and throw away piece of hardware. Instead, the first stage lands on a barge near the Space Center, and there have been so far 44 successful such landings, and 31 of these first stages have been successfully refurbished and reflown. The Dragon spacecraft itself that the astronauts will be flying in is sort of, think of it as the Apollo-era spacecraft on steroids. It's about as wide as the Apollo was, about 13 feet wide, but it's twice the height at 26.7 feet tall. It has significantly more habitable space than the Apollo did, which carried 3 men and something close to moderate comfort and moderate discomfort. This spacecraft is capable of carrying a crew of up to 7 men and women, although there will only be 2, obviously, this time. There are 16 thrusters arrayed around the spacecraft that allow it to perform the delicate choreographic maneuvers it will need to perform in order to dock with the International Space Station, to reorient itself for re-entry, and to do all of the other maneuvering that is necessary during space flight. There have been 22 launches of a Dragon spacecraft, the cargo version of a Dragon so far, and 21 visits to the International Space Station. It is almost all automatic. Obviously, the astronauts are highly trained in order to take over at any point. The instrument panels are all touch screens, very different from the mechanical toggle switches and dials of the old Apollo era. And the crew is perfectly capable, eminently capable of flying the spacecraft on their own if any of the automatic systems fail to work. When they come home, they will land under the power of 2 small drogue parachutes and 4 main chutes. The Dragon, like the first stage of the Falcon rocket, is reusable. This is all in an attempt to ensure that that prices can be kept down and assembly can be complete. And what we just saw here, what we're seeing here, is a test of the escape system that was conducted last year to prove that the Dragon could successfully separate from a rocket that was threatening to explode. So we're working with 2 reliable machines today, 2 machines that have a very proven track record. The one thing they have not done until today, we hope, is carry human beings, and we are inside of 33 minutes now until the point at which that important milestone may at last be crossed. The presidential motorcade is now approaching. We should be able to see that soon. The weather looks calm, as you can see from the inset image on the left. The sky is rather blue, and as you can see in the top right corner, that windsock, that orange windsock at the top of a light pole does not seem to be getting pushed by much wind at all. So we have what appear from these decidedly non-scientific measures here, clear skies and low winds, and this is what you would want to see. The president and the motorcade should be arriving momentarily around this bend that we can see in the image here. The president will view the launch. He will arrive just about 8 minutes before launch time at 3:25 for the, or rather at 3:17 for the 3:22 launch, and will then go to the vehicle assembly building at 5 p.m. to address NASA workers and a number of the people responsible for what we hope will be today's launch. You see the motorcade arriving now. This is part of a long tradition of presidents making sure that they are present either at launches or at recoveries in order. There's politics involved, certainly. There is nothing wrong with doing the touchdown dance when something momentous like this happens under your administration. But also all presidents, going back to President Eisenhower, who was the president who founded NASA, have known that space travel is as much about technology and exploration as it is about politics and funding. And it's important for presidents for any administration to be there, to wave the flag, to show the colors, to make it clear that they are behind this enterprise. Traveling in space is expensive. Traveling in space is dangerous. And it's important for presidents to show that they are in support of this program and that they are backing it. And President Trump is there very much today to enjoy what looks like it could be a successful launch, which is now just 29 minutes and 15 seconds away. And it appears as if fueling of the rocket has now begun. You can see some of that condensation from the liquid oxygen that is part of the fuel mix subliming out of the spacecraft. This is the first crewed launch that it uses what is known as the load and go process. Typically, the rocket is fully fueled, and only then does the crew climb aboard. That was considered a safer way to go. But with the design of the Falcon 9 rocket, the supercooled and highly condensed fuel cannot sit in the tanks too terribly long before it begins to lose its efficiency, at least its efficiency within the system as it's designed for the Falcon 9. And for that reason, the fuel is kept in the tanks for as short a time as possible. Consider this a little bit like when horses load into the gate in any horse race. Horses will not tolerate a gate very long, which means once they're there, the race is about to begin. Fuel in this rocket will not tolerate lying idle in a tank terribly long. That doesn't mean it's going to blow up. It just means it's going to lose some of its energy potential. And for that reason, once the fuel is in the rocket, it is going to go. The astronauts boarded so long ago, hours ago now, which is very much a part of the process. It takes a great deal of last-minute work to get environmental systems up, to get crew checklists gone through, to drill what the final maneuvers are going to be. Crews are very accustomed to spending time flat on their backs in their spacecraft. As Doug Hurley said in the earlier piece we saw in NASA, for his shuttle flights, he was accustomed to spending as much as 4 hours on his back. One thing about fueling, it's interesting to think, we think of rockets as great machines that happen to be filled then with fuel, much the way your car is, 95% the weight of the vehicle, and you add a few extra pounds when you fill your tank. A rocket is quite a different thing. A rocket is something like an egg, with the shell as the rocket itself actually the lightest part of the entire assembly. It's the fuel that weighs the most. A Saturn V rocket, unfueled, weighed about 1.5 million pounds. Fully fueled, it weighed 6.5 million pounds. So you had fuel weighing more than 3 times the weight of the rocket. Think of a rocket as an empty vessel that is a machine that is used to process the fuel that fills it. The load and go process is underway now. It should complete not long before launch. It does not take all that long to pump even 76,000 gallons of fuel into a 229-foot machine. So with this fueling coming, it means we are in the final stages, just 24 minutes and 40 seconds now away from launch. And we have a question from a viewer as to why the launch time is so precise, why we have what's called an instantaneous launch. You either launch at 3:22 or you don't launch at all. Why can't we push it 20 minutes? In fact, if you were launching into any old orbit with any old spacecraft, you could do that. It wouldn't make terribly much difference. But it's a very delicate ballet between the International Space Station, which is in a 51-degree orbit relative to the equator at 250 miles above Earth. It's a very delicate dance between that spacecraft and the Dragon, which will have to launch from 28 degrees, then quickly move to a 51-degree inclination, and then orbit the Earth 13 times in order to catch up with the space station, essentially to intersect the orbit. Think of it as a series of spirals. The Crew Dragon will launch, and it has to spiral out carefully until it reaches the space station's orbit. If you launch even a second or two too early or too late, you miss that intersection point. So basically, the Crew Dragon is aiming for where the space station will be 19 hours and a handful of minutes from right now. And you cannot miss that launch by more than a second or two, otherwise you will fall short of or fly wide of the space station. And it's worth reminding ourselves and it's worth reminding ourselves and our viewers one last time about what SpaceX had to do to get to this point. This is a momentous day for the for a private company launching astronauts, launching NASA astronauts, and they had to go through a great deal to ensure that their systems were reliable, that their hardware was reliable, and that they could get crews safely away from a rocket that was threatening to explode. The two great tests that they had to go through were the so-called pad abort test, when the spacecraft was on the launch pad and fired its escape engines to prove that it could get away from a rocket that was threatening to go awry. and later a launch abort test in which a Dragon crew vehicle was actually launched atop a Falcon 9 rocket, and the Falcon 9 rocket was deliberately destroyed. An instance before it was destroyed, the Dragon spacecraft was capable of firing its escape engines and taking the astronauts to safety in the event of any kind of such eventuality today. And here we're looking now at this pad abort test. This was a test. Those engines that took that spacecraft off the ground would be the ones that would pull it away from a faulty rocket should any kind of accident occur. It would separate from the service module and it would release its parachutes, and the astronauts would then descend safely into the ocean. This, of course, is one of the reasons also that Cape Canaveral is the place from which we launch. We launch east over the ocean, which means that any accidents with rockets will fall harmlessly into the ocean and not toward population centers. It's also the reason that Russia, which does not have the same access to the same kind of warm water coastline at a low latitude, launches from Baikonur, which is very much desert. Here it looks like we're looking at the launch abort test in which a Falcon 9 was launched and then deliberately destroyed. Let's see if that's indeed the footage we're watching. But this was one more test to prove that the spacecraft could get safely away from a rocket that was in distress. And yes, here we see the spacecraft separating. Under these circumstances, the onboard systems would have sensed that the rocket was in trouble. It would have gotten the astronauts away, and that explosion of the rocket would have happened far behind where the astronauts were. On earlier spacecraft, the Mercury and Apollo spacecraft, there were escape towers on the top of the spacecraft that would pull the spacecraft away from the rocket. On the Dragon, there are escape rockets at the base of the Dragon itself that push it away from a rocket in distress. Either way, it keeps the astronauts safe.
Stage 2 LOX load started.
And we see to the left here a lot of dignitaries on the balcony of the OSB building watching as the launch is about to take place. There are astronauts here. There are military folks here. General John Raymond, the head of the newly launched Space Force, is here. This is in lieu of the much more crowded viewing stands that would typically be the place from which launches were watched, but for the COVID pandemic. Of course, looking at this balcony, we're not seeing a whole lot of people wearing face masks. We're not seeing a whole lot of people socially distancing. This coronavirus may not be the immediate news of today, but if this launch goes successfully, in 13 minutes and 14 seconds, ignition will have happened. 12 minutes afterwards, the astronauts will be in orbit, and then all of us will have to go back to our everyday lives, which include the coronavirus. This should not be meant to diminish the success of today, but it is a reminder that we are about to achieve, it looks like we're about to achieve, may achieve something extraordinary in a time of extraordinary problems. And the launch will be a pleasant break from that, but it's a reminder also that we must continue to take the virus seriously. And if you're just joining us, we are now inside of 11 minutes to launch, T-minus 10 minutes and 54 seconds. The rocket is fueled, as you can see from the vapor subliming off the side of the rocket. That is the liquid oxygen. That is the super cold liquid oxygen. That is one of the two fuels that's used. Super cold cryogenics, liquid oxygen actually adds weight to a rocket, not simply because of the weight of the fuel. It actually causes the humid Florida air to condense against the side of the rocket and form a thin ice shell. The Saturn V, in the time it would sit on the launch pad, used to gain about 1,200 pounds just in ice forming on the side of the rocket. There's probably a little bit of that happening on the Falcon 9 rocket today. The fueling is complete. The astronauts are in what is effectively the terminal countdown now, just awaiting ignition and awaiting for the precise moment when the International Space Station, orbiting 250 miles above at about 17,150 miles an hour, moves into precisely the right position for the SpaceX Falcon 9 rocket to light its engines and begin what will be a 19-hour chase between the two astronauts in the Dragon and the station itself. That will culminate tomorrow morning, shortly before noon, in a docking at the station.
Know that we're with you. Have an amazing flight and enjoy those views of our beautiful planet.
Thanks, Jay. It is absolutely our honor to be part of this huge effort to get the United States back in the launch business. We'll talk to you for more, but thank you.
Copy all. Thanks for those words. and enjoy those views of our beautiful planet.
Starting TVC hydraulic press. Stage 1 and Stage 2 engine chill has started. Engine hydraulics at pressure.
And on the viewing stand, it's hard to see in the image we have, but President Trump and Vice President Pence are both there, along with NASA Administrator Jim Bridenstine. It's unclear if Elon Musk, head of SpaceX, is with them, but the President and Vice President are present. The First Lady is there as well, and Jim Bridenstine, a former congressman, appointed as NASA Administrator by President Trump in 2017, replacing previous Administrator Charlie Bolden. It is Administrator Bridenstine who has been charged now with the job of overseeing the Commercial Crew program, as well as the much more ambitious Artemis program, which is intended to land the first woman and the next man on the surface of the moon in 2024. But today their minds are less on the moon and more on this immediate launch, which is now inside of just 4 minutes away.
Vehicle tanks pressing for strong back retract. Strong back retract has started. Stage 2, RP1 bleed. Stage 1, RP1 bleed. AFTS final setup started. MVAC igniter purges. Pogo bleed. Dragon has transitioned to terminal count and is on internal power. Stage 1, LOX load close out. Vehicle is transitioning to internal power. Stage 2, LOX load is closed out. Propellant fills are complete. Dragon is in auto idle.
Ground gas closeouts is starting.
Falcon 9 is in startup. Dragon is in countdown. FTS is armed for launch. Dragon, SpaceX, go for launch.
SpaceX Dragon, we're go for launch. Let's light this candle.
T-minus 30 seconds.
Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
Vehicle pitching downrange.
1 Alpha.
Copy, 1 Alpha.
Stage 1 propulsion is nominal.
Falcon power and telemetry nominal. M1D throttle down.
Vehicle is supersonic.
M1D throttle up.
Max Q.
1 Bravo.
Copy, 1 Bravo.
Start of MVAC engine chill. M1D throttle down. Eco.
2 Alpha.
Falcon stage separation confirmed.
Copy, 2 Alpha.
MVAC ignition.
Acquisition of signal lofts.
Stage 2 propulsion is nominal.
Dragon SpaceX, nominal trajectory.
And we have seen now
Signal Bermuda.
the
SpaceX Dragon, nominal trajectory.
we've seen separation of the first stage booster, which should now be on its way to recovery on the ocean barge for reuse. On the left, we're seeing a view inside the spacecraft. To the right, we're seeing, looking back toward the end of the spacecraft,
propulsion is still nominal.
the tail end of the spacecraft, as that second stage engine continues propelling the astronauts to space. They are in a much smaller and much lighter vehicle than they were when they left the ground. The first stage is now gone. What is happening now is all about increasing acceleration. The crew is going to feel a maximum of 3 Gs on this flight, which is not terrible to the average person. That would be quite a lot. The average 150-pound person would feel like he or she weighed 450 pounds, but these astronauts are accustomed to eating 8 and 9 Gs in a simulator. What we should be seeing on the right now is a scene from the first stage, which is descending from midway toward space back toward the ocean. That appears to be what we are seeing. To the left is the view that you would see if you were behind Bob Behnken and Doug Hurley, looking toward the instrument panel and the windows in the front of the spacecraft. The first stage on the right is in something close to controlled freefall now. It will not reignite its engines for landing until it gets closer to the ground. But attitude control thrusters along the flank of the booster keep it aligned and keep it
SpaceX, nominal trajectory.
keep it moving steady. When you hear nominal trajectory, that is all good news. Nominal in this case means exactly as you want it to be. On the right, you can see the thrusters now beginning to fire on that first stage as it slowly descends toward Earth. It is falling at a speed at this point, of course, that would not allow it to survive reentry, but it will.
Stage 2 propulsion is still good.
It will reignite its engines. S2 propulsion, as they just said, that's stage 2 propulsion. That means the second stage.
SpaceX nominal trajectory.
That means the second stage of the rocket is still proceeding to fire.
Nominal trajectory.
Hey, John, not the PTZ.
Acquisition of signal, New Hampshire.
Stage 2 FTS is saved.
And now we can see those first stage engines have reignited as the first stage descends toward its landing barge. It is just about to penetrate through the cloud tops, and landing on the barge should be less than a minute away, though it's a little hard to tell from this perspective. It all depends on the exact height of that cloud
Terminal
ceiling.
guidance.
And back throttle step.
Shannon.
Copy, Shannon.
And back throttle step. And back shutdown.
Dragon SpaceX nominal orbital insertion.
Launch escape system is disarmed.
Dragon copies. Nominal orbital insertion.
Those are some sweet words, nominal orbital insertion. The Dragon spacecraft is in orbit. Unfortunately, the signal, then we are seeing on the left that not only is the Dragon spacecraft in orbit, but the first stage of the rocket has successfully landed on
Acquisition of signal, Newfoundland.
has successfully landed on the barge that is playfully named, Of Course I Still Love You, welcoming the first stage back. The crew is in orbit. The first stage is recovered. The first launch from American soil in an American spacecraft with American astronauts since 2011 has now placed those astronauts in orbit.
loss of signal, Wallops.
And at this point, what we are seeing is a surprisingly controlled mission control room
Dragon separation
and in Hawthorne, California, where the flight controllers seem relatively calm given the enormity of what they've just accomplished. Separation of the lower stage of the second stage engine of the spacecraft is now complete. The Dragon is independently in
Dragon
orbit.
SpaceX, with that separation call, we have a few words for you from our Falcon 9 team.
Let's listen in on this.
Dragon, Chief Engineer on Dragon to Ground. Bob Doug, on behalf of the entire launch team, thanks for flying with Falcon 9 today. We hope you enjoyed the ride and wish you a great mission.
Well, congratulations to you and the F9 team for the first human ride for Falcon 9, and it was incredible. Appreciate all the hard work, and thanks for the great ride to space.
Copy all.
Power and light. Proud of you guys and the rest of the team. Thank you so much for what you've done for us today, putting America back into low Earth orbit from the Florida coast.
Copy all. Good luck and Godspeed.
So the work has been
Dragon
done.
SpaceX, we confirm nominal
The launch has been completed.
America
has rejoined the ranks of spacefaring nations, launching from its own soil, its own astronauts, its own rockets. We will be returning now to the NASA feed, direct for about another 15 or so minutes. This is Time Magazine reporting from Kennedy Space Center in Florida and the Time headquarters in New York City. We have witnessed history today, and we've witnessed a return to America as a leader in the world of spacefaring nations.
Environmental control and life support system. That's everything controlling their atmosphere, just keeping Dragon a nice, safe, habitable environment where they're going to be living for the next 19 hours until they arrive at the space station.
Right, exactly. And Falcon 9's job may be done for today, but the mission is not over. Crew Dragon's job is not done. As you can see, Bob and Doug are still inside Crew Dragon, making their way. It will be a 19-hour trip to the International Space Station before they dock tomorrow morning. And such cool views. I love that we can get these live views here and see and watch what they're doing now that they are in orbit.
Yeah, it's incredible to just be looking over their shoulder, to be along for the ride. And we're going to be with them, and we're going to be with all of you the entire way for their journey to the space station. We're going to be covering live throughout. Bob and Doug will obviously have a sleep period where they'll get about 8 hours of sleep a little bit later today before they wake up for all of their final approach. One of the major things we are looking forward to in the next couple of hours is going to be their first turn at the controls. So they're actually going to be using those touchscreen displays to take control and manually pilot Dragon. We'll walk you through what that's going to look like, and assuming we have some good ground station coverage, we'll be able to get views from right inside Dragon, looking over their shoulder as they manipulate the controls at the display. But I mean, we had a smooth ride uphill, both stages of the Falcon 9 doing their job, placing Bob and Doug into orbit. I mean, this is a day, this is a historical day. This is us kicking off that new era of space flight that we've all been talking about and longing for since the Space Shuttle program came to an end in 2011.
Yes.
And the weather cooperated.
Yes, second time's a charm.
Right.
All right, so day for the history books. As you can see, we have lost some live signal there, but the mission still continues, and we're going to send it over to KSC to continue broadcasting live with you.
Expected loss of signal, Newfoundland.
pressure looks good. Toggling up. Roger roll, Atlantis.
Water towers can fly! Yes!
Tango Delta nominal. Flight outside SC off. Say again, SC off.
Yikes. You bet. Concur. We don't need any more of these.
You know it's a special day when we go live early. It is time for SpaceX to launch the Crew 6 mission to the International Space Station, and we are watching a Falcon 9 on pad 39A, which will launch in, just under 4 hours now. We will make sure until this countdown reaches its 0 time, we will answer all of your questions until then and cover everything you need to see and know before the crew will reach orbit. My name is Adrian Bile for NSF, and I'm your host today, and I'm here in the studio together with Alicia. Alicia, how are you doing?
Thrilled to be here with you guys. Super excited for Crew 6, especially the 3 first-timers on board. And hello to everyone tuning in tonight, especially those of you who maybe it's your very first launch. Welcome. Thank you for joining us.
And we sure have everybody on board for today's launch, because we are not only here in the studio with 2 people, but we also have Mr. Michael Baylor in the background, making sure that everything here is properly covered and we see all the amazing scenes today. So hello, Michael. We also have Kevin Michael Reed in the background, who's also doing that. So we have 2 people here on deck for all the producing and directing. And then we have loads of people in the field. I will start with Mr. Thomas Burkhardt. Thomas, how is Florida?
Oh, it's a beautiful Florida night here, Adrian. Thanks. I'm actually here outside the Neil Armstrong Operations and Checkout Building, where we are awaiting those 4 astronauts to come out from their crew quarters after completing their suit-up procedures and get ready to board some Teslas and make the ride over to pad 39A. So that's where I am starting my evening, and we're looking forward to the launch later tonight.
Yeah, you really see, like, we will cover every angle we can cover, and you will not miss anything here. We also have in the field Chris Gebhardt. Chris, how are you doing?
I am doing just fine, getting ready to watch Steve, Woody, Sultan, and Andre go to space tonight. Very good night.
There we go. And I don't want to miss more people we have in the field here as well. We have in the field as well Julia Bergeron, who will make photographs for this launch, as well as Sawyer Rosenstein, who's in the field for us. And we have also Steve in the field. So we have, like, I feel like the whole Florida team basically is at the launch. So definitely an interesting and exciting day. And before we start to answer your questions, I want to throw it to Chris Gebhardt. Chris, do you mind giving us a mission overview of what we will see today?
Not at all, because today is the start of a 6-month-long journey to the International Space Station for the Crew 6 astronauts. So today we will see Steve Bowen, Woody Hoberg, Sultan Al-Niadi, and Andre Fedyevi go in, board their Dragon Endeavour capsule and head up toward the International Space Station. Overall, the journey to the station will take approximately 1 day, with a rendezvous and docking on the 28th, with a liftoff on the 27th. And they will then spend about 6 months aboard the International Space Station. They will have about a week handover with the Crew 5 folks before Crew 5 returns. And then everything is for Crew 6, including all the science experiments that will take us out through roughly the September timeframe on board the station. Not exactly the plan that it was, but this is the only early 2023 crew rotation flight to the International Space Station. It was supposed to be 2. There was supposed to be a crewed Soyuz MS-23 vehicle that was to launch 3 new crew members up to the station, but that one ended up launching uncrewed a bit earlier this week to replace the Soyuz MS-22, which sprung a leak. So only 4 people being rotated off the International Space Station the first part of 2023, and the Soyuz crew will stay for a full year, departing in the September timeframe. So overall, that's a brief overview of the mission, but some pretty important points for this flight. One, it is a new booster. It is B-1078 making its first flight, but it is not the first flight for the capsule. This is Endeavour's fourth flight, the leader for the Crew Dragon fleet. Endeavour previously flew Demo 2, Crew 2, and Axiom 1 up to the International Space Station and is ready to go again. But also, this is Crew 6, which means it is the 6th post-certification mission for Dragon, which means this is the completion of the original crew rotation contract with SpaceX and NASA. There are many flights that have been added to it as part of a contract extension, but Crew 6 is technically the end of the very first contract for crew rotation that SpaceX had with NASA. So overall, a big night.
There we go. And during this big night, make sure to tag at NASA Spaceflight in chat if you have questions. We will make sure to answer everything we can during the next 3.5 hours. So you will for sure have some time to ask us questions here. And before we do that and start answering questions, I want to throw it to Alicia for some science overview of this mission. Do you mind giving us an overview of the science that will be conducted by the Crew 6 mission?
Absolutely. So, these crewed missions are always so great. There's so much science that they take up with them in their payload. And, just being up there for 6 months allows them to do so much. So, Crew 6 in particular is going to be doing actually 222 experiments. They'll be specifically conducting a ton of human research programs focusing on astronaut health risks. So things like altered immune systems while they're in space. One of those things, previously, the European Space Agency's immunity assay tested immune functions. So they would test them before and after a flight. But now they actually have a special newly designed assay tube that will allow them to do those tests while they're in flight. So that'll help to provide a bit more clarity for scientists just moving forward, how to best counteract some of those immune deficiency changes while in space. They're also going to be studying dietary things. Woody Hoberg actually mentioned he'll be eating a modified diet with more fish than usual, extra lycopene. That's a compound that's found in a lot of red fruits and vegetables. So essentially the pigment that, dyes your utensils in the kitchen orange, when you have tomato sauce, that stuff. They're also going to be doing spaceflight associated neuroocular syndrome tests. So that's an eye safety investigation, since astronauts, when they're in microgravity, their eye pressure is always something that's of concern. Also, vascular aging, looking at how spaceflight affects the vascular system. And something that's really exciting is they're going to be expanding on some experiments with these things called tissue chips, which are these small bioengineered devices that mimic the function of human organs in a 3D matrix. So things like the heart, the brain, the cartilage functions while they're on the space station. So scientists can effectively model changes in organs that occur really over time spans of months or years while they're in space, and then test them and how they react to treatments. So two in particular they'll be looking at now are something called the Cardinal Heart 2.0. So that'll be testing certain drugs to prevent changes in heart cell function and gene expression throughout spaceflight. So looking at, possible drugs to treat patients with heart-related diseases, and also the Engineered Heart Tissues 2 test that will test for therapies that prevent space-induced changes in the heart tissue. So things that could potentially lead to cardiac disease. So again, things that are helpful here on Earth as well. And then they'll also be really, burning up the space station. They're conducting some fire safety investigations. So a continuation of some combustion research where they use the solid fuel ignition and extinction hardware insert, or SOFI, for the station's combustion integrated rack. Some new experiments that'll be burning solid fuel under relevant conditions like that to test how they can actually extinguish some spacecraft fires and also clean up those materials afterwards. That's important because they'll be looking at the flammability of materials used for projects and equipment in the future for space missions. And then also another experience that I think is fascinating, they are going to be taking a look at the effect of human space missions on the space environment itself. So near the end of the Crew 6 mission, they're planning to do some EVAs, some spacewalks. And while they're there, they're actually going to be swabbing the outside of the space station near some of the life support system vents, and they'll be looking for microbial life. So, bacteria, fungus, and whatnot, just to see if the ISS is actually releasing some of these microorganisms into space, and if so, how far they might travel. So the samples, once they return them to Earth, they'll be doing some DNA sequencing and some multigene analysis. And this is important for planetary protection and really to limit some potential contamination from Earth when we go on to visit places like the Moon and Mars. And actually, they specifically even cited Jupiter's moon Europa, which, hey, so that's really going to allow us to study more of these extremophiles, these microorganisms that are able to exist in the harshest of environments that we previously thought weren't even possible. So yeah, a lot of really cool science experiments coming up on this one for sure.
Thank you for that overview, and I can tease that we will have an interview at a later time, which will also go a bit more in the science side of this mission. So stay tuned for that as well. Certainly lots of love for the science here on the broadcast today. And I want to start with some questions here. And we will start with a question about the crew capsule here today, which is how many Dragon V2s are there at this point, and are there plans to build more? Also, are there any operational Dragon V1s still? Chris, do you mind taking that question?
Not at all. I'll take the second part of it first. There are no Dragon V1s still in operation. That line has been retired of the cargo crafts. In terms of the Dragon V2s, there are 4 crew vehicles, Endeavor, Resilience, Freedom, and oh boy, Endurance. There we go. And then there are 3 or 4 cargo capsules that go up to the International Space Station. Right now, the capsules are designed for 5 flights for certification, but SpaceX wants to get each of them and sees a path to get each of them up to 15 flights for certified use of each individual capsule. And there is word that there is a 5th capsule that is on the way. SpaceX originally was going to build 5, then they said no, 4 is enough, and word on the street is that they will in fact build a 5th as well.
There we go. Then we have a question here about the UAE astronaut Al Yanadi. Hey, NASA Spaceflight, will the UAE astronaut be doing some spacewalks with the NASA astronaut? Alicia, is it already known who will conduct the EVAs for this mission?
Not sure specifically who's going to be assigned to those just yet. If anyone else knows that, you can chime in, I guess. But he's definitely going to be doing a lot of the experiments with them throughout it. They've all been training together, for quite some time, years now, in order to do all of these together. But I know that's kind of going to be something that's slated a little later on while they're up there.
There we go.
And there's some wiggle room for EVA assignments. If it's very specific tasks, like you're going out and you're installing a new solar array, they usually train for that pretty extensively on the ground with both extravehicular activity folks, so the 2 people who actually go outside, and the IVA or intravehicular person who coordinates between the ground and the crew outside while doing that. But there is a bit of cross training just in case, like if someone pulls a muscle or strains something up there during exercise and they can't go out the hatch to do the airlock, sometimes it's better to just swap out the crew member and go anyway and do
And
it.
Chris,
So, yeah.
Chris, funny you should mention that, because that's something that they are planning to do. Later on, they're going to be getting some ISS rollout solar arrays, the IROSAs,
Yep.
and they will be upgrading those on the space station and be doing those EVAs to install them. I think specifically the ones who I've been hearing talking about it the most are Steve Bowen, the commander, and Woody Hoberg, the pilot.
Yeah.
And if we can now see the new black crew Teslas that are standing here. So just for a reminder, in the previous missions we had the white ones here, so apparently they changed them. I do not believe we know why exactly they changed them, but yeah, new crew vehicles. And they are waiting there, and Thomas is standing by to watch the crew walk out as soon as it happens.
I can report that they also have a new license plate reference on the back, so as they drive by, we'll have to keep an eye out for that, I think.
So you have not seen yet exactly what the license plate says?
No, I have, but I think those who are watching the live stream have to stay tuned and find out.
Oh, very good. Very
Ooh,
good point.
Surprise reveal.
So I'm looking forward to see what kind of wording we have on the license plate again. But they look cool. I like them. I'm really looking forward to see them walk out soon. There's a question here by Travis, which I want to throw over to Chris G, which gives us the opportunity to talk about launch windows to the ISS. Why so early?
No one has any control over it. So the way you launch to the International Space Station is so from Florida and from Russia and from Japan. This actually all works the same way for the three nations that do launch their own stuff up to it. There's only one trajectory you can go because in Florida you have to go northeast. You can't go southeast because of Bahamas land overflight. In Russia, you also have to go northeast because you can't overfly China and Mongolia. And in Japan, you can only go southeast because you can't go northeast for land overflight of that country. So that gives you the trajectory you have to go out on. And then the ISS's trajectory, when it passes over your launch site, it passes over twice a day, once going northeast and once going southeast. But you have to align your launch time to that moment. And for February 27th, 2023, from the Kennedy Space Center, that is 1:45 and 3 seconds for the Falcon 9 local time, and that is your liftoff time.
There we go. So it's not to make sure that we all get the minimum amount of sleep. It's just how it is. I believe you can see some footage of the suit up of the crew right now.
Yeah, that was Andrei Fedyaev, who we saw first there, the Russian cosmonaut on this particular flight and mission specialist number 2 for the mission.
There we go. It's certainly a very international mission with three nations involved here. So yeah, we might be very soon to the crew walkout here. Getting certainly very close. And let's try to hit some more questions before that. But another question here is, how do the crew keep themselves entertained on a long trip to the station? Space Netflix. Alicia, would you have trouble to keep yourself entertained in space?
Oh my God. If I was in one of those capsules, I would be entertained every freaking second of that entire mission. Are you kidding me? I'd love to go into space. But, it's funny. I remember when we were watching the Crew 5 one, who's it? Anna Kakina, I believe, was going in there. And didn't it look like she was falling asleep? And she slept through the whole thing. She was so chill about it. I would imagine, though, riding on top of a Falcon 9, that'd wake you up pretty fast. So no, I mean, it's a while, but it's not that long of a trip. So I don't know. Maybe they sing songs. Who knows?
I feel like the part of the mission that'll get you is the couple hours you get to sit on the pad. Because once you board, there's all that time built into for any troubleshooting and stuff like that. And if there's no troubleshooting, you are just kind of sitting there for a couple hours, and before the rocket's even propeller loading or anything like that. So I feel like that's the minute that gets you, and you might actually fall asleep.
And
shuttle astronauts on the mid deck used to fall asleep because they were passengers along for the ride and had nothing to do. And you can hear in some of the comm loops too, the pilot and the commander would jokingly call down, "Y'all awake down there?" At 5 minutes to go. Yeah.
The worst seat on the shuttle. Oh man.
No windows. I know.
Oh.
Sounds like my day at work.
But to answer your question about entertainment, the personalized iPads that they take up with them on the Dragons have loaded entertainment. For example, Chris Sembrowski, who was part of the Inspiration 4 mission for SpaceX and Dragon, was watching Spaceballs as they were preparing for reentry. So there is entertainment baked into their personal iPads that they take with them. Yes.
And we're getting a very ominous zoom here right now on the walkout door. So I'm not sure if that is a sign of imminent happening, but we got a zoom. So
it's a sign that things are near. Yes.
Yes. It was a very slow zoom to the door. So it's this has some hype generating here right now. So we might be very, very close here. And of course, this is always exciting part of the crew launches, because this is not something we usually get on any other Falcon 9 mission, of course. So this is the reason why we go live at 4 hours and not 45 minutes, because there's a lot to talk about during this.
Here they come.
And here they come.
Yes.
So that's Woody on the left, Steve on the right, up front, and behind Steve is Sultan Al-Niadi, and then behind Woody there is Andre from Roscosmos.
Core on countdown. About to step into crew walkout. We remain on schedule.
And there was just a call out there. They remain on schedule for now, which is good to hear. But they of course have some wiggle room in the schedule as well, so they can sometimes gain time. We saw that before, that sometimes they are able to gain some time or have some extra wiggle room to catch up on time if they, for example, have to leak check a little more longer or something like that. Okay. So I don't know the exact anatomy of this building, I have to admit here. They're taking an elevator down, I would imagine.
Yes. So the crew quarters are on one of the upper levels of this building. It's not a very tall building. It's like 3-4 stories total. Not very big, but this is. But they take the elevator down to the bottom floor there, and then there's a little bit of a hallway that they go down, and then they emerge in the very famous image that we see from that doorway.
Hey. Nice.
With the 6. I love that.
Love it. Huh.
That's a neat little idea. So will they change it for every mission now? They have to, right?
Well, they've been changing them for every mission, to be fair.
Oh.
Have they? Oh.
Yeah, like some of the ones said later Earth, Earth or bust. Some of them said, the license plates have been different.
I love that.
Oh, I wonder who picks them. It's like SpaceX doing the jokes and plates, or is it like the astronauts who ask like, "Hey, what do you Tesla?"
It's a good question. Yeah.
I'm actually curious, but I don't know.
Good.
But here we have the families, right, standing by to say a goodbye to their family members before they fly, and I believe
indeed
they're standing in front of the door.
Yep, they're just behind the doors. You can see them in there. And you can see the armored personnel carrier behind there, the security for them today.
There's also some press there. We see a lot of people standing behind the barricades. Try to spot
Very
Thomas.
I know, he's somewhere behind one of those barricades, isn't he?
Yeah, like trying to find Thomas is can be a game here, I feel like. But I have not been able to find Thomas yet. Let's hit one more question since it's related to what is happening here. Why do astronauts actually load so early into their capsules? So Alicia, why are they already going to the capsule this early?
There's so many tests that they have to do. They got to get them all strapped in. They got to get them all safe. They got to seal it up. And then there's just a whole long list of checks that they have to do, technical checks to make sure everything is safe for them to actually light it and send it. It takes a while. And, there's always that funny story, with Alan Shepard. He was up there in his capsule. It took so long, and there they come. He ended up having to pee himself.
Oh, they look all excited.
Well, for 3 of them, it's their first time.
Yeah, I would be excited if I could.
Steve is the only veteran of the flight, the commander, yeah.
Steve's probably like, oh, I'm chill about this. I did this before.
He's done it 3 times before, yeah.
I would imagine it would be such a mix of emotions. They've gone through so much training that it's muscle memory, I feel like, at this point. But also it's real finally. These people have been training for years. Andrei, actually, Fedyaev, he was selected in 2012. It's been over 10 years that he's been waiting to fly.
Versus Sultan, who was selected in 2018 as one of the first 2 Emirati astronauts as part of their astronaut corps. Yeah.
So yeah, it's also I feel like this is maybe like one of the emotional moments of this countdown for them, since this is really like the saying goodbye for the moment to their families and also friends. So yeah, I feel like this after that it maybe get for them a bit more operational. They're more in the flow, but this is more a private moment, a more a family interaction moment.
Exactly. Exactly, and I really appreciate the new sort of tradition that has been started here, because the Apollo and the shuttle crews never had their families right there where they were stopping and talking to them, right? They kind of came out, they waved, they did a little photo op, and then they immediately got in the vans to go out to the pad. So taking this moment of seeing the crews talk to their families, talk to their loved ones, and then seeing those people go to the windows of the cars and the Teslas and say that goodbye to them, it really reinforces their whole entire reason why this happens. And you can see Hazza Al-Mansouri there on the left and Shannon Walker there on the right. Hazza was the first Emirati astronaut in 2019 on Soyuz MS-15, and Shannon Walker was part of the Crew 1 mission to the International Space Station.
Looks like
there's Steve, our commander today.
It looks like Steve will be in the first Tesla, if I see this correctly.
Pilot and commander are usually in the first one, and mission specialists are in the second one.
There we go. Just for orientation here, for folks who keep track of who's where.
Yes, indeed.
So is there a scheduled time when they will start to drive to the pad?
Yeah,
Here.
so they stay out here for about 5-ish minutes, and then they head out to the pad. The timing is fairly sequenced, but there is like a little wiggle room. Like if they're a minute early or a minute late leaving the O&C, it's not like, oh my gosh, we're gonna blow the timeline or anything like that. There is some wiggle room built in here. So yeah, they'll stay out here for about 5 minutes total, and then the cars will depart.
And I believe you just saw a SpaceX personnel telling them,
yes,
it is time to board the Teslas now.
Well, and you can see Woody and Andre getting in. We can see Andre getting into the Tesla on the left. Woody just went behind to get into the first one. Steve's now in, as is Sultan. So all going well here for their trip to the launch pad.
Yeah.
Those new black Teslas are so cool.
I know, right?
Oh my God.
They had to match the ninjas.
Yes. Oh my gosh, they do.
It's really it feels more fitting. Also, I feel like the suits are more popping out now with the deck contrast now. So I like that. Yeah. And the wing doors are closing. So yeah.
And then you can see the families going up to the cars now. The continuation of that new tradition.
And core on countdown displays are configured for crew ingress.
And you can hear that call continuing to configure Dragon for the crew's overall arrival and ingress here. So teams equally working at the launch pad, continuing Dragon preparations as the crew is about to depart. So this is about a 20-minute drive from the ONC out to Launch Complex 39A. They will come up State Road 3 and then up to the Vehicle Assembly Building and then out to the Kennedy Parkway to Pad 39A. So all told, about a 20-minute drive here for them.
Quick question to Thomas. Do you wear a white shirt? I believe he cannot answer it right now. But I believe
yes.
Okay, then I saw you. One to spot the Thomas game.
And you can see that's Andre's kids and wife there talking to him, and then you can see Steve's family talking to him in Tesla number 1.
It's really like, and once that they start to drive, how long is it to 39A actually? How long is the drive?
20 minutes.
There we go.
Core on countdown, advanced team complete, ready for crew arrival.
And you can hear that Dragon is ready for the crew. And families are leaving, so they will be on their way to the pad momentarily.
It's time to go. I believe that's also a real cool moment to drive on the pad and slowly start to see the rocket.
And there they go, on their way out to the launch pad. So you'll see several vehicles in front of them, the beginning part of the security escort, and then you will see a bunch of other armored carriers and military vehicles behind them, protecting them for the first part of the drive out to the launch pad. The Teslas, however, are the ones that will actually make the full and complete drive. As they continue on their way, the other vehicles will eventually peel off and not make the complete drive up the ramp with them.
Oh, I think we have a POV of one of the cars
POV,
there.
like that.
That was interesting.
Yep, that's totally the lead Tesla with the camera up front.
Just for the people that usually watching our Starship streams, this blue and red light in this case is not a road closure for testing.
Well, it is a road closure, but
this road is certainly closed.
Yes. Oh, and you can see the helicopter as well. They're flying overhead as they head on out to the launch pad.
And I believe it is time to give some overview of the crew that is on board today. So let's start with Stephen Bowen, actually, who is the first submarine officer to be selected as an astronaut. He flew on STS-126, STS-132, and STS-133. And I believe the STS-126 mission was part of the assembly of the International Space Station.
They all were, yeah.
Yeah, and he did so far only 40 days in space. It was fairly short duration missions for his previous. So this is like his first real long-term duration mission, right, Chris?
Yes. So all of his previous shuttle missions were up and down, about roughly 2-week flights. So this is his first long-duration stay in space. And what is interesting about Steve Bowen as well is that his third flight on 133 was not supposed to happen. He was a last-minute replacement for Tim Copra, who was injured in a bicycle accident just weeks before the delayed launch of 133, and he was unable to fly because of that injury. So they needed someone who still had training and was still up to date on everything. And that was Steve, who had flown the previous mission, 132, and he therefore became the only person in NASA history to fly back-to-back crew flights.
There we go. Quite definitely a commander of this mission with a lot of experience and history in spaceflight. And of course, it's always good to have a Chris on the webcast if you talk about the shuttle. So,
and this is actually good. You can see they are on the on-ramp now to State Road 3. So they are en route heading for the VAB. In fact, you can see the VAB in the dash cam there in the distance. So they are on State Road 3 and headed for my camera right now. And of course, someone has come to stand directly in front of it.
Is that a direct call out of them so they might move?
I'm going to say that. Let me mute myself real quick.
Let's get a big stick and start poking him.
Yeah, basically like a selfie stick. Like, sorry,
Yeah.
This is a camera.
Yeah.
Hey, you see them going down that pathway.
Yeah.
Let's move on to Warren Hoberg, also called Woody, who reported for duty in August 27 as part of the 27 astronaut candidate class. He has a degree in aeronautics and astronautics from MIT. He also has a doctorate in electrical engineering and computer science. And he is a rookie, as you can see, 0 days in space so far. So that will increase quite a lot today, by kind of infinity, you could say.
Yes, it will be exponential growth, yes.
And let's go to the next rookie. So from here on out, we only have rookies here. Let's move on to Mission Specialist Sultan Al Nayadi from the United Arab Emirates. He's also a rookie on this mission, and the second astronaut from the United Arab Emirates. My God, I can talk today. Arab Emirates that will go to space, right?
Yes. So Sultan was one of 2 original astronaut corps members for the United Arab Emirates, along with Hazal al-Mansouri. Mansouri flew first on Soyuz MS-15, and Sultan al-Niadi will be the second, but not the last, because later this year on Axiom 2, we have 2 more Emirati astronauts who will be flying, and they are both from the second group that was selected for that. So the UAE is really making a name for itself. And they are really an agency to watch because not only are they getting long duration missions to the International Space Station without being one of the major partners, they are also getting 2 seats on the next Axiom mission, and they have stepped up to be a partner in the Gateway module, working with Northrop Grumman to develop one of the primary modules for the Gateway. So the UAE is really an agency to watch because they emerged onto the scene and have not stopped and really truly want to be a part of everything that is going on, and really good to see them represented on this flight as well, because it is the first long duration mission of the Arab world into space. So that is very important for all of them as well.
Yeah, certainly also making use of Crew Dragon, because 3 of the astronauts will then fly on Crew Dragon, right? So there's certainly usage of that new capabilities that come with that. And last but not least, we have mission specialist Andre.
I see them. Keep talking. I see the convoy starting to arrive, though.
Andrei Fedeyayev, who is from Roscosmos and will be a mission specialist on this mission. And as we said before, another rookie on this mission. So yeah, certainly a lot of experience to gain on this mission, right, Elysia?
And today is actually his birthday. Also, we should say happy birthday to him.
Yes, his
Happy
42nd birthday. To be fair.
There will be a special candle for him.
Oh yeah.
Although technically his birthday ends an hour and 45 minutes before he lifts off, but I think we'll give it to him.
Yeah, belated birthday present. Why not?
And there's some helicopter action.
The helicopter is going overhead as the crew continues to arrive, passing the vehicle assembly building on their way out to the pad.
So they are very close to you right now, right?
Very close, yes.
I believe that's your camera, right?
This is my camera, yes.
Hello, there they come. Quite a convoy of cars.
Yes, indeed. A convoy it is.
Is there a assigned function to each of these vehicles, or most of them are just protection?
There are assigned functions to each of them, yes.
Oh, there's I believe the Space Coast Live VAB shot, or as some might say, VAB. They're not driving slow.
No, they don't. They do not drive slow.
It looks a bit slower at first, but then you notice in some of these shots, they're like, oh no, they're speeding.
To be.
I hope there's no speeding tickets on the way. That would be an unfortunate one. Yeah. Let's use this moment right now to hit some of you super chats. As you know, we are really thankful for these super chats as they allow us to do these marathon coverages and have all of these cameras at different places. So I want to make sure to thank all of the people that support us that way. I want to start with Nikki the Nozzle for gifting a Red Team membership. Thank you so much, Nikki, and congrats to the person who received that Red Team membership through that way. Musical Wolves, what are the Tesla license plates today? I believe we saw them, so yeah, there you go. There you have the answer. And then we have Guara Yoshi with, I think that's 40 Indian. I want to make sure I get the currency right here. It's Indian rupee, I believe. So thank you for that. When S24 will get pet, or when Polaris Dawn will go? I believe the question is what will go first, and I believe the answer right now is probably ship 24, as Polaris recently confirmed they will, I think, go in the summer. So that's most likely ship 24. Ninja Decimator, I always love that name when it appears up. $4.99 for the caffeine fund for watching long. Thanks for the coverage. There is certainly caffeine needed for this one.
Yeah.
Yeah, I believe we talked about this earlier. It's kind of impressive how it makes both the Europeans and the Americans with this one sleepless. Man's on Mars with the $4.99. If you were hopping aboard this flight and tasked with picking the character stuffed animal to join you in 0G, what would it be? Oh, that's a good question. Do you have a preferred 0G indicator you would pick to space?
Yes, and it's not an animal. It would be a 0G indicator of the Starship Enterprise.
Oh, well, who was it? The guy that did the Star Trek I can't remember his name now. He actually brought little toys of the Enterprise on the shuttle and filmed it.
Sweet.
Oh, I have to look up what this guy's name was now. It's so funny. That was like a thing.
I know there was one astronaut in the early 90s who refused to refer to the flight decks of the shuttles as the flight deck and instead referred to them as the bridge. And I liked that. Yes.
Nice.
And I believe we do know what the 0G indicator of this mission will be. And I believe we even have a graphic of it. So there we go. That's the mascot Suhail. I'm sorry for the pronunciation. And that will be the 0G indicator for this mission. So we will see that flying around Crew Dragon very, very soon. And hopefully indicating 0G as they do. So there's that. Musical Wolves, another one. What are the odds the 0G indicator is a Kerbal? I'm sorry, the answer is, in this case, 0. Because we know the 0G indicator, and it's not a Kerbal.
They had one of those recently, too. Didn't they have a Kerbal as the 0G indicator a couple launches ago?
Now I'm questioning my memory.
It was the one... It was the one that had Rosie, I believe, which was the mannequin. Not the Moonikin. That was Artemis.
I always love the name Moonikin, though.